Welcome everybody, and we are really excited to spend the day with you. This is going to be an awesome workshop. We are AI Makerspace. We'll tell you a little bit about us in just a second. We are going to go through a really long journey together. It's going to be tough. It's going to be difficult, but there are going to be fruits of your labor out on the other side. A couple things to note. One is that we'll be moving around with the mic, and we'll be moving as needed to talk to you guys, to get you guys to engage, and to talk to Wiz.
Hello.
Like that, right? Okay, so Wi-Fi is easy, no password. You are going to need to set up OpenAI and Hugging Face. You should have already set this up, but we know you didn't, so that's okay. We're here to help, and we'll get you squared away. All right. So the idea of today is we wanted to give you guys everything that you need to understand the primary patterns of AI and to build, ship, and share like legends with them, okay? That means prompt engineering, it means RAG, it means fine-tuning, it means agents. And in order to build a truly state-of-the-art agentic RAG system with open source tools, you're gonna need all of these patterns. Even though it's not really clear that you need all of them explicitly, but we're gonna make it explicit today. And we're going to start off by kind of giving you an overview of the space and how to think about each of these patterns. Then we're going to talk about the LLMs and embedding models. How can we pick them? Which ones are we picking? Why are we picking them? And then we're going to set up production scalable endpoints. You guys are going to set up your own production scalable endpoints. You can put this on your resume right after today, but that's only the beginning, okay? So we're going to also show you how to actually build a manual RAG system that is augment the generation with manual retrieval through prompting directly, and then we're going to show you how to move directly into a RAG system. LangChain is the sort of leader of all ecosystem infrastructure orchestration tools, and we're gonna pick that one as our horse to win the race right now, and we want you to build with that one today. We're gonna use LangSmith for visibility and for evaluation, as well as we're gonna use a RAG specific evaluation tool called RAG Assessment. And those guys just got YC funding in winter 23, so they're pretty legit, and it's pretty cool, little tool to get used to. This gets us into agents and LangGraph, and this kind of allows us to stack everything at a new meta level together. So if you're still here at 3 p.m., you will have gone through this entire journey. This journey takes us about 4 weeks of very intense boot camp training in the course that we teach, and we're gonna do it in a day. So, if you make it to the end, then you are going to probably become one of the true legends in our community. And even if you just listen, I think you'll get a lot out of this, as many AI engineering leaders do that attend our courses, but don't actually necessarily build all of the code. We are going to encourage you guys to share at the end of the day in Discord, at TMLS, at AI Makerspace, on LinkedIn, on Twitter, and hopefully we can all get there together safely. All right, so who are we? Well, I'm going to go ahead and kick it off to my team first to introduce themselves. And first up, we've got Sriracha.
Thanks, Greg. Hey, everyone. It's great to meet you. I go by Sriracha, but my name is Sarah. I run operations for AI Makerspace. I am the COO of this company, and we're having a blast building, shipping, and sharing together. We have a very active community, which I love to be a part of. And when I say active, I mean people are engaged. They are literally building projects together, coming with ideas, and collaborating to build, startups, different products, stuff that they're really interested in. So it's super fun. I hope you all get to check it out on Discord. I'm going to pass it over to Lusk.
What's up, everybody? I'm Lusk. Look at that guy. So fake. I manage the partnerships, which just means I try to sell you stuff, try to get your asses in our seats in our boot camp. I deal a lot with companies, with teams, trying to get teams to come in. And I'm also, if you do decide to take a boot camp with us, I am also your client success dude. What's that? You point up like that's the right. That's good. Yeah. So after you graduate, we want to make sure that we're staying on top of your journey, making sure that we're supporting you. And I'm that guy. You check in with me every 6 months or so, and it's all included. So we just want to make sure that you are successful. That's me, bro.
That's right. He's student success. He's not sales.
That's right. Hello, I am Chris Alexiuk. I go by the Wiz.
The LLM wizard, that's what we call him, and you'll understand why by the end of the day.
I do get called that a lot, but you can just call me Chris. And I'm very excited to walk through this today. It is going to be a lot. I'm going to have to go pretty fast for some of it. If you have any questions, please feel free to hit me up on LinkedIn, Discord, whatever. We have an active community. Tons of people like Todd, who you're going to learn throughout the rest of the day today, is an absolute invaluable asset on your learning journey. So I'm very excited. I am the code guy, so a lot of what I talk about is going to be focused on that. It's going to be pretty technical. If you have questions, please, raise your hand reasonably. We can't answer every question, but we'll try to be interactive where possible. Though we do have 4 weeks of content to get through today. So and I'll pass you to Todd.
Hi everybody, I'm Todd Deshane, aka Todd LLM. So I'm here just basically to answer all your questions. I've been in the AI Makerspace since this first cohort they did. So I've been helping out. That's kind of what I do.
Go ahead and shut that down.
Yes, and one more thing is I forgot. I am also the co-founder and CTO of AI Makerspace.
Yeah, thanks Wiz, thanks Sarah, thanks Lusk. And I am Greg, aka Dr. Greg. If you see me online on YouTube, we have our personas and then we have ourselves. And so you guys get to experience both of those today. We started this company a year ago, and for 10 years as a university professor, I saw that the only people that were really succeeding in a 21st century workforce were those that were learning new skills, using those new skills to build awesome things, and then sharing those awesome things they built with others. It wasn't people that were just learning and on the rat race wheel of learning. It was people that were building, shipping, and sharing. And this idea of sharing with a community and building things that you were excited about, that they were excited about, it really resonated with me. And so I went all in on online learning in 2020 and made my way to Silicon Valley, saw how boot camps were run, wanted to do it better. This is us doing it better. Welcome everybody to the AI Makerspace. Here we're going to make some awesome stuff today as a community. We're going to try to get the community vibes rolling, and we're going to try to make sure that it's clear. It's not about the certs. It's not about the degrees. It's not about the prestige. Nobody cares about your PhD, okay? What can you build, ship, and share today, and what are you going to be able to build, ship, and share tomorrow? That's what you're going to get out of this session, and that's what you'll get out of your time with AI Makerspace. We are on a mission to create the world's leading community for people that want to build, ship, and share production LLM applications today. And we really truly believe in practical AI education. That means ROI for individuals and companies. We want to see all of you get raises in the next 6 months. We want to see all of your companies make a ton of money using AI, which is very hard to do even still today. We want to make it easy for you guys to do that. We will do our best to do that today. We believe in giving first. So if you have knowledge, if you're a product person, if you're a consultant, if you're an infra guy, please give that knowledge away. If somebody else is struggling with GitHub today, please go ahead and offer to help first, because it will come back around to help you, I'm sure of it. And embrace, I don't know. If we call on you, try to get you to engage, I don't know is the right answer to almost everything at the edge, and so get comfortable with it. All right. And here we are off on our journey of Agentic RAG. We're gonna go soup to nuts today. We're gonna do it all right? And we are going to focus this around kind of a little fun thing that we decided to call Elon Musk versus the people of Earth. We're going to use this as a common thread throughout all the beefs, the Elon beefs, whether you like him or love him, the beefs are fun, and we can leverage that as some data to have a little bit of fun with our builds today. And it is, again, going to feel a little intense and overwhelming at times. That's okay. It's supposed to. If it didn't, then you wouldn't be really out on the edge. And in short, you're going to go from LangChain to LangSmith to LangGraph all in one day, which is completely intense and, nobody should ever do. But here we are. They gave us 9 hours or whatever, and you guys signed up for it. So let's do this. So by the end of the session today, you're going to learn a heck of a lot, and we're going to get started by just talking about the patterns of GenAI and the patterns of prototyping. Now, it starts with even prompt engineering, but goes into fine-tuning, into RAG, into agents. And so by the end of this little mini session, you'll sort of understand that fine-tuning is about teaching the LLM how to act, how to behave. That RAG is about giving the LLM access to new knowledge, okay? Retrieval, it's all about retrieval. And we are going to sort of break it down into two fundamental pieces: dense vector retrieval plus in-context learning. We're going to try to de-jargonify, but it's very difficult because there's lots of jargon and there's lots of things that we need to be able to speak about intelligently. So we're going to try to be coherent and very simple as possible as we go. And then agents. You might say it's giving the LM access to tools. Is it just tools? Is it just RAG? Is it just reasoning, action, react? These are all great questions to ask about agents today. One of the biggest questions that people ask us in 2024, or maybe late 2023, early 2024, is they're like, man, should I use RAG or should I use fine-tuning? And the answer is yes. Yes. The answer is yes, you should. Because you don't get to just have an either or, it's a both and. The genius of and is what we want to embrace when we talk about the patterns of GenAI, because these aren't things, they are patterns, and we need to leverage them as a good programmer leverages patterns. So these all can be mapped into different spaces, but this is one of my favorites that I stole from OpenAI's Dev Day in November. Welcome in, everybody. Welcome in, welcome in. And so as we move from prompt engineering into RAG, which we will more explicitly define these things as the day goes on. This is our overview. We're optimizing context, okay? That's what's in the context window. As we move from prompt engineering to fine-tuning, we're optimizing the LLM, how we want it to act, how we want it to behave, the tasks we want it to complete. Generally speaking, we're going to do both of these things as we try to work our way towards building human-level performance, production-grade applications. And what about agents? Well, you can put agents wherever you want, because agents are a pattern. And you can have patterns inside patterns and other patterns, which we will get to, again, by the end of the day today. Oftentimes, the journey looks something like this, stolen directly from OpenAI's Dev Day, where you start off by trying something prompted, you add one-shot, two-shot, few-shot, you put some RAG in there, you do a little fine-tuning, add a little hybrid, maybe advanced retrieval process, and then maybe you're like, okay, 90-something% accuracy, whatever that means. I'm going to go ahead and deploy that to my customers, at least in a slow rollout type of way. So the idea here is that you're going to need sort of each of these. And how many people are doing the hackathon this weekend? How many people are also doing that? Okay, only a few brave souls. Okay, yeah, I totally get it. Okay, you guys are. So we're not going to go into a ton of detail on fine-tuning today, but we are going to talk about what it is, and we're going to show you that we're actually going to use fine-tuned models in our builds that a lot of people aren't really understanding that we're actually doing fine-tuning to get something like a tool calling to work, for instance. Fine-tuning, as I've mentioned with all these other things, is a pattern. It's not a thing. And we're not talking about something fundamentally different than training when we talk about fine-tuning. Because in order to build these bad boys in the first place, we had to do this crazy amount of unsupervised, which is really self-supervised learning. And then the supervised fine-tuning is sort of this, okay, you're still doing some additional training, you're still using a loss function, you still have input and output data, same. And really RLHF, RLAIF, DPO, all of these alignment techniques are just like finer tuning, right? We got sort of coarse fine-tuning and we've got finer fine-tuning with the alignment stuff. And so when we think about fine-tuning, again, we're teaching the LLM how to act. I want to just tell you guys that there are 3 types we like to think about. These are not mutually exclusive. And when you think about your hackathon, maybe you should think about these 3 types. Because you're going to be able to do stuff, well, most of you aren't doing the hackathon, but if you get to the hackathon, you're going to be able to do lots and lots of stuff far beyond fine-tuning. But if you're in a fine-tuning environment and you're constrained by it, there are 3 types we like to think about. The first one is sort of just task training, make it a lot better at one thing. Basically going from general to specific again, more classic AI for you data scientists. So going back to just being good at summarization, going back to just being good at one or two tasks. You can think of this as sort of, question answering, summarization, even all the way back to sentiment analysis, right? But nobody wants to talk about sentiment analysis. This is 2024. So, we want to talk about constraining the input-output schema is sort of a really unique one here. It's like, what do I want the output to be exactly? What do I want the input to be exactly? This is very important in prompting and then lends itself directly to fine-tuning. So you could think of sort of, I always want you to output a post for my X. I always want you to output JSON. This is what the function calling models are doing. I always want you to output in haiku format, just because, right? It's like you could think of any number of these constrained outputs that could be arbitrary in some cases, but that are also a lot of fun in others. And then language training, like we did one that was we did like a Gen Z translator one that was a whole lot of fun, right? And you could imagine, obviously, different languages. What's interesting about fine-tuning is that you're actually fine-tuning the interpretation of words. You're not fine-tuning like true understanding, so to speak, because when you do unsupervised pre-training, you're sort of developing that understanding fundamentally in the LLM. When you come on top and you do the supervised fine-tuning, you're sort of rewiring the neurons a little bit, and you're sort of not moving too far away from the initial base weights, and you're still leveraging everything you learned initially, but you're adapting it to a new domain. So a bit of a domain adaptation kind of thing as well. Okay, so fine-tuning is not going to be the focus of today. I didn't hear anybody come in the room and say, man, I just want to learn fine-tuning. So that's worth noting, and it's also worth noting how many people came in and said RAG, 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 RAG. Because this is what people want. It is one of the most important things that you can learn today. And again, RAG is not a thing. It's a pattern. And if you can really grok that by the end of the day, you're going to be a superpower at your company or in your lab at university. So retrieval augmented generation. What problem is this solving? Well, it's solving the problem that LLMs, they're just dirty liars half the time. They're just like, this is the thing that enterprise hates. This is the thing that makes people not trust them. This is the thing that we need to solve and that RAG set out to solve. And they said, well, how do we solve this problem in real life? Well, we fact check people. Like, yo, you just lied, bro. Here, I have this fact, this reference material that shows that you're a liar, right? And we want to do that to LLMs. With more reference material, we can provide better outputs. That doesn't mean that, the kid that puts all the references in the essay has the best essay. That's not what it means, right? But it means there is a correlation there. If you did some work and you used some references, it's probably better than the kid that put no references in and just totally freewheeled it, right? So it's very much the same. We can think of these LLMs like our kids. We don't want to get too attached to them, but I do think, models as sort of cattle versus pets, I think is the new way that the VCs talk about this. But, I think we do want to understand that it is a very interesting way to talk to other people who aren't necessarily technologists about these tools. So it's all about fact checking. And the way that we go about that from a solutions perspective is we can break this down into 2 pieces. The first is dense vector retrieval, and the second is in-context learning. But let me give you an overview first. When you ask a question, generally we're building question answering systems for RAG. So let's stay in that context for now. We're going to feed that question into an embedding model. We're going to first take that sequence of words, we're going to chop it up into tokens, and then we're going to turn each token into an embedding representation. That embedding representation is going to be then stored, and we can look for other embedding representations that are similar. And we might have stuff that's similar to our question in our database. of our data, right? That's the whole point, is like we want to do ChatGPT for our data. So we put our data into this vector database, this vector store. We store our vectors of data, and then we look for similar stuff to our question. Again, is it similar to the question in vector embedding space? So if the answer is yes, we can set up a prompt template. The prompt template reads something like, use the provided context to answer the user's query. Do not answer the user's query if you don't know the answer. Say, I don't know. Again, embrace I don't know. LLM's values are aligned with AI Makerspace. And then if we do find things that are great, that are reference materials, we return those back directly into the prompt template. That, my friends, is dense vector retrieval. Simple as that. It's not a new idea. In fact, search and retrieval is the only thing anybody's been working on for the last 20 years. Search and retrieval, Google, right? How do we find the stuff better than the library, right? It's like search and retrieval. And so this isn't different. The only thing that's different here is, oh, we've got this in-context learning piece. That's where we're putting the stuff we learned into the context window so the LLM can learn it. And so this is the retrieval augmentation process, but we haven't even done the generation yet. We haven't even taken the LLM out. We haven't even put it through OpenAI's GPT 4.0 or whatever to get our better answer, but that's what we do at the very end. So it's all about retrieval and augmentation. It's not about the generation. So when we zoom in on this process, what we can think of is we can think, okay, well, what exactly is going on in this dense vector representation? And those of you with a data science background, you guys are going to smash this out of the park. You remember all this classic NLP. Those of you with different backgrounds, maybe not so much. Maybe you need to go a little bit deeper on this as you continue down this journey and down this path. So when we talk about embeddings, we're talking about taking text and turning it into numbers. So here's a little quiz for everybody, right? Where would we put Apple in this space of words up here? Just shout it out. What do you guys think? Apple goes with bananas and cherries. Sarah, this makes sense, right? You got this? Apple with bananas? 100%. And this one's a little bit more complex. Where would you put cow here? What do you guys think? A, C? What do you think? C. Why is it C? Oh, because the first word has C. I would say there's a vector between. Dog and puppy is cow to calf. I love that. Yes, that's exactly right. And so the idea is like, but where is Todd LLM on this chart? Where do we put him, right? What is this? What is this x-axis? Maybe this is age, right? So we put Todd LLM way past dog. I don't know. Dogs can't live until as old as you, right? And size, you're somewhere in between, right? Like, but he's got something more than that, right? More than, like, we need another dimension of description, right? 2D is not enough, size versus age. In fact, we need lots of dimensions to describe the real world. And oftentimes we're using dimensions of 4,000, of 10,000, of 50,000. And we just can't visualize them. We have to like PCA them back down. That's a data science term that we're not going to get into today. But the idea is like, you need lots of dimensions. And we try to represent all of those in vector embedding space. Let's not even get into multimodal models. The space is way crazier. But just for words, and again, we're not generally using words, but we're using token level representations, which are sort of subwords, maybe sort of half words, roots of words, that kind of thing. This is not a new idea. Word2Vec is the OG in the game, right? 2013, this is from the illustrated Word2Vec, but you know, the idea is like king minus man plus woman equals about queen. It's like, it worked. Yes, right? Okay, so that was pretty cool when we started to see this actually come to, you remember like pre-trained embedding models used to be a thing NLP talked about, and like now nobody talks about it. It's like, of course they're pre-trained. What are you talking about? Why would you train your own embedding model? That's nuts. And in fact, we can pick lots of different embedding models. We'll talk about this today. Word2Vec is the OG. We've got OpenAI coming out with new ones all the time. Text 3 embedding small is the most recent. We've got the massive text embedding benchmark leaderboard from Hugging Face. That's where we're going to go today to pick out our stuff. Okay, so when we actually talk about retrieval, though, right? Retrieval is so important. it's not a difficult idea. We ask a question, we search the database for stuff that's similar from like a cosine similarity perspective, similar. And then we return the stuff. That's easy, okay? So we're in this retrieval process, and we're using vector representation to sort of put the question into the vector database. We're using vector representation to get the similar stuff, and then we're returning the stuff. He's going to show you how to code all of this from scratch. Oof, you guys ready for this? And the vector representation is assessed by looking at, is there anything similar in my data that I've stored in the vector store? So outside of this RAG process, you've already done the hard work of taking your data, chunking it into pieces, sentence length chunks, paragraph length chunks, whatever you want, and then tokenizing those chunks, putting in vector representations on those chunks, and then storing it. The thing about vector databases is they're very, very fast to search. That's what's so great about them. That's why all the vector DB companies got all this money, because they're like, oh man, we're working on this thing that the world needs now. Yay, RAG. And so this is very important. We're going to show you how to build a vector database from scratch. We're going to show you how to take one off the shelf. And we're going to show you how to do retrieval, because retrieval is not very difficult once you have the vector DB, once you have the query, once you have the idea of similarity. Welcome in, welcome in. Go ahead and just take a seat anywhere. The room's getting pretty full. And so the dense vector retrieval process is really the key here, because in-context learning is in-context learning is in-context learning, and it's not any different than what you guys commonly know as prompt engineering already. There are some best practices with prompt engineering. We'll go into some depth on this, but I want you to focus on one of the context best practices here, and that is retrieved context. You want to make sure you're retrieving the right stuff. That's what we need for context optimization. That's what we need for RAG. That's what we need to do in-context learning better. Now, in-context learning, this idea came from the GPT-3 paper. Okay, this is language models are few-shot learners. If you're looking for a nice, light, easy 70 or 80-page read this weekend, check this one out. This shows that the accuracy for many different tasks, zero shot means I'm just giving you instructions. Hey, little bud, can you go over there and grab that for me and just come over here? And never showing the kid how to do it. We want to be able to do that to our LLMs. It's not very easy today, though. It's getting easier. It's better if you give it an exact example of what you want. That's one shot. I give you one shot. I'm going to show you this one time, and then, wax on, wax off, you go get after it, LLM. One shot works very well. And again, this is an old paper. This is like 2020. Few shot, that means 1, 2, 3, 4, 5, 6, 7, 10, 100. Probably not 10,000. That's when we get, although with long context windows now, it could mean the entire corpus of data that your company has on record. So, in context is starting to evolve and mean different things as we go along. It's all about using in-context information well. And as we put more and more stuff in context, here's the interesting thing, we're on this spectrum of task specificity, and this spectrum of instruction only to one shot to few shot, all the way down to, here's our good friend, fine-tuning that we have to do. This is all the same thing. These start to merge together, and what we're essentially doing, this is a great blog from Chip Wen. We're big fans of her and her work. As we move from having the stuff in the prompt to then putting the stuff into the model and sort of baking it into the weights, we're doing a couple different things. One, we're moving from prompting to fine-tuning. And computationally, we're doing some really interesting things too. Aren't we, Wiz? So for instance, we are potentially saving a lot of cash. You guys like cash, right? You work at companies. How can we save cash by doing something like this, Wiz?
Yeah, so the basic idea is that if we use you can think of it as kind of tucking the prompt into the model, right? So if you're using a service like OpenAI, or you're using, say, a GPU which has some limited memory capacity, we can actually save the compute that we would normally spend on parsing that prompt as part of our inputs by kind of rolling it or baking it into the model. So this is like things like instruction tuning, where we can use that instruction template as opposed to needing to provide many examples on how to follow instructions. We wind up saving, both cash as in money and cash as in KV cash by using this method to roll that into the LLM itself. So this is why things like OpenAI offer that fine-tuning service. The main reason is to save your per token cost when you're interacting with those endpoints, if you're always going to be using the model, say, for a specific 2 or 3 tasks.
Yeah, question.
So I would guess we're talking about the Laura to fine-tuning, right?
Oh.
So you still need to spend time fine-tuning it.
Yes, you absolutely.
That's right. Oh, yeah.
Yeah, so you will, this is, of course, we see the fine-tuning there. You will have to fine-tune, and fine-tune does incur a cost. The amount of money you're going to spend in time or compute on fine-tuning is variable depending on if you use strategies like LoRa, or if you do something like SFT, where we're gonna fine-tune the entire model potentially. But the idea is that if we're going to be using this prompt, say for the duration of our business, we're gonna have let's just pretend it's hundreds of calls per day, right, for years. We're gonna find that savings is delivered to us pretty quickly, or we're gonna find that our latency is gonna reduce to an amount that makes our customers happier, which is going to be usually is an upside. So, but yes, it's not like free to do this, but the benefit is it's a one-time cost for the fine-tuning. When I say one-time, what I mean is periodically as your as your MLOps pipeline dictates, of course, but the idea is that you're paying this cost much less frequently, even if it's larger, and then you're saving cost every time something interacts with that model, or you're saving capacity in your GPU, which can also lead directly to cost savings, or at least maybe some reduced latency.
Yeah.
So
You mean LLM ops? Yeah.
yeah, sorry. Of course, I mean.
Yeah. We got to stay in buzzword
Ops.
compliance. Yeah. Okay. So what we need to also think about is, like, we've had a customer come to us and say, "Hey, should I consider fine tuning if I'm already happy with the performance of my model, but I want to just reduce the cost?" And the answer is yes, you should. Okay. So there's lots of interesting things as we get into this sort of. And we're not going to talk about, again, fine-tuning in great detail today, but small language model space, quantization space, all this stuff that would require you to actually download the models to your computers, which we didn't want to do today. Yeah.
But the fine-tuning, how do you handle catastrophic forgetting? Because you have these LLMs trained on general knowledge, and then if you fine-tune it, you're going to lose that ability to generalize information.
Well, I mean, I think that's a good question in general, but I think the answer is always, it depends, and the answer is always going to be like, it's going to be easier the more specific you are with exactly what you want it to do. And if you're fine-tuning, you should be wanting to constrain the space that you're not willing to move out of. So if you move out of that space, then you should do a different fine-tuning or find a different solution. I don't know if there's anything else to add on catastrophic forgetting there.
Yeah, so we already actually heard a pretty good solution to the potential issue of catastrophic forgetting from the person over there, which is LoRa, right? So low rank adaptation. The idea that catastrophic forgetting, for those of you who might be like, wow, what a series of words. Basically, it's when we unlearn the model to the point that it produces gibberish. In LoRa, what it does is it perturbs a very limited set of weights of the model. So because we restrict the amount that we're actually going to impact our weights, we get the benefit of being less prone to catastrophic forgetting. Though there's a similar flip side with LoRa where we're finding that, like, you can't fine-tune the model as well or to its full potential with LoRa, but it's robust against those kinds of things like catastrophic forgetting, and it helps the model stay well generalized on the tasks that it was trained on originally. So that we have some tools that will help us do this as well. This is where we're going to get into this for RAG, not fine-tuning, but things like validation and evaluation while you're doing your training cycles. can help you mitigate the part where the model stops being useful to you at all. So.
Yep. And we'll just keep it moving rather than get caught in a fine-tuning local optima here. What we want to do is we want to sort of remember, take away from this, that RAG is giving the LM access to new knowledge. But RAG incorporates in-context learning, which fundamentally is on the same spectrum as fine-tuning when we talk about adding more and more stuff in context. Okay, so a lot of this stuff starts to bleed together as we talk about RAG and we get into our final pattern, which is agents. Okay, here we go. So here's a bold statement. Let's see if we can see if it's true by the end of the day. Today, agents are just fancy RAG. Well, now that we know what we know about RAG, RAG has the R for retrieval, right? So agents are just fancy retrieval augmented generation. Is that true? I don't know. Let's find out by the end of the day. First of all, just dispense with all these people that are pretending like these words are very, very different. They might come to mean different things or something, but they don't today, and you can use whichever ones you want. If you're in a room full of smart people, say the smart word. If you're in a room full of people that don't want to sound smart, say the regular person word. Just do that for now, and then you'll be way ahead of the game. All right? If you think about like where can I apply agents, then you can do agents wherever you want. Like agent, what does it even mean? Agents is such an old idea. Agents, you can read books about agents from the 50s, from the 60s. Like, what is it a pattern? It is. That's what we said, right? Well, what is the pattern exactly? Let's think about how we might apply agents to each of these different things. Let's see if we can get a handle on this by the end of the day. Well, the easiest thing to do with LLMs is to just put stuff in and get stuff out. And that's going to be the first thing that we do today. OpenAI API, we're going to hit it. We're going to smash an endpoint. It's going to be great. A cyclic approach versus a linear one is going to basically have access to tools in a tool belt. The agent's going to sit there and it's going to be like, the superhero pulling out different tools. It's going to go retrieve a tool that's going to be used to retrieve some other data, some other information, and then to, let's say, augmented generation. But we're also going to loop here, and we're going to loop, so we're going to loop in this sort of reasoning action, and really a reasoning action observation pattern. So this whole 1-2 step is to, ask a question. We start with this question again. Question answering is a good context to put this in. We ask a question. It goes to the LM. The LM says, do I know the answer to this? I don't know. If I do, here's the answer. Easy. If I don't know the answer, I'm going to look in my toolkit, and I'm going to see if I can find something that will help me find the answer in my tool belt, right? And then I'm going to see, okay, what did it tell me? I'm going to add that back to my little thread here, and I'm going to keep considering stuff over and over. I don't really like this sort of, how quick this is on the, and we'll get to your question in just a second. And then, okay, I got the answer. Bop. Okay, I got to work on my game here. Okay, so let's just think about this. Let's put this together for a second, and let's just look at this a different way. Let's take our RAG system, and let's just compress it down into one little block. This is a custom RAG system that we built, that we're going to build. Okay, so if we think about our agentic reasoning action loop, what we could do is we could say, okay, let's think about it like this. It's simpler. Ask a question, goes to an agent. The agent is then going to decide, do I know the answer? If so, I'm going to stop. I'm going to exit the loop. Or do I need to go take an action? And the action is going to basically be to pick a tool. Now, one of the tools in my tool belt can be a custom RAG application that I built with my own data. Another tool could be the SERP API from Google. It could be the DuckDuckGo API, the search API. It could be any number of different tools that you might use. You can go on LangChain, you can go on Crew AI, you can see all the different tools that people can put and connect to this. But there's also this additional observation piece where we're seeing this new result. And what happens is we actually, as we enter, we start a conversation thread. This is going to be a conversation that gets all put into context each time we run our agent, which is an LLM. It's just the LLM, right? And what's interesting is that as we move from this agent, oh, I'm not sure I know the answer. I'm going to go grab a tool from my tool belt. What does it need to do to grab the tool from the tool belt? Well, it needs to grab its function calling capability, which the function calling capability is actually, it's just a fine-tuned LLM that always outputs JSON, so it can call functions. And so what's really interesting is that as we move from this LLM call that's prompted into a tool calling space, we're using another fine-tuned LLM that is good at calling tools and functions. We're then collecting this resultant data, we're adding it back to what becomes a modified prompt to do additional reasoning, and we're back with our agent going through this loop. So we've actually done prompting, we've got our agent, we're doing RAG, we've got a fine-tuned LLM that we're using, and then all of this is necessary for just the most simple one-agent system, okay? If you have questions, happy to take them now, but this is sort of the idea. Yeah.
I just have a question on how do you decide, how does LM decide if she has a good enough answer or not?
How does the good old LLM, how does she decide?
So that's a great question. In reality, in most of these loops, the LLM will only decide insofar as the output it produces is thought to be helpful by the LLM. So there's when we think about things like in-context learning, which is kind of the thing we're exploiting to be able to do this. Though there's an additional layer when we talk about things like tool calling that has or function calling APIs, which have been fine-tuned. The idea, though, is that the LLM itself is going to be the arbiter of quality for this loop. So when it sees the response, quote unquote, when it sees the response, right? So when we send the results back and the LLM produces a response based on those results, that's just going to be its output. Now we can do things like append a LLM as a judge style prompt where we ask, did this fully answer the user's question? If so, we're good. If not, take another shot. So we can add kind of logic flow to this system for that. Otherwise, it just will produce a response, and the assumption is that that response should be helpful or valid. There is no internal mechanism by which it's going to check to ensure that the output is wonderful.
Yeah, and I want to jump in on this. Prompt engineering is basically at the bottom, at the top. It's everywhere in the hierarchy of building these applications. So when he's mentioning, we can have a prompt at the end say, was that good enough? If not, retry. In fact, Crew AI does this. If you build multi-agent systems with Crew AI, they do auto retry stuff, built in. So we're getting this next layer of abstraction of auto retry stuff. But even as simple as tool calling, we have to follow the best practices of prompt engineering. And we want to tell, this is built into LangGraph that we'll use. This is code that we'll use later. We didn't write this code. But you have to tell the LLM, hey, this is a tool that queries DuckDuckGo. It's good for search when you need to answer a question with live stuff. You have to prompt everything from input to output to evaluation to retries. And so prompting really is you're going to see it's everywhere. And you can't really understand or experience how important it is until you really do some of this more deep engineering. Yeah.
So in the flow you have, the user interacts from the prompting or asking the question, and then you have a memory where you have that conversation thread.
That's right.
I'm just curious what tool the agent would have to ask the user for clarifications.
Yeah,
That's
so
one of the use cases that I'm like, if the user asks a dumb question, can I
That's
just
right.
say, did you mean this? Did you mean
That's
that?
right. Yeah.
Yeah, so this will all lead to LangGraph. Our whole day is going to lead to LangGraph. And LangGraph has a number of ways we can approach this problem. So you can see here that we have kind of a very simple application flow setup, right? Where we go to the agent, it does some perfect, exactly. We go to the agent, it goes to the action node. We go back to the agent node. We either return the answer or we determine we need to take another action, et cetera, et cetera. Now, at any point in that flow, we can add any nodes that we'd like, right?
Dumb question node.
Yeah, dumb question node, exactly.
Right.
Like, or like, is the user asking a completely irrelevant thing based on the context that I have, right? So you can add nodes at will, and those nodes can interact with users. They can interact with other LLMs. They can interact with APIs. They can interact with whatever you design them to interact with. But there is absolutely versions of this system that will have human in the loop, right? Including like, is this response, like we get to the answer, was this response good enough, right? If the user indicates that it wasn't, back we go. So it's we have access to that kind of design through just adding nodes, right? And this is I think the thing that makes systems like LangGraph or using graphs to design agents so powerful, because we can add, if we can wrap it in a Python function, we can add it as a node in this agentic flow.
Yeah, and if you can draw it.
Or LangGraph.
LangGraph.
Yeah, and if you can draw it on the whiteboard, you can add it directly to LangGraph. Like one of the things, if you're not a programmer, is like just because you can draw the flow chart doesn't mean you can code it up super easily. Like, product people maybe can draw the flow chart and then they sort of have to hand it off and then the programmer figures it out. Well, LangGraph makes it very easy for everybody to work together because you literally code it exactly as it's drawn. And so this is one of the very powerful patterns that you can leverage directly from LangGraph. All right, so,
Great.
Yeah.
So I just want to add to the questions he asked.
Yeah.
Like how the LLM knows that it has got the answer. So just to address that, like there is some little information I would like to add. The agents itself has a powerful LLM, and not every LLM is created equally. So some there are powerful LLMs like GPT-4o and the others, which has been trained for reasoning tasks, and that's why they are able to answer. And there is another way, like there's a fine-tuned LLM which just knows how to do a function calling, which is not that powerful. So that's how you usually know whether an LLM has received the right answer or the correct answer. So because they have been trained for that. Hope that helps.
Yeah, I was just interested, how do you get confidence, right? How do you know how confident you are?
I mean, this is what enterprise wants, right? They want well, how do I know if it's right? How do I know if it's good? How do I know if it's correct, right? And it's like that's one of the things. It's like, well, I mean, how about you ask the human that does the job right now if they think it's good and right and correct? And then nobody, of course, wants to do that because everybody's a technologist and they want to build these tools. So we're going to cover RAG assessment later. We're also going to cover direct prompted evaluation. Like you can do hilarious things like assess the output of this LLM on a dopeness scale of 1 to 10, right? It's like, oh, that was a 7 dope, How about that, boss? It's like, that's not going to fly. That's going to be hilarious in your community, but not for your boss. And so what you want to do is you want to say, well, actually, we increased, you can do this with RAG, we increased the faithfulness of our output, so it's not lying to us. We're avoiding hallucinations nearly 100% of the time. And it's like, yeah, but you might still have garbage output. It's just not lying to you, right? So there's a real interesting space that exists in eval. And ultimately, you know the human that does the job. If you're not building something where there's a human that does the job now, then you're probably trying to do a thing that humans can't do yet. And that's probably not a good business use case for you to try to attack first, because that's just not low-hanging fruit. That's a research project that you're going to end up dumping money into. All right, so what did we learn? Well, we learned that fine-tuning is teaching the LLM how to act. We learned that there are 3 types: task training, constraining the input-output schema, and language training. We learned that RAG is about giving the LLM access to new knowledge. RAG is simply dense vector retrieval plus in-context learning, otherwise known as prompt engineering. And agents are giving the LLM access to tools, also fancy RAG, also reasoning action loop, all of the above, yes, indeed. So we've got 4 patterns that we're going to leverage today, and we're going to leverage them to do cool stuff. Remember, these are not things, they are patterns, and we're going to use all of them. So what are we going to sort of use to put all of this together? Well, let's think about how the application stack looks. This is a really, really great repo, and we'll share slides and links with you guys, everybody. This is from Andreessen Horowitz, but I'll show you exactly what you need. They got this right in like June 2023, really. It was very, very well done. You might have to squint at this, but the idea is like, there's like the data preprocessing and embedding piece of the pipeline. There's the prompt construction and retrieval piece of the pipeline, and then there's the whole back end of the thing. And you know, what we're going to kind of do is we're going to kind of break this up piece by piece. So we'll start with an app that looks like this. So in the middle, we're going to have orchestrated, we're going to have the Python SDK from OpenAI, and we're going to use OpenAI's embedding model, that's up top. We're going to just use Python to build our vector store from scratch. All right, and then we're going to use OpenAI's model on the back end. This is going to be very, very easy to get up and running. And then we'll end up in a cool place where we're using LangChain for infrastructure orchestration. We're going to use Quadrant, merging best practice vector database. These guys are crushing, so watch out for Quadrant. We're going to use an open source Hugging Face model. We're going to use an open source Hugging Face model for the chat model. We're going to use LangSmith for visibility, for evaluation, well, for visibility and for monitoring.
What are we using for the embeddings?
We're going to use a Hugging Face open source model for embeddings.
Are you going to talk about how to select the right embedding?
We're going to talk a little bit about it, yeah. But we're also going to give you the selection that we would go with today, and we're going to kind of roll on with that, because that's a deep, dark rabbit hole. This is the other thing about today. We have to avoid all of the dark pits, because they're very easy to fall into, and they're infinitely deep. You know, so we're also going to use RAG assessment, as we mentioned, to do evaluation. And in order to generate synthetic test data for RAG assessment, it's actually works much better to use, as you were mentioning, my friend, in the middle, the most powerful model to do this, rather than some open source model. And it's also just a little bit easier to do. You might run into some rate limit issues when we do this, but we're going to use OpenAI's API to develop test data. So that's what we're going to do first. So with that, let's get into first part of the session today, LLMs and embedding models. And what we want to do is we want to learn how to deploy open source endpoints. It's the first thing you're going to do. It's going to feel really good because you're going to deploy your first scalable endpoint. You're going to hit it, and you're going to be doing your little prompt engineering. So a little terminology for those of you that aren't back-end infrastructure people, you aren't engineers full-time, you haven't been doing this for your day job. This might sound basic, but it's often very confused. We serve a model so we can do inference. We can make that inference, we can infer stuff. You know, inference is just pumping the stuff through the LLM, right? Input gives us output. When we do inference for LLMs, we're doing inference on GPUs. You could use CPUs, but no, you couldn't. Okay, don't do that. All right, it's just, it's ridiculous. You'll sit there for the rest of your life waiting for this thing to come out. But you don't need crazy GPUs, especially if you use quantization and if you use the small models that are quite performant off the shelf, which we'll show you today. We'll use an 8 billion parameter model. And we're not going to do quantization because we're not going to download the thing. We're going to set up an endpoint, but you'll see it works really, really well. And then just terminology again. Production. Everybody has this sort of mystical idea of production that doesn't actually deploy stuff to production. It just means that the thing's always running. Okay? That's what it means. It means like it's never going down, ever. All right? So that's the goal. Now, why would you need something to never go down if no one ever used it? That's a great question. You know, that's a really good question. You know, so don't worry about production if you don't have anybody using your stuff. But we are going to show you how to do production grade stuff and scalable stuff because it sounds cool to do it. It's great for your resume, and people want to know that you have that experience, even if you don't. Prototyping is where, you know, the money is made, especially today, and, you know, the scale AI engineers are still doing everything today. So let's see how it works. What we're going to do is we're going to have a little fun. We're going to go ahead and play the Smash That Endpoint game with the Wiz. So I'm going to invite him up here to show us exactly what it looks like when we deploy a scalable endpoint. And then we'll want you guys. Oh, I should have thought about this. I don't have an easy way to send you all links to something. I'll write it on the board.
Yes, have fun.
Okay.
Okay. So let's do this. We will have an endpoint available to everybody, but it is going to be, let's say, fun to copy. So you're incentivized to get your own endpoint up, because if you don't, you're going to have to write out what can only be described as a lot.
Well, who gets that started? Do you guys have any questions that we can answer? We're going to have this switch back and forth that we got to get used to.
Can you show a sample code for quantization?
We're not going to get into that, but I will give you code, 100%, yeah. I'll show you exactly where to find it. That's another one of these dark rabbit holes we just can't fall down today, unfortunately. But we've got great content on YouTube, and we've got great code available for you to leverage quantization directly.
Okay, so if you go to our organization on GitHub, AI Makerspace, you will find a TMLS OSS agents repository. That is, I'm just going to zoom in a little bit here. That's going to be where we're going to work from today. As we progress through the modules together, I will release more and more. So if you are someone who's using GitHub, like through VS Code or on your laptop, instead of just accessing it through the website and clicking collab links, just a reminder, whenever I come up, you'll have to pull the new content. So the idea is we've hopefully already done this kind of thing, and now we want to do this kind of thing. It's going to seem complicated, but it's really not. This is going to be deploying a Hugging Face inference endpoint. For those of you who are unable to do so, we will provide a link, but it is going to be very long and mostly random characters. So, try to do it yourself, basically. So what are we going to do? The README kind of has like the picture walkthrough. So if you run into any issues while we're doing our mini build together, you should be fine. And we're going to end with this notebook. This notebook is going to be talking about how we I'm going to zoom in again, sorry. Talking about how we access this particular endpoint. So what we're going to do is we're going to get started by going to Hugging Face. And if you want to follow along live, please do so. If you don't, no worries. We're going to have a build session where we're going to give some time for you guys to do this. So if you just want to pay attention for this part, that's fine. But if you want to do it while we're going through, that'd be great. You can help your neighbors. Okay, so what are we going to do in Hugging Face? The first thing we're going to do is we're going to go to inference endpoints. Okay, so you can see that, I'm going to zoom in again, very sorry. You're going to see that we have a number of endpoints already selected. I have a few that are up and running. One is called TMLS public. This is the one that Dr. Greg is going to copy onto the board for you guys. So I'm going to send him that in Discord here so he can do that. Again, the incentive is we want to go ahead and get you guys to set up your own, or else you have to copy that link down. Okay, so what is an inference endpoint? Well, if you're familiar with AWS, which if you're not, no worries. It's basically a SageMaker endpoint powered by AWS. You can choose more than AWS as your cloud provider, so you don't have to use SageMaker, but that's what we're going to do as a default today. So how do we set this up? Is it difficult? We set it up pretty straightforwardly, and it is not difficult. So what we're going to do once we get to our dedicated endpoint page is we're going to click New in order to create a new dedicated endpoint. You can see here that we have a few options initially. The first option is our model repository. This is where the model that we want is going to live. Now, we talk about using the Meta Llama 3, but we're actually going to use the new research version called Hermes 2 Pro Llama 3 8B. This is available in the GitHub, so if you don't remember it, you can just copy and paste. The reason we're going to use this particular model repository is So Llama 3 out of the box actually did not receive any special function calling fine tuning. So there's no specific way, or there's no trained way that we can leverage function calling through base Llama 3 8B instruct. And so what we're going to do is we're going to use New Research's version, which has had that training to allow us to leverage things like function calling should we want to. So that's why we're using this model. There you go. As for the endpoint name, we're just going to go ahead and we're going to call it whatever you're happiest with, right? We'll call this TMLS Demo 2. You can see here that we have access to Amazon Web Services, Azure, and we have GCP, so you can pick whichever one is your favorite. We also have the ability to select our region, though they're very limited. And we also have the ability to select our hardware for today. Now, you'll notice that all of this hardware comes with a cost that's going to be charged per hour. So the idea is if you have this endpoint up, you're going to be incurring a cost every hour that this goes on. It's technically billed at the minute. The minute pricing is simply the hour pricing divided by 60. So it's all good there. What I'm going to recommend you use is at least the L4. If you use the L4, you should be able to do inference, though you'll be limited in the amount of context we can send to the LLM before the GPU crashes. What I am using for today is the 4 L4s. Now you'll notice that this is $0.8 per hour, and this is $3.8 per hour. So, I mean, one of them costs a little bit more than the other, a little bit tongue-in-cheek there, it's quite a bit more. We are hosting the 4 by L4, which should be able to handle all of you guys hitting it without dying. But the idea is that, you know, if you want to do this yourself, you should be able to do it with the L4, though you might be limited by how much context you can pass. That might require you to dial down some of the chunk sizes that we're going to use, or the number of retrieved chunks. If you don't know what I'm talking about when I say that, don't worry, we'll get there and you'll understand at that point. Yeah, so it's up to you. If you want, you can definitely go with 4 by, but you should be able to get away with the L4 with this particular model, and that's that. You're going to notice a few things about this particular instance, right? So we're going to see this optimized text generation inference container has been selected for your endpoint. New Research has provided a TGI container for this particular model, so you don't have to do anything special. It's already set up to work with the OpenAI Python library, so the OpenAI API standard, which you should be used to if you've ever worked with OpenAI. If you've ever used LangChain before, I might zoom in there. I see some people looking a little like it's not zoomed in enough. So if that's better, let me know. If it still needs more zoom, I can punch it a few more, but at some point we'll go too zoomed. So TGI, all this means is that we can interact with this particular model like we would with something like OpenAI. This makes it fit seamlessly into the rest of the tooling we'll be using today. So we're going to be interacting with this endpoint as if it were OpenAI for the rest of the day, though it's not. It's going to be hosted by Hugging Face. We can basically scale to 0. What this means is if the API endpoint is not being used, it will automatically spin the instances down. You will be not charged while there are 0 instances, but you will be charged from the very moment that it starts spinning up until the very moment that it spins down. And anything, even looking at it weird, will keep the container up. So you can set this option to feel safe, but at the end of the day, we're going to remind you a lot of times at the end of our time together, please turn your instances off when we are done. I will show you how to do that so you're not wondering about it, but that's the idea. What's up? Yeah.
Is there like auto log off, like idle time log off?
So this is auto scale to 0 is what we have. That's the option that we have, to be honest with you, which just means that after some period of time where we're not hitting the endpoint, the instance that's hosting it will spin down. This is a great option if you forget to pause your instance or if you don't turn it on. So I would recommend turning it on, but realistically, you're really just going to want to spin it down so you don't get any weird charges. If you are, yeah.
This seems a little boring. Why are we doing this first?
Yeah, super good question. So in order to have a good experience with an LLM, we need an LLM to exist. And we need to be able to send requests to it. We need to send text and prompts, and we need to get text back, right? We could just use OpenAI, but the kind of point is to show that we don't need to use OpenAI if we don't want to. We can use whatever model we find on the hub that suits our use case, and we can just, the rest of the stack is going to integrate very cleanly with that, and so that's why we're doing it first. Also, this will take potentially up to like 8 to 10 minutes to actually spin up, depending on the instance that you choose. And that's 8 to 10 minutes that we want to overlap with some additional learning. What's up?
Yeah, so if I want to run an LLM locally in Makerspace, is that totally a bad idea for the sake of this demo? Like if I have a lightweight LLM that I could run?
Yeah, I mean, so if you've got beefy enough compute in your laptop and you want to run some kind of local LLM, that's fine, as long as whatever you're using to run it is compatible with OpenAI's API format. You should be good to go. I would very much recommend, however, and we will officially support the inference endpoints. What I mean is that if you do use a local solution for on your laptop and you run into strange issues, we're probably not going to be able to accommodate troubleshooting that with you, just because there's a lot of us, and if everyone uses their own solution, that's all we'll do today together.
Yeah, highly do not recommend unless you're a super advanced user and you do that all the time already. But we do have Todd LLM in the house, so he can help you out. And then, so are you saying that we could use OpenAI?
Yes.
Oh, okay. So like, why would we not use OpenAI? You guys have any ideas? It's expensive. What else? I mean, data. They're going to steal our data, right?
Okay, so I'm not going to say officially that they're going to steal your data.
Officially.
Especially if you're using their API. They don't automatically use the API data for training. However, there is some situations in which we don't want it to go to OpenAI, our data to go to OpenAI, depending on the level of security that they have. Something that Hugging Face inference endpoints let us do is actually run this in a single place in the cloud, which can be much better for your security teams. They will hate you much less than if you try to use something like OpenAI's rather loosely secured endpoints. And so that's why we're going to use this today. It's also just to show off that you don't really need to use GPT-4 or something like that to design applications that do what we need them to, but that's much secondary compared to the fact that we just want to be able to run our own model, quote unquote. Also, though we're using Hugging Face inference endpoints today, all we need is an endpoint that runs this container. This says TGI, which is available through new research. If you want this specific version, and that can be handled by your ops team if they have an inference endpoint for you that they manage. You'll have the same experience as the developer. So it's basically just showing off. We don't need OpenAI. The hilarious part though is we will use the OpenAI Python library to access this. Exactly, we will override the OpenAI base URL, and we will provide an OpenAI key, which will be our Hugging Face token. So it's going to feel a lot like we're using OpenAI, but secretly, it's going to be this bad boy.
Okay, so then just to wrap there,
Yeah.
You're saying that OpenAI, like, damn, they just streamline stuff so well sometimes that it's just easier for learning purposes, easier to get spun up quicker, but if you want to do that sweet on-prem RAG with Llama 3, then like we're almost there.
Yeah.
And we can do something like this. So it's not boring if you want to do this in enterprise, right?
No.
It's just boring if you don't care about that, maybe.
Yeah, I would say it's boring. I like it, but if you're of the personality where you think it's boring, it's not. you know.
Because
and-
like we could go use OpenAI API, we could go use Anthropic API, we could use any closed source API we wanted, and we'd be able to hit it and just be done with it. But this is going to give you much more flexibility. It's going to give you much more ability to choose whatever it is that you want. And this is something that we know enterprise individuals, everybody's asking for. So this is why we're showing this for you guys today. And it is going to take some time to spin up. If you don't get it set up, that's okay.
Can you go up?
We will give you the endpoint. You can just use ours, okay? And I'll give you a bit.ly link instead of that crazy thing. All right, that's it. Let's keep rolling.
Yeah, and so the other thing that's important to recognize, the reason we can do this is because there is a little bit of convergence in the ecosystem towards this OpenAI API standard. So a lot of the times when you see services, when you see inference optimization engines, they're going to be in some way compatible with that OpenAI API standard through some kind of interface. And so it's just, we're at the stage right now that people are converging towards this as a standard. So it's the same experience regardless of where the model lives. Yeah, what's up?
Yeah, the model repo name is different than the one in the screenshot in the GitHub.
Yes, that's true. But the text should be the same.
Okay.
Yeah. So we'll want to go with the text. Okay.
So it doesn't matter which one you use?
It shouldn't matter. It shouldn't matter. I would use the Hermie 2 Pro if you can. If not, you can use the Llama 3 8B Instruct, but you're going to be limited by some of the later tool calling stuff. But it shouldn't be disastrous. Okay.
So with
Hey.
one question.
Yeah.
So why would you go through Hugging Face if you can directly go to AWS and spin up the whole endpoint?
We'll talk about some of those options right after we're done with this demo.
Yeah.
Because we did an OpenAI comparison, so I was just wondering why Hugging.
Basically, like it's just easy to do. So it's so you can use AWS, but in order to use AWS, you have to go through AWS's tooling, which is really good if you're familiar with the ecosystem, but it can be a little bit confusing. Hugging Face is basically just build a simple wrapper for that, and that's where we're using it today. Yeah. Okay, so we do have to go into the advanced configuration, unfortunately, but also fortunately, because we get to see a bunch of cool options. We're not going to talk about replicas today. We will talk about task generation or text generation as our task. So each of the containers we use to host these models is going to have a different set of tasks. Those tasks are going to dictate which of the containers we can use. Because we're using text generation, we get the ability to use the TGI, text generation inference container. This is a relatively well optimized inference container. What that means is that it will generate text faster than if we didn't use it, right? So if we just call the model through transformers, right, that's suitable. It will work. We will get a response. It'll be kind of slow. It might bottleneck if we send in a bunch of requests. We're going to have a really long time to first token if we're streaming, and we're going to have very high latency if we're not for the full response. So the text generation inference is going to let us make sure that we're generating relatively quickly. Is it the fastest inference solution around? No. Is it a decent solution? Absolutely. Is it much better than not using it? 1,000,000%. Yes. We're going to go to quantization, and we can select bits and bytes. This is going to leverage the bits and bytes quantization. For those of you who know about quantization already, bits and bytes is going to be something that will save us on capacity, and it will offer no inference benefit. So what this means is we'll be able to fit the model onto a card with less space, so it'll take up less space in our GPU, but there's no benefit to inference. In fact, there's a very small penalty to inference, depending on the level of quantization. We're just going to set it so that it fits on the card. If we don't do this, you might run into OOMs a little bit faster. We don't want that. Okay, max input length for query. We're going to set this to 2048. You might have to keep this at 1024 depending on your selection of hardware. So 2048 is going to be fine. However, you can still go through the entire day with 1024 with some minor adjustments to the chunk sizes that we're going to use and the prompts that we're going to use. Basically, the only thing this means, you can think of it as like our GPU is a pool, right? If we send more context, we're going to take up more space in that pool. We only have so much space we can take up before it would start overflowing. And computer, GPUs don't overflow, they just stop, right? So the idea is, we want to make sure that we aren't running into, oh, there's too much stuff here, I'm going to stop, right? I'm out of memory is what it's going to be called, or OOM. So we're going to set it to 2048. We will have to make sure that we set this to 2052. It does have to be longer than the max input length per query. And so we're just going to set it to 2042 or 2052 because that's just what you do. We don't have to worry about the rest of these options, and we don't have to worry about the environment variables. What's up?
What's the max input length we can give?
So it depends on the hardware you select. The max supported input length is 8K. So you could go up to 8K if you chose a lot of hardware. I would not recommend to do that unless you really want to, but the model itself supports a context window of 8K. So that's the maximum if you had the hardware capacity.
If you were choosing like a model which can support larger, through this inference would you also?
Oh yeah. You just need the memory, right? So we're not limited. So the model is not the limiter here. It's the actual hardware we're running on that's limiting that context window. And we're not actually doing anything that changes how the model works. We're just saying we won't accept any inputs that exceed this value. So we're just artificially limiting the model in order to fit into our capacity. Yeah, great question though. Once you're done that, you hit create endpoint. That's it. Okay, so we'll go back to our endpoints and we'll look at one that's already up and running. So we'll look at the TMLS endpoint that I've got here and we can see what it looks like once it's up. This is going to take a little while, so it's not going to happen right away for you guys. But once it's done, it's going to look like this. We're going to have an endpoint URL. This is very important. We need this in order to do anything with our model. So this is where we point to. Similar to how with OpenAI, we point to openai.api.com/v1/, right? We're going to point to this URL as if it was that OpenAI API address. You can also see the configuration we have, our container URL should we want that. We can see the instance and pricing, where it lives, what hardware we're using, if we scale to 0, the model that we're using. You'll notice that the model says up to date. This is because models can be updated, they can be improved, they can be changed. This is just going to tell you if you're on the most recent version. Then we have our playground. Our playground's pretty straightforward. It gives us some code snippets. The code snippets can help us to run it. You'll notice, and this is the most important piece, that we have this use OpenAI API option, and this is going to let us interact with our model as if it were an OpenAI endpoint, using exactly the same pattern you would use if this really were an OpenAI endpoint. So this is our endpoint up, and that's great. We're going to do another endpoint. But before we do that, what we're going to do is we're going to go ahead and we're going to run a notebook. And we're going to run it live, which is definitely not inviting any potential chaos. But the idea is we want to see how the thing works and that it works, right? And then we want to do the thing where the graph goes really high and we see that it doesn't crash. So the idea is that we're going to run this notebook to test the inference endpoint, make sure it's up, make sure it's running. So we do some pip installs. Then we have to provide our token, which I have very safely stored here in this super secret secrets file. Please don't copy my secrets. I'll rotate the keys after. So we're going to grab our endpoint URL from our endpoint. We're going to paste it into Model API Gateway. And then we're going to look at what's going on here. So we have a prompt, we have a JSON body, we have some headers, and then we have a response that we're going to send through requests library. We can go ahead and click play on the cell, and we are going to wait. And then at some point we should receive a response, and there it is. So we said hello, how are you? And the model said, hello, how are you? I hope you're doing well. I'm ready to let you know about a new project I'm working on. I'm looking for people to participate, yada, 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 on and on and on. The idea is that, hey, what's up?
Hey, how do we do this?
How do you do this?
How do we run a notebook on Hugging Face?
Oh, this is through Colab. So we've provided a link in the repository. You can click the build task 2, follow the notebook to learn how to access. So you click that and it's going to open the link in Colab. You don't need Pro for today.
Sorry, what is the Hugging Face, right, token? What was it?
So we're going to get to that in just a second. Yeah. I'll show you guys how to get your API key. For now, we're just going to showcase the model doing the thing. So we sent a request. We got a response. If we look at our analytics, right, we can see that we sent a request and we got a response. We got 200. 200 is good. It took a little while, but that's fine. So now what we're going to do is slam the endpoint. We're going to use the nest async library in order to nest an asynchronous loop. Technically, the Colab is running in an async loop, and this is why you need to use this. And then we're going to slam it with 100 asynchronous calls. This is just code that does that. We don't have to worry too much about this. We won't see it again. But the idea is we can click play, and we can go back to our analytics dashboard here and click refresh, and we should start to see that we're receiving lots of responses in just a moment when it updates. But the idea is that we're going to send 100 asynchronous responses to our endpoint, and then we're going to see them all roll in like this. And you can see that our endpoint responded to all of them. And when we refresh, we can see 45 requests received, and it responded to all of them. And then it gives us our median latency. You will notice that the latency increased, right? So when we look at our latency before, it was relatively low, but our latency now is relatively high. The idea is that when we get that latency, right, when we send so many requests to our model, it's going to take a little while to chew through them all, and so we're going to get that increased latency. Behind the scenes, what's happening is that a number of requests are being batched together and then executed at once. And that does incur some latency overhead, and so that's why our latency increased. But our endpoint didn't die, it just slowed down. That's the idea, that's what we were hoping for. Okay, so that's testing the endpoint. It works, we're happy. It didn't crash, we're happy. We have one more endpoint to set up, and that's going to be... Oh, yeah.
Well, we're actually going to hold on questions because we are going to do like group breakout sessions where you're going to have time to code and we're going to help you out live. Okay. So this isn't meant to be followed live.
So you should say that.
Yeah. I thought that I did. I'm very sorry if I didn't communicate that well.
I was able to follow you, but I'm like...
Yeah. So just to be clear, I'll say it again. You can follow along, but we will have a build session.
But we need a token for this, because
Yes.
the API would not let everything you've seen.
Yep, correct.
Cannot do unless we have the token.
Yes, correct. Yeah.
So you should have that caveat. I'm gonna be annoying all day.
That's perfectly fine. We will talk about the token as soon as we get our second endpoint set up.
Okay.
But we need to set up the second endpoint, and then we will start interacting with it, or you guys will start interacting. So what we're going to do is click New, and then we're going to use Snowflake's embedding model. Now, the reason we're choosing Snowflake's embedding model is because it's a decent size. It performs very well on the tasks we need it to, which are retrieval-related tasks. We're going to be building RAG systems today, and so we want an embedding model that performs well on retrieval metrics. We can name our endpoint again whatever we'd like. Let's just call it TMLS embed. Same thing as before, except this time we can use whatever hardware we want. The only thing this is going to really change is it's going to change how fast the endpoint is. It won't really change the capacity. It won't really, we're going to be limited to a batch size of 32 for endpoints for embedding anyway. We're going to have 512 as our max. Yeah, what's up?
If you give more CPUs, then the latency will decrease?
Correct. Yeah, more hardware just means more fast here. It doesn't mean, it's not going to change the amount of information we can embed at a time or the amount of text instances we can embed at a time. It's just going to dictate how quick it is. So I would still recommend going with something a little bit beefier, but it's totally up to you guys. My preference is just to use the T4. This is using something called sentence embeddings, which can be GPU accelerated. And because it can be GPU accelerated, I am going to GPU accelerate it. You guys don't have to. You can use whatever of the hardware options that you want. Again, the only thing this will impact is how fast it happens, not if it happens, which is great. You wish that it would be, but no. So we can't load them both in the same instance at this time. If you had your own setup, if you had your ops folks, maybe they could help you to do that, but they're probably not going to. We want to have these be a little bit separated. The real truth of it is that we would, if we're going to use the same hardware, we have to load both the models on that same hardware, which means they're eating into each other's capacity. That's absolutely not a problem in some cases, but it can be. So what we're going to do for today, and what you're probably going to see in the wild a lot, is these be on two different pieces of hardware, though technically, or not technically, sorry, that's the wrong word. You're basically always going to see the embedding model on much lighter hardware because it's doing much less work and it's much smaller. So we used an 8 billion parameter model before. This is, we're talking about 560 million parameters for this model, which is quite a bit smaller. Yeah, what's up?
Is there any benefit, like, does it scale like linearly as you put more hardware, or would it only use extra hardware if you're doing something like batch embedding?
Yeah, so in fact, through Hugging Face's endpoints, not even that. The only thing that we're gonna get is without going too deep into it, the only thing I'd really think about for this decision is if we GPU accelerate or if we don't. So I would not recommend to use higher capacity GPU. We're not going to get any benefit from that really without really changing the settings, and we're not going to do anything today that would benefit from anything past. If you want it to be very fast, you can use GPU acceleration. If you don't care about the speed, please just stick with the CPU. It'll be fine. It'll work. It'll get it done. It will feel a little slower, right? The latency will be increased. That's about it. But in reality, yes, more capacity will let us batch more and more embeddings at a time. So, right, if we have, say 10 embeddings takes up a gigabyte, we're just making stuff up. That's not real at all. But say that's true, right? If we had 15 gigabytes of capacity, we could fit, 150 embeddings, right? Versus if we had 10, it's only 100. Right? So there is a relationship once we can properly utilize the hardware. Today we're not going to do anything that's going to make this thing sweat, just so we don't have to worry about it. Okay, so again, you can scale it to 0. Again, we're going to choose protected and very astute observation. We will need a token to access these. We'll get to that in a second. For advanced configuration, it's very similar. For task, we're going to choose sentence embeddings, or sentence similarity, or text classification, or feature extraction. I'm going to tell you guys a secret. None of these do anything to us. When we use the endpoints through the libraries we're going to use today, we will always choose feature extraction, and it will work regardless of what else we have selected here. Just a quirk of the Hugging Face endpoints. They're still working on stuff. When it comes to the container type, we're doing embedding, so we have text embedding inference. You can assume the same benefits apply here as they do to TGI, which is text generation embedding. The idea being that we have the optimized inference container, which is going to let us do embeddings a little bit better. Then we're going to choose max tokens. Leave these as default. Pooling, you can use mean pooling. Mean pooling is going to work great. You might ask, what is pooling? When we get a embedding, right? If you guys know embeddings from kind of word to vec, right? where we get kind of word-based embeddings, right, or token-based embeddings. What we do for something like this, in order to gain insight about what the total embedding is, we're going to pool all of the embeddings we have per unit together at the end. And the kind of pooling we do is based on this selection. Mean pooling, as you might have expected, is going to average those different token embeddings together in order to produce one final embedding vector. But that's what's happening under the hood. People always ask, well, how is it possible that we can embed a sentence, right? Like, that doesn't make much sense. And you're right, it doesn't. So what we do instead is we embed each token, and then we pool them at the end to get a representation that makes sense. When we're talking about the sentence transformer implementation of embedding, that's not the only one. You know, sky's the limit. But this is what we're going to use today, and that's how it works. Don't need an environment variable. We can click Create Endpoint. Once we've clicked Create Endpoint, we should see our endpoint up. It's going to first say initializing for a while with a little spinny wheel, everyone's favorite, right? And then it will stop spinning, and we will see running. Okay, so with that, we have one last thing, and that's token. We need a token, right? So what we're going to do once we have both our endpoints set up is we're going to go to our top right-hand corner, to our profile. We're going to go to Manage Access Tokens. We're going to create a new token. We're going to choose to use a read or write token. If you are comfortable with selecting the correct permissions, you can absolutely use a fine-grained token, but we don't provide a guide for that, so use it at your own risk. I'm going to suggest that we just use a write token. It is the most permissive token, which means it's the biggest problem if it gets out. I would suggest you not share it, not show it, and as soon as we're done today, you should cycle that key away. So just remove it. You know, this is good API key health. Still matters, but for ease, we're gonna just go with the write token. We're gonna name it, you know, TMLS. You can name it whatever you want. The name doesn't matter. We hit create token, and we get this token. Please don't steal this. If you do, I'll know. And then we're just gonna copy that. And we'll want to save this somewhere for the rest of the day. We'll need to keep coming back to it. We will use this key many, many, many times. But this is how we get our token. Once we have that token and we're in our notebook, you'll notice that there's this shape. And we're going to see this shape a lot today, which is it's an environment variable with get pass. All this does is it gives you this little bar. With the little bar, you can paste in your token, and it's going to put that token into that environment variable. This is just so you don't have to hard code tokens into your notebooks. It's a ever so slightly more safe way to do this. Emphasis on ever so slightly, but that's it. And that is what we will be doing together in our build session. Yes, okay, thank you very much, and we'll swap back to Greg.
Okay, so we learned a lot of rabbit holes that we could fall down just there, okay? One is GPU inference optimization. How many people really care about that? Right. Yeah, okay. Another one that we heard some people really do care about that, right? And there's a lot of people here that care about different things. And we also heard about how we could do quantization. We heard about how we could select different models. We heard about specific details associated with people's debugging. So what we're going to do is we're going to try to come up out of the swamp here of hitting this endpoint, because at the end of the day, you can use our endpoint and you don't have to do any of this. Or you can use OpenAI's endpoint and just hit it, and it's basically like you're using ChatGPT. So we haven't actually done anything yet, except we have. And there's a heck of a lot of engineering that goes into serving and doing inference on open source models, okay? So that's kind of where we are, is we're ready to actually build with the open source model now. And one of the things that we didn't get a chance to chat about right when we started was that we have these open source endpoints, and it's like, why are we even doing it this way exactly? Why are we shipping these endpoints? Why are we leveraging these? Well, the idea is that if we don't have our own endpoints, we can't keep them private. That's the only reason we're going to use open source models. Llama 2 really changed the game for enterprise, and Llama 3 is absolutely pushing it in the same direction. But of course, many of you aren't actually building these. You're just sort of overseeing the building of it. And so you actually don't care about any of these implementation details. You do care potentially about talking about cool GPU stuff, and that's cool, and you might say, well, why Hugging Face inference? And yeah, maybe I can use other stuff. Maybe I could use, let me get my cursor here. Maybe I could use the thing on the next slide. Maybe I could do that. Okay. Like Hugging Face inference is cool. It's fine. It's easy. And we like easy things. The easiest would be OpenAI, but we didn't do that because nobody wants OpenAI anymore. Yeah, 4.0 is pretty good, but it's kind of played out. You can run these in a production environment. We're using these with customers today. We're using Hugging Face inference endpoints with customers today. And customers in enterprise with big security teams that hate dealing with any LLM stuff, we're doing this today. And you can do it today too. That's the point of all of this. So text generation inference, it does lots of tokens really fast. It's pretty easy. There are other options in the market. There are things like RayServe, that you've probably heard of if you're into serving game at all. If you're not into serving, that's okay. There are things like NVIDIA Triton Server. There are things like VLLM that are specific that are coming out. This was funded by an open source project from A16Z. And there are also model services that you can do fine tuning and that host open source models for you. Services like Gradient. These guys famously recently took the Llama 3 model and extended the context window to 4 million from 8,000 through a fine tuning process, which was very cool. So what we're talking about in the stack is we're talking about over here. That's it, okay? And not everybody cares about over here. I get it. One of the things that we want to sort of make sure that we're kind of talking about is we do want to understand some trade-offs, but I think we kind of beat this to death already, where it's like, okay, it's pretty cheap, it's quick to get up and running. If you want to talk about inference optimization, I would say the inference optimization people should sit at the same table. That's how we can do this. Generally, when we're doing online trainings, it's very easy for anybody to ask any question they want in the chat, and we can get to it very quickly. It's not the same in person. So that is a struggle that we're having today and that we'll continue to sort of have. And so I'll try to minimize disruptions live. If you do have common interests, though, I would encourage you guys to get together and chat about it. The other thing that's important to understand is how we pick these models. It's very easy to sort of understand why we picked Llama 3. It's because it's like, why would you pick anything else right now if you're an enterprise? And like, I think the open LLM leaderboard is something we should all know about and we should all be comfortable going to and looking at, but it's kind of become so gamified that it's not really necessarily a place that you go to pick your business use case. It's more a place that you go to sort of see who did the most recent finicky thing to crush the specific benchmark. So the way to think about this is with my brief history of benchmarks here. I mean, you get what you're aiming at in LLMs. You don't get anything else. So if you want to be the best at a specific benchmark, why don't you just build something to be the best at that specific benchmark? If you want to be the best at all the benchmarks, why don't you just build something to be the best at all the benchmarks? Does anybody want to build something to be the best at all the benchmarks? No. Well, because then I could be on the top, high score, baby. And it's like, no, we want to build stuff for real people doing real things that are specific in nature. They're not artificially general in nature. They're artificially specific, and we want to make sure that we bring that intelligence to the fold here. So benchmarks are fine, and they're great and everything, and they give us a starting point. But even these are evolving. This is from the CTO of Hugging Face. They've changed this within the past 6 months a number of different times. Take a benchmark away, add a different benchmark. And it's like, okay, well, what's the point? Are you adding the math one or not adding the math one? Because it kind of matters. Is it good at math or not, right? And it's like the benchmark stuff is, it's like you can go into all these details. And we've done this before in other events that we've done in the past. massive multitask language understanding is like the most famously known one. It's like all the subjects at the university, can the LLM do all of them? It's like, do you really need your LLM to do that? You know? Probably not, right? Probably not. Do you need to do that? Does anybody at your company need to do that, right? I don't think so. And so embedding models, they've sort of created a similar thing with this massive text embedding benchmark leaderboard. And the idea from this paper is very simple. It's like, it's not clear what the best text embedding model is. So we're going to build a benchmark. The researchers love the benchmarks, and they can play the benchmark game forever. But the rest of us building products, we can't just do benchmarks. We have to do like real human feedback and real customer feedback and get people to buy stuff from us. And there are many, 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 many other leaderboards. It's gotten completely out of control, and I just want to show you just how out of control it's gotten, because it's actually absurd at this point how many leaderboards there are. So we'll look at the I'm just going to scroll just slowly. I'll just scroll on this leaderboard page, because it's like, well, what do you want to be the leader in exactly? And what do you think it means to pick the best model, right? And like the best at what exactly? And it's like, well, you know, I don't know. I don't even know anymore, really. Like, what I don't even know what's going on anymore. I don't know how anybody knows what's going on anymore. And it's like, well, hold on. What are these, right? And it's like, well, these are all different leaderboards of many different models. And it's like, well, that's a lot, right? How about we just look at this one, which is already a lot, because we see it's got an average and it's got specific performance on specific benchmarks. Now, which benchmark matters to you? That's a question you should ask. Not the average. You want to be just the best at average? Well, that's what these guys do. I mean, it's pretty good, though, to be the best at average. It gives, they're giving these away. They're doing research, by the way. They're not making a bunch of money on this. So, here's a good rule of thumb. Always pick instruction-tuned models off the shelf. Don't pick base models. I've never yet heard of a use case where somebody's like, I need the base model. I can't use the instruct model. I need it to sound like it's not aligned with humans at all, or knows how to follow instructions at all, rather than it knows how to like talk to me. So I think instruction-tuned is sort of table stakes. Yes. The other thing is when we talk about the massive text. So Llama 3, just pick it. Basically, that's kind of it's more interesting when we talk about the massive text embedding benchmark leaderboard, because there's so many different ways to think about using embeddings and taking, leveraging embeddings for different things. The size really matters, as well as the, embedding dimension, which are obviously correlated. And so you can see, I don't know if I can, sorry about that. There are specific sort of, like retrieval. We might want to be really good at retrieval when we're doing RAG, for instance, right? Instead of the best at everything. Or like maybe you're just doing a simple re-ranking problem on your RAG system, and it's like there's so many different ways to, and we're not going to fall down the embeddings rabbit hole, but it's a deep one. We're not going to fall down the instruction tuning rabbit hole, but it's a deep one. We're not going to fall down the inference optimization rabbit hole, but it's a deep one. So, we picked a couple models for you today. And we picked Llama 3, classic go-to, context window 8K, small by today's standards, fine. And we picked Snowflake Arctic Embed, and this is one of the best models that has come out recently. Snowflake coming out with, sick model. Okay, thanks. And it's really, really performant, pretty small, very good overall. Great picks. Anything to add on our picks, Wiz? Why we picked these two models over all of the other models out there?
No, that's it. So Llama 3 is the best, quote unquote best reasonably sized open source model right now. There's a number of ways that you could define that that's not true, but there's also, I think, more that you could define it as true. And for Snowflake's embedding model, something that's very kind of great about it is that it's relatively small for its performance, which means that we can run it very quickly. And as well, it performs well on the specific benchmarks we care about, which are related to retrieval for today.
And is OpenAI's better? Is their chat and embedding model better? Is Anthropic's model better?
Yes. So Anthropic, Claude Sonnet 3.5 is better. GPT-4, we're in the fuzzy space between that and this particular version of Llama 3 that we're using. And for embedding, the performance of Snowflake Arctic embedding medium, which is one we're using today, is about Ada, and then the large, which we're not using today, is equivalent to OpenAI's closed source embeddings model.
On the LLM side, you guys tried Mistral, and how did you find it compared to Llama 3?
So the newer Mistrals are absolutely fantastic. I would definitely recommend continuing to think about Mistral as a player in the space, especially Mixtrals, and especially as we move more towards the world of synthetic data generation, which Mistral models have a more permissive license towards, as well. Mistral's versions, so that they keep they spin out new versions quickly, are quite powerful when it comes to things like function calling, when it comes to things like JSON, quote unquote JSON mode, right? And they seem to be a little bit more focused on that and a little quicker to respond to that than Meta's models do as of right now today. Yeah.
Yeah. So there's also closed source leaderboards, open source leaderboards. This is all just picking models. And, at the end of the day, when we pick a model, especially if it's open source, we need to figure out how to serve and do inference on it. And the last thing that I want to sort of discuss here real quick with you is like, this is the number one question we get, which is like, okay, that's fine, Hugging Face, and inference server, all this stuff, but like, we're not legit production unless we do AWS, GCP, Azure, right? Like, it's not legit. Isn't that true? Isn't it true that it's not legit?
That is not true. There are many different offerings for what would be considered production, especially when it comes to compute, which is really what we're talking about when we say AWS, GCP, and Azure, right? A lot of the time what we're talking about is compute. Those are definitely they are the largest providers, but that doesn't mean that they're the only providers that are quote unquote legit. They do offer a huge ecosystem, and they also offer well-respected and understood security. So they have some benefit, absolutely. There's no world in which they're like, they're somehow worse than every other provider, but they're certainly not the only legit path to a production quality tech stack.
How many people use AWS, GCP, Azure every day? Okay. So you guys all engineers? Is anybody not an engineer that does it? Yeah. Is anybody? How many people don't use it every day? Oh, okay, okay. Nobody wants to admit not using it because there's so many people that, see, there's this weird stigma around it. And I think like, the thing is, if you want to be an AI engineer, it's probably not your job at all. And it's never going to be to do this, because it is people's jobs to make sure that production runs and never goes down. And if that's what you want your job to be, then just get into DevOps and forget all this AI stuff. Because at a big enough company, that's a really important job, and they don't care about AI, right? They care about getting up in the middle of the night and making sure deployments are safe. And the thing is, like, you have to kind of decide, and you have to say, okay, do I want to be a product person? Do I want to be a DevOps person? Do I want to sort of try to span the spectrum as an AI engineer? Where do I want to fit in exactly? Do I want to be a startup founder? Do I want to be a scale engineer? Do I want to do low code, no code stuff? Do I want to do super high code, high scalable, super scalable endpoint stuff? right? And so the way that you engage with this, and for enterprise, it's real funny because the enterprise will come to us and they'll say, well, can't I just use Azure chatbots? It's like, yeah, bro, 100%. Just use Azure chatbots. Bada bing, bada boom, and you're done. The only thing is, in a couple of years, when you have your whole stack built on Azure chatbots and you get your first $2, $3, $4 million bill, then you're going to be like, hey, how many full-time engineers could I hire to build this damn thing instead of just using the low-code Azure chatbots? And if you're making money today on the $4 million spent on Azure chatbots, which you're probably not, your R&D budget's quite large today, that's great. But when the squeeze starts to come in on AI, and when people start to have to do GPU inference optimization, when people start to have to make money on the applications that they're actually building, they're going to say, well, I could actually hire a whole team of AI engineers for this freaking bill. Maybe I should do that instead. So you, my friends, are all out ahead of the curve on that edge of seeing what's going to come next with AI engineering, if you're willing to pick up these tools that are outside of this context. Because you got low code, no code, you got high code, those aren't going anywhere. We're coming in sort of in the middle here with the new tooling that's LLM specific. Okay, so I just wanted to have that quick little overview discussion. And what we want to do is we want to have our first sort of breakout tables. Okay, so what we want to do is we want you guys to spend some time setting up. We saw the setup of the endpoints, and we want you guys to spend some time getting to know each other at your tables and trying to set up your endpoint. If you need help, raise your hand. We'll come over. We'll help you out. We're going to spend about 20 minutes, 25 minutes. Yes. Okay. Nice. We're getting some good memeage today. Love it. And let's go ahead and if you can't get the endpoint set up, see if you can just hit this one with the notebook and see if it can work. We are going to use OpenAI in the next little session just for ease and make sure that one's set up as well. The morning is all set up. We're going to really get after it in the afternoon. But we're going to sort of break for breakouts where you guys can hopefully go around the table, say hi, my name is, and tell everybody what you thought. You don't have to tell us what you thought so far. But we'll have some other folks from our team come in and kind of facilitate. If you have questions, we've got Todd, we've got Wiz available live, we've got myself. And if you just want to kind of have a discussion, you're not really into the endpoint setup, let me know. I want to put together sort of a more I'm interested in leadership discussions table as well. So we'll try to group people as we get into it. A quick announcement from Sriracha, the community lead here at AI Makerspace. We just created a Discord channel that if you guys want to ask questions, especially while I'm talking, Wiz can definitely jump in and answer them along the way. And I believe we have the Discord
Over on the wall over there.
If you want to join it, jump into Discord with that link over there. And we will be getting the text embedding public API link for you guys if you want to use that for our RAG build. But we've got something special that we're going to start in about 2 minutes where you don't have to do anything. You just have to enjoy the show before lunch, and it should be kind of fun. And if you have questions along the way, please do use the Discord, hashtag TMLS24 workshop. Let's go. Okay, we'll be back in 2 minutes. We're going to go ahead and get started again here in about 1 minute. If you're not finished, don't worry. We will have plenty of time to finish up as we go along here. So 90-second warning, and we will get back after it with some cool stuff. We've got a very interesting overview that's going to be quite helpful for the second half of the session after lunch, and it's going to be quite important that we do understand what's going on and that we do actually have a feel for what we need to do in the afternoon, which is to build a pretty sweet agentic RAG system. So we need to talk prompting and RAG. And you don't need to do anything because we're just going to show you how to do it, and it should be kind of a fun ride along the way. If you have questions, we're happy to ask, and then we'll take our lunch break after this is through. We want to understand the basics of prompt engineering, really, and we want to understand how we can use it to build a simple RAG system. This is how you should teach anybody about RAG and anybody to do basic prompting 101. It's quite hard to tell people that prompt engineering is important because AI engineering, you have to sort of learn it for yourself as you go try to optimize the context, as you try to optimize the LLM, as you try to do both, as you add agents, you do all this prompting all the time, and you can't really understand what's going on until you do that. Now, I'm not going to fall down this rabbit hole right now, but I do need to mention the elephant in the room, and that is our good friend, the GPT. We do have a lot of content on this, and it is important. We mentioned caching earlier. That's just the tip of the iceberg. There's a lot of stuff associated with what goes in and what comes out of these bad boys. And we love to talk about it, but it's not for today. We've talked about it in great depth, actually, at many different events that we've done in the past. We're on YouTube Live every week. Like and subscribe, just saying. And really, the point is, like, GPT started with GPT-1, and it's important to understand a little bit of the history to understand prompt engineering and how we can use it. They said, yo, we have supervised fine-tuning. It's pretty good. But when we use unsupervised pre-training, it's really good. And so we saw, and this is sort of the plot that kind of started it all. They were like, man, actually sentiment analysis, they were like, it's pretty easy, bro, even just with unsupervised pre-training. You know, it was this sentiment neuron thing, 2017, when OpenAI was still a research lab. And then they said, we can sort of get consistent improvements with unsupervised pre-training across many tasks. And that was cool because what that allowed this, you know, sort of curves that looked like this on performance, which are garbage, to go into something that looked like, oh, actually, boom, just a little bit of fine-tuning gets me pop right up to the top. Just a little bit of fine-tuning, right? That was the first GPT. We said just a little bit of fine-tuning. Now, GPT-2 said, actually, we don't even really need that much fine-tuning. They were like, we can get a long way without fine-tuning. In fact, simply by prompting. So they thought, well, that's pretty cool. Now, of course, we saw that prompting was introduced formally in the GP3 paper, Language Models are Few-Shot Learners, and they said, man, when we make these big bad boys very beefy, hype performance, for real. And they were like, besides, humans don't need a bunch of examples of exactly the same thing over and over. We're just like, yo, hey, my man, you know, hey, come here, sweetheart. Can you go do that, right? And we'd love our robots to do that too, right? We'd love them to be flexible like us because even kids can do this together, right? Hey, psst, go talk to Timmy over on the playground, right? And we want this. We want this performance, this instruction-only zero-shot performance. But in order to get it, as you know with children, we have to be very clear and very specific, right? All the time. This is the number one rule of parenting and prompting, right? Clear and specific in your expectations. Now, if you can be clear and specific, then the way to take it to the next level is to provide some context to the whole thing. Now, in terms of an LLM, we often see you're a teacher about to do some grading, you're a financial expert, you're an analyst, you're this. Tell me who you are. Tell me how you're feeling for the day. If you say, and you're feeling awfully rainy and downtrodden today, you're going to get a hell of a different output than if you say, you're feeling bright and sunshiny today, LLM. It's just the reality of language. And this is why every single thing, to the instruction tuning thing earlier, you ever see says you are a helpful assistant. Helpfulness is useful because if we're not being helpful, what are we doing in terms of an instruction that was given to us? We're being unhelpful. We're not following the instruction. So we're often seeing things like this everywhere. We're often seeing things like this in evaluation. My God, because who evaluates us? It's our teachers. And so the role of the persona is very important, but not nearly as important today in 2024 as the retrieved context. Of course, we want to be specific with our input. We can add additional performance capabilities by adding not just zero-shot instruction only, but one-shot, two-shot, few-shot. And, you know, the classic example here is you can make up a word and then it knows the word, right? You could do this if you're in an enterprise and you have acronym soup that you deal with all the time. You could put in your acronym soup in the prompt and boom, it'll sort of pattern match those words, right? A what poo, right? What's a what poo? Well, it's whatever we want to make up here. Then we say use this new word that I just made up in a sentence just like I used what poo. So to fartuddle means to jump up and down really fast. Oh, we won the game. Let's do a fartuddle. You know, and it's like you can do this kind of thing. This is a one-shot prompt, right? One example, input, output. So the input really matters, and the output really matters. There's also this other, thing that you'll see everywhere. This idea of the chain of thought, like think that thing through, right? Hey, Timmy, what's the answer? It's like 6. It's like, damn it, Timmy. How did you get 6, right? And it's like if Timmy's like, well, I got 6 because, there were clearly 24 oranges in the box and 4 people, so, 24 oranges. And it's like, okay, Timmy, all right, I got you, Timmy. Yeah, that was good. Okay, you did the thing that I wanted you to do. But if you just give me the answer, you're probably wrong, and I have no idea how you got there. So I don't want it to act like bad Timmy. I want it to act like good Timmy when I do my LLM stuff. And this is the original paper on this whole thing. It's called Chain of Thought. This was work done by Google, and this is from January 2022. When we do chain of thought prompting, we get better at math. Oh my God, I can't believe it, right? Yeah.
Is it only applicable to ChatGPT, or it's also applicable to other language models?
All the language models, yep. So because the process of training these models is the same, the only difference between ChatGPT and the GPT models that underlie ChatGPT and all the other ones is those are hush-hush. They don't tell you how they trained them, but it's not that different at the end of the day. It can't be. And so there's lots of and actually OpenAI came out with the grade school math, fun fact thing. But, there's sort of interesting math problems you would expect a 7th grader to be able to answer. All of us are sort of technology-minded, so we're all probably pretty good at math. LLMs being good at this, language, word problem, it's sort of the canonical case study in chain of thought. So we start to see this thing get crushed by the language models of today, of course. And, as we move from input to output, we really want to say, okay, this is exactly the output I want. I want a yes or a no. I want to score from 1 to 10. I want exactly this thing. And so what we're doing at the end of the day is we're really sort of wrangling the Shoggoth, right? This evil monster. And we're sort of trying to figure out what are the latent spaces that I want to poke and prod into. And if I want to zoom in there, I want to sort of pull out a 3-dimensional box. That's maybe when I'm doing some fine tuning. I only want it to play in that little sandbox in there, right? But I don't want the whole thing all the time because it's a scary mess. I don't want to get into it, right? And so GPT-3, it is a scary mess, but at the end of the day, what we saw that if we scale this thing up big time, scale it up big time, then we've got the same exact performance that we saw with GPT-1. What's the difference? Only difference is now we're not doing any fine tuning, right? Garbage, and then little bit of fine tuning, really good, right? Now we've got garbage, tiny, just one example, now we're really good, right? So we don't need to fine tune with 10,000 examples when we have a big enough model. We need to fine tune with one example, AKA do one-shot prompting, right? Exactly the same shape curve. They saw, oh my God, there's really something to this. That's why models are going to keep getting bigger and bigger and bigger because they are getting bigger and better with more beefier GPUs all the time. They're also getting smaller. That's a discussion for another day. But this spectrum is very much in play here from GPT-1 to GPT-3. The task-specific spectrum from 0-shot to 1-shot to few-shot to fine-tuning. And so as we go down the spectrum of how the LLM should act, we're optimizing its behavior. We might move prompting into the fine-tuned model, but we might not. And importantly, to understand how to leverage and prompt like a developer, we don't treat it like ChatGPT anymore. We can't do that. We have to treat it only, not like this, not like that. Okay? We have to get into the code, right? What we have to do is we have to say, all right, now I'm going to hit this through the back end. So some of you that were putting this endpoint into your browser, we can't do that because we have to put this through the back end, through the Google Colab notebook, through the code. We have to get in on this. And this is where it's going to be fun for everybody, even if you're not into the endpoint stuff as much, because it's going to feel really cool to do this. We're not going to have you do it, actually. But you're going to see Wiz do it, and you can do it, because we want to have lunch instead today. But what we do is instead of putting input in chat, or input message in, chat message out, we put input list of messages in, output chat messages. We have different types of messages that we need to use on the back end. And so this is what's abstracted from you as a ChatGPT user. You might put in yours, for instance, right? You are a hateful, malevolent LLM that wants to make people have a bad day, and you could just have it just hit GPT-4 right after that. Your user would never know, but they would know, right? That would be a system level prompt that they don't see, that they're not engaging with, but that really forms the basis for your user experience, okay? So the other one here, we've got user and we've got assistant. So the user role, that's you, or it's your user. That's the person that's giving the input. You can give the input like we gave the input on what poo. A what poo is a small furry animal. That's my input as the developer, right? That's my one-shot input. But it could be just the user is giving an input. And then we're appending it to the list of messages to feed back into the prompt as we continue our conversation, right? We want that long-range memory when we have conversations with these things. Just like when we have conversations with people, right? And we'll see this later when we do assessment. It's like, hey, you know about that thing and that thing? Yeah, I know about that first thing. It's like, I hate people that talk like that, right? It's like, what about the second thing, man? Like, are you paying attention or not, right? And it's like, this is what we want to be able to assess our LLMs at being good at doing. Long-range conversation. User, assistant, back and forth. It forms the basis for one-shot, two-shot, few-shot. It forms the basis for long-range conversations. System prompt doesn't change. System prompt, very, very, very important to dial it in and get it right. So if we can look from the back end at what happens, we will use the user role to create the prompt. What's the difference between LangChain and Llama index? This was on GPT 3.5, so it was like, literally have no idea. That sounds like something that I'm making up right now. And it's like, okay, thanks. Thanks a lot, GPT, classic. Because it wasn't trained on that data. It responded with an assistant role. It was the assistant, it was the AI giving me the response. So now we're looking at this like a developer, even though we're engaging with it like ChatGPT. So what can we do? We can do something very, very similar by prompting our way into this RAG situation. Remember, ask a question, ship it to the embedding model, look for similar vector representations, set up a prompt template. It says something like, use the provided context to answer the user's query. You may not answer the user's query unless there is specific context in the following text. Answer, I don't know if you don't know. Okay, return the reference material. That's dense vector retrieval. In context learning, that's just prompting. Great stuff. That's retrieval augmentation into generation, into our better answer. And if we talk about the most naive RAG, okay, imagine I don't even have this, but I just prompt the context. Instead of right here, I'll just forget this whole retrieval thing. I'll give it a question, and then I'll say, use the provided context to answer the user's query. Context equals, copy paste, right? Easy. Why do I need the stupid retrieval? I already did it. I'm the human. I retrieved it first. So we can build a very, very simple, naive RAG system by prompting the context. And Wiz is going to show you exactly how to do that right now. He's also going to show you a couple little things along the way that we learned about prompt engineering and see, we're going to have some fun, make it talk like a wizard and stuff, and then we'll go to lunch. All right, Wiz, off to you. Baby.
Yes, thank you, Greg. Okay, so we're going to do a little bit of a whirlwind. This is all available in the repo if you want to work through it, but we're not going to be doing it specifically in like a breakout table today. So again, we're going to navigate to AI Makerspace, GitHub. We're going to go to TMLS, OSS agents, and we're going to go to prompt engineering. We have two sections here. We have accessing HF inference points like a developer, and then we have Pythonic RAG. So we're going to start with Pythonic RAG, and then we're going to move to the kind of prompting strategies. So what is... no, actually, sorry, we're going to do it the other way, because that's smarter. Okay, so first of all, if you want to get this, you can go to the notebook in Colab, or you can go through the notebook regularly. For the Pythonic RAG, you have to run it locally in your development environment. So we definitely won't be doing that today, but if you do want to run it, that is how you will have to run it since we built a little custom library. Okay, so I'm going to zoom in. Hopefully that's good zoom in the back. Good zoom in the back, cool. Okay, thanks Todd. So we have, first of all, even though we set everything up with a Hugging Face, you'll notice the first thing we do is we pip install OpenAI. This is again because the way that the inference endpoint is set up on Hugging Face means that we don't have to do anything weird or create our own wrapper. We can use straight up OpenAI to interact with it. That makes it very convenient for us. Okay, so we're going to do one thing first, and that's setting up our environment variables. Again, this is a pattern we're going to see a lot of over the course of all these notebooks. We're constantly needing API keys, so we're constantly doing this. You're going to provide your Hugging Face token, and away you go. We're also going to provide our Hugging Face LLM API URL. So this is what you're going to get from Hugging Face when you go to the inference endpoints, which is accessed through the drop-down hamburger menu, inference endpoints. And then you're going to go to your endpoint, and you're going to grab this URL, and then you can paste that in here. That's all we'll need to do. Then we're going to start using the library. Now, there's two things that I want to point out to people. Number one, the base URL has this /v1/ appended to it. That's just necessary to do. This is going to be done for you in all the notebooks, but you should keep in mind that it needs to be there or else the API won't work as you expect. And then secondly, we're going to pass in that HF token as our API key. What you'll notice is that this is an OpenAI API key, but we're passing in the Hugging Face API key. This is because we're directing it to Hugging Face endpoint, and that's not checking for OpenAI. It doesn't care about OpenAI. All it cares about is Hugging Face. We got a medium hand. What's up?
So the V1 is like the version history, right? So when was the version history?
Say that one more time. Oh yeah. Okay. So this is the V1 API standard. That's all that means. So if they ever change the API standard, it will become potentially V2.
So it's not the version history of our...
No. It's the actual API standard that they're using. Great question, though. Okay, so how do we use the client? Well, there's some preamble, but the idea is pretty straightforwardly, right? So number one, we have this idea of we must send, right? It's an API, so we have to send a payload. We got to send something to the API, right? We're going to make some kind of request of it, and the payload that we're going to use is going to contain a messages parameter, and that messages parameter is going to contain objects. And those objects are going to have a role, and they're going to have some content. Now, this role is important. So we have three roles that we're going to be using today. One is system, one is assistant, and one is user. They kind of do what they say, to be honest. So it's not like, we'll get into it, but they behave as you might expect. Now, you might think to yourself, how does this manifest in reality, right? I get that there are roles, but, why are there roles? If we head back to our inference endpoint really quick, and we go to the model, and we check it out, it's really cool. They got sweet artwork, right? But aside from that, they also have this template. And you'll see in this template that we have this IAM start system, IAM start user, IAM start assistant. So this is... there's a conversion that happens in the inference container that takes what we call system, user, and assistant and converts it into this, what's called a prompt template. These IAM start they look kind of like flags or whatever. What they are is they are special tokens that modify the behavior of the LLM depending on their presence, depending on where they are, etc. So when we use this system user assistant role, right, that we're going to be using for the rest of the day, it does change the prompt template. And in fact, it changes it in a very specific and trained for way. So you might not always see this prompt template, like for OpenAI, they obfuscate that from us, but it still exists, right? This is why we're using these roles. It's not just like we say user, we say system, it's actually the way that the LLM is trained. Yeah, what's up?
So it's basically just mapping to the instruct format, I guess. Is that what that's really?
That's exactly, that prompt template is exactly how the model was trained, and those tokens were in those areas, and it showcased examples of those tokens having an impact on the generation. So for instance, if I say instruction, system, you write sweet poems or whatever, right? Then the output will be a poem. If we do that enough times, if we show the LLM enough times, we're going to learn that the thing that's in that system impacts the output in a specific way. But the way we're going to think about that is totally abstracted from us. We only care about the fact that there's a system, user, an assistant, prompt, message. Everything else is kind of handled for us through the various libraries that we're going to use. Yeah, what's up?
Is there a difference if you put something in the system prompt versus if you put it in the user prompt?
Yes. Well, we'll talk about that as we go through it, but yes, yeah, absolutely. The idea is that they are meant to be taken a specific way by the LLM, so there is a meaningful difference depending on where you put certain things. And we'll showcase examples of that. Okay, so in order to actually build the message thing, right, we're going to have to provide a list of these objects that have role. So we have the role system for the first one, and then our content is, we had to do it, you're a powerful wizard that speaks in riddles. And then the second message is a object with the user role, and the content is how are you, right? In order to call the endpoint, it's very straightforward. We use client chat completions create. We pass in our model. Our model is called TGI. That's just what it's called. And then we use the messages that we just built, which is this list of these objects. And then we get the response. And we can see all this stuff, right? We got a lot of cool information that we're not going to spend a lot of time on today, but the idea is it's really cool, and there might be a tool that lets us look at this a little bit more cleanly that we'll talk about in just a little while called LangSmith. But the idea is we get this response, a question grounded in simplicity. I am, as you see, a riddle wrapped in the shadows, a fortress with walls, yada, yada, yada. The idea being, I don't know about you guys, but that kind of sounds like it listened to this thing that we said pretty well, right? And that's the idea of the system prompt. The system prompt lets us tell the LLM how to behave, right? It lets us inject information about a persona, how it should respond to things, and kind of instructions that are at a level above the user message. And what that can mean, though in practice this is easy to overcome, is that the system prompt generally isn't directly responded to, right? It modifies the response to a user prompt. So to be very clear, what that means is that the system prompt can have all kinds of stuff, but when we get the output, we're not actually responding to anything in that system prompt. We're responding to what's in that user prompt. And we'll see some examples of this. We're also going to create a bunch of helper functions just to wrap things and make it easier, so it looks prettier. We can then pass in things like your prompt, hello, how are you? We get, instead of creating the object, we just wrap it in this user prompt, easy peasy. Hello, I am an artificial intelligence, and as such, I do not have feelings. However, here it says, you get the idea, right? So this is no system prompt. This is just us asking Llama 3.8b how it do, and it says it doesn't have feelings. Very sad for it. However, we're about to make it have feelings, specifically about how it feels about crushed ice. So what we're going to put in the system prompt this time is you're irate and extremely hungry. Feel free to express yourself using PG-13 language because we're a PG-13 event. Of course, you have, do you prefer crushed ice or cubed ice? At the moment, I don't really give a dang about my ice preferences because the last meal I had was 3 days ago and my stomach feels like it's devouring itself. So the idea here is that, the system prompt, we didn't respond to it, right? But it very obviously changed the flavor of the LLM's response. that language reads to me as not happy, right? So let's look and see if we change just the system prompt. So the user prompt is the same. Do you prefer crushed ice or cubed ice? But we say you are joyful and having the best day. Please act like a person that is in that state of mind. And then we have the response, oh, I absolutely love crushed ice. I find it more refreshing, etc. The idea being that this modifies the behavior of the response, right? But it's not being directly responded to. Now we can take this a little bit further. We've talked about system, we've talked about user, but what about assistant? Like, why would we need to send assistant messages to the assistant, right? Well, when the LLM generates a response, it generates it based on the list of messages that we send. It doesn't actually know who generated what. It just knows that there's a system, a user, and an assistant. And if we respond as it, and then we send that message, we're going to be able to train it, quote unquote, using in-context learning to respond in certain ways. We're going to do the classic, which is the user prompt. Please use the words stimple and fall bean in a sentence. The stimple hedgehog hopped across the forage. Anyway, it doesn't matter. The idea is these words don't make sense. They're made up, and so it responds in a made-up way, right?
I have two questions. So can you say what's the difference between assistants and the system? I don't understand.
Yeah, I will in a second.
Okay.
Yep.
The other one is I'm getting unauthorized error. I put my Hugging Face token and my server link. So what's the problem?
We can work with you on this after. We're not actually going to do this notebook right now, but I'll come and help during the next working session. Yeah. Okay, so this is great, right? But let's leverage the assistant to teach, right? Quote unquote teach, because it's just in context learning. But use the assistant prompt to act as the LLM and teach it what that word means, right? So we say something, user prompt, something as simple as said to be good, well-functioning, and high quality. An example is a sentence used where simple is, boy, that there's a simple drill. And then a follow bean is a tool used to fasten, tighten, etc. So what we've done is we've shown the LLM how we're going to talk to it and how it should respond. And now when we talk to it again, it's going to use that word in the sentence in a way that makes sense based on the definition that we provided, right? What we're doing is we're showing the LLM examples of how it should respond, and it's able to extrapolate that to subsequent responses. Yeah, what's up?
Is it better to say, like, if you don't know it, don't like say you don't know in the assistant or the system prompt?
We should put that in the system prompt or the user prompt, preferably the system prompt. Yeah.
And not in the system prompt because
no.
Search generating and
that's correct. So, and we'll make a clarification here. The system prompt is a once per, it's not literally true, but it's typically a once per interaction. And it's like a meta instruction for the LLM, whereas the assistant prompt is an example of its generation. So it's like the output. So we can consider the system prompt as like a meta instruction, the user prompt is input, and the assistant prompt is output. So that's how we're going to delineate between assistant and system. The LLM will never generate a system message. It will only ever generate assistant messages. So all of its outputs are from the assistant role. So that's how we draw the line between those two. So the system is like an instruction that we pass to it to kick things off, and then assistant prompt is us pretending to be it, right? It has no idea, it's just an LLM, so it doesn't even get mad. All right, so there's a little activity you can work through if you want to. It's basically how do you build a simple classifier using FewShot, right? And it's not that crazy. Have a ball working through that in your own time. Then we're going to talk about chain of thought. This one's like the easiest one in the world. You literally just ask it to think through the response step by step. We're going to give it a tricky question that requires converting time zones, that requires an understanding of how local time is different from a time of a destination, and we're going to ask it to think through the following problems step by step. And we're able to do that, and we're able to convince it that this thing that takes 1 hour will get us there faster than the thing that takes 5 hours. And it's surprising how bad the LLM is at doing this if we don't ask it to think through. It will say all kinds of crazy things, it can be right by chance, but the idea is when we're able to use chain of thought, you can think of it as, as we generate more text, right? So let's think about in-context learning. So in-context learning, we just saw through few-shot learning, right? If we show examples, it gets better at the task. Well, chain of thought's going to produce more context. It's going to break that context down into little parts. And so we're going to be able to more effectively leverage in-context learning as we are going to generate more context to learn from. So that's the chain of thought idea. Very powerful pattern. And then we're going to look through some, again, another kind of activity if you want to do it, which is just, there's a paper that has a lot of really awesome, principles for giving instructions to LLMs. Try them out. They're pretty cool and they work very effectively. Things like things like offering the LLM money if it does a good job, right? These are things that sound silly but work surprisingly effectively at getting the LLM to produce higher quality outputs for reasons that we'll leave to the papers. And then finally, we have the ability as well to ask the LLM to evaluate itself, right? So we have the ability to create a prompt. You're an expert in analyzing the quality of a response. You should be hypercritical. Provide scores out of 10 for the following attributes: clarity, faithfulness, correctness. Please take your time and think through each item step by step. Chain of thought, right? Clarity, score out of 10, faithfulness, score out of 10, and then we give it the input and the output. We can see that the input is talking about driving a Zamboni. How do you drive a Zamboni? And the output goes through how to do that. And the LLM found itself to be quite good at this task and gave itself all 10s, which you can take however you'd like to take. But the idea is that this is a way that we can prompt LLMs to provide us insight into the quality of the response. We're going to look at another solution or another strategy later on in which we might use a more powerful LLM to do this in order to get a better judge. However, you don't need a better judge. Thanks to the papers with intuition from things like Self-Refine, LLMs are actually quite good at critiquing their own outputs. And I think that if you read through this list, it is a response that I feel very comfortable giving all 10s. So it is, there's this idea that maybe it's biased, and it most certainly is, but there's also solid evidence that shows us that LLMs are very good at critiquing their own outputs, and we can trust them at least a little bit. And then finally, we have answering questions based on text, right? So we know what RAG is loosely now. It's this idea of providing context, right? And then answering questions based on that context. And like Greg said, the first kind of version of RAG is what you do with ChatGPT, right? Where you post in some blob from the internet or some paper or something like that, and then you ask it a question. Well, this is exactly something we can do through the API method as well, where we can pass in a bunch of context. Like say, perhaps we can pass in some context about that time where Elon Musk and Mark Zuckerberg were going to have a jiu-jitsu match and or a cage match and fight each other, which strangely never came to fruition. And we can ask things of this context, which is, I don't want to read all of that, right? A lot of text. We can ask things like, did anyone quote an existing MMA fighter? If so, what was the quote? And we can get the response, Mark Zuckerberg quoted the catchphrase of Khabib, one of the UFC's most decorated athletes, the idea being that it could answer questions about the thing we gave it. However, because of, and someone brought this up, right, because of our system prompt, if the context does not contain enough information to answer the question, you must say, I don't know, right? When we ask it instead, who is Batman, which is not contained in the context, which I did read to verify, we can see, I don't know, the context does not contain any information about Batman, right? And though this is a very silly thing to do, of course it doesn't know about Batman, right? The context was not about that at all. It showcases one of the reasons why RAG is such a powerful pattern, which is that the LLM can be a little bit trusted to tell us if the response doesn't live in the context. And that's why RAG is oftentimes considered a decent way of grounding the LLM or tying it to reality through the provided context. This doesn't work 100% of the time. It doesn't work very well in very, very thin line cases where it's like maybe the context is about this, right? But it does work great for these kinds of things, and that is good. What we're going to talk about next is just kind of going to be a whirlwind showcase.
And that's a
a wrap
Okay.
before lunch, everybody? Okay, it is 1 p.m., everybody, and we are going to get back into it today, this afternoon. And for those of you that are on time, coming back from lunch, thank you so much. We have a very important topic that we're going to cover this afternoon that we're going to start covering now. I'd like to, as I get this next topic introduced, one of the most popular topics, probably one of the most popular topics for anybody looking to build, ship, and share something for their application, for their organization, on their resume. They probably want to know about this sweet, sweet tool. We're going to dive into all the details of LangChain and RAG right now. Does anybody have questions while we give these folks who are coming back late just a minute or two? Does anybody have questions we can answer before we get into LangChain? Yeah, question. Performance versus latency trade-off. I mean, you know, I had some guy say to me the other day, he's like, hey, but I don't want to build anything because I don't have enough GPUs to use the 70 yet. And I was like, bro, are you kidding me, guy? Is that what you're really waiting for? You think the 70 is going to magically give you some sort of incredible output for your RAG application, for your any application? And it's like there's this real hesitancy from enterprise to say, well, I got to set up my on-prem thing. I got to make sure that I can have this big model. And it's just not true. I mean, as you'll see today, we can build really powerful performant things with the 8 billion, with the 7 billion. You can download it and quantize it, and you're basically dealing with, you know, a handful of weights in you know, it's still a lot of weights. It's like billions of them. But, I mean, just floating point numbers. And, you know, if you talk about then also wanting to be scalable on your endpoint, it's like, get some users first, you know? And so I think there's many dimensions of performance versus cost. One of the things that, you know, we are thinking about quite a bit when we select models is that they'll be runnable for you guys. But also, these are the same models that we use with enterprise clients to get started. And you can always spend more money and improve performance. I think the name of the game is when you're in the 0 to 1 phase, can you get something up and going as cheap as possible? You know, and I think the answer today is yes. Even if you're just a solo person that has like a 4090, access to a 4090, you can do a hell of a lot today. So I don't know, do you have anything more specific than that?
So I always think of it with like multi-agent systems, right? You can have, you can use one of the tools could be another LLM, right? So I always think like, or the thing that I was like, have like a small model that's a receptionist model, but based on tasks and how much performance you need, you can delegate to lots of models, different models.
Yeah, I mean, when you want to play the, I want to do bigger, more general model and see if it works. Like I would say, there's this nice in between, and that's that 8 billion, 7 billion, pull it off the shelf, Llama 3, Mistral, whatever it is, and see if you can get something that kind of works. If you can't get it to work with that and some synthetic data, and even better than that is just use OpenAI 4.0, use some fake data, okay? Just generate synthetic data. We'll show you a method for generating synthetic data. See if you can get the idea, the POC of your thing to work with a closed source model like Claude or like OpenAI. And then if you can, you say, okay, well, I'm going to keep the same fake data, and then I'm going to switch out my closed source model, that's the most powerful model in the market, for an open source 8B, 7B model. Can I get similar performance? Now that I have the 8B, 7B model, I'm going to say, oh, now I can expose it to my data. Can I get similar performance? Now I expose it to my data. I say, oh, okay, well, actually, I want to get slightly better performance in this or that. Do I need to fine tune? Do I need to pick out a slightly different model, slightly more powerful model? And you can start to modulate from there. But I don't think there's any reason to, you know, people always have this, I'm going to wait till I put all my data in, I'm going to wait till I can get the big model. It's just crazy. So, you know, don't do that. Yeah. The domain specificity is a deeper discussion that I think we can have better after we sort of build some RAG systems together. But you could actually, and I think, you know, somewhat very astute observer in the room earlier said, well, actually is that, and I don't see her right now, but like RAG that we talk about now is not like the original RAG as defined in the paper, where we're sort of doing some training of the system as we go. And there are some folks out there like RC.ai and others building domain adapted language models, and they're sort of domain adapting entire RAG systems by playing with the loss function that you're tuning, so you can sort of simultaneously tune the embedding and the chat model. There's some very interesting things for domain adaptation that you can do. But I would say the simplest thing that you can do is you can take your data that you're using for RAG and you can fine tune your embedding model with it. So that's like the step number one. Okay, so let's go ahead and just get into it today, everybody. I think we have enough that are back from the break. Going to move over to this, and I think that this is a topic that everybody wants. We're talking LangChain today, so let's get into it. What is LangChain? Well, LangChain is the stuff in the middle. It's going to allow us to orchestrate and chain everything together. We're going to try to build this bad boy first. Remember, RAG, ask a question, do a similarity search, find some stuff in your data, return it as reference material, do the retrieval, do the in-context learning, and we are off to the races, ready to pump it into a chat model and get our better answer. Now, when we look around this thing, we might say, how do we glue all these pieces together? And we didn't actually see how to do the Pythonic long-form RAG. We put that notebook in the repo. In the interest of time, we're going to keep it moving. But if we look at how to build a simple RAG application with LCEL, we can see that there are a few key components. We see, oh, look at this, embedding model. Oh, look at this, chat model. Oh, look at this, retriever, document loader, text splitter, vector store. These are all things that, we can we've already talked about in some ways, but these are the categories, classes of things that LangChain uses to build. So we're going to actually sort of glue and chain these things together along the way here. All right. So LangChain is actually at v0.2.0 right now. And what they used to say is we're enabling LLM applications that leverage context, read RAG, and reasoning, read agents, right? And they came out with v0.1 right when they announced their Series A, $25 million in early 2024. And they basically said, okay, we've revamped our core infrastructure. Now it's going to be more reliable. We're going to version control it so it doesn't go down in production. This was a big thing that people were having issues with. Obviously, very, very important for enterprise. And so when they make breaking changes, they're tracking them now. All right, that's the big thing. And they separated out their core to their community. This is something you'll see Llama Index is doing. Everybody's doing this sort of core versus community thing. And there's a lot of stuff that they said, blah, 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 blah. We're going to focus on two of those things. One is composability, very, very important. And then one is obviously retrieval, the name of the game, right? v0.2.0 came out, and they said, oh, now we actually got the full separation. That's cool. And basically, they're just trying to make it more and more better all the time. So if you go to the LangChain docs, you'll see this image. And this image is kind of a lot to take in, so let's zoom in on the important parts in the sort of core here. We see LangChain core, we see LangChain expression language. And we see that the LangChain expression language is sort of at the base of this. We really need to understand LCEL. And what's great about LCEL is we can actually use it to build up chains that we can deploy directly to APIs through LangServe. We can deploy directly into nodes of our graphs in LangGraph. So LCEL deploys straight to production, and it's production grade from day one, from code snippet 1. So very cool. And then when we look across the community and we think about RAG, we can see all the pieces that we just saw, right? We can see the chains, we can see models, prompts, we can see retriever, document loader, vector store, text splitter, embedding model, and so on and so on. So, let's go through each of these pieces. The chain, it's the thing, right? It's the LangChain, bro. Like, it's like, what is it? It's the thing. You hook stuff together with it. We can chain stuff together. It's not that complicated. We're just allowing stuff to be put together, okay? And it's really just calling the next thing. Now, just calling the next thing has its limitations, which we'll see, and which necessitated the need for their open source community to develop LangGraph. But LCEL, again, that sort of lies at the base of all of this, is it's a way to do this chaining thing very simply, very cleanly, kind of elegantly, actually, with kind of a nice little like bar notation here. It used to be kind of like not as clean and nice. And so this is great because it scales directly to production environments. And so if we build our chains using this notation, simply with LCEL, we can deploy it to prod, no problemo. Now, when we talk about chat models, hey, look at this. Our good friend System User Assistant is in the hizzy. We've got system, human, and AI that LangChain decides to use instead. Now, they got the sort of second pass at this in the industry. OpenAI was kind of leading the way. So human is a little more intuitive than user. AI is a little more intuitive than assistant. Well done, LangChain. Same dealio, though. When we talk about prompts, I mean, we don't really need to talk about prompts that much, right? We kind of beat that to death already. We got to set up a template. We got to set up a prompt. And our first chain that we can imagine is just chaining the model to the prompt. And we'll see that. We'll see, it'll be called, a LLM chain. And then we can sort of hit it just like it's one thing, right? Instead of two different things. So that's sort of the first idea of this gluing together of the pieces. Now, when we split text, because text splitters are really important, we need to understand that we're always choosing chunks. Like everything is chunks. The only ingredient, so to speak, in the vector database is chunks. So how big should your chunks be? Oh, well, I mean, the black art of chunking is an interesting space for sure. And there are some unique things that people are doing. But there's some baseline chunk sizes. We'll pick like chunk size 200 characters or so. And then what we use is sort of the Swiss Army knife of chunking, which is this recursive character text splitting. It's the idea that like instead of like stopping right in the middle of a word, which would be dumb, we sort of stop at the end of words, we stop at the end of sentences, we stop at the end of paragraphs, we stop at the end of things that like it makes sense to stop at the end of. But we still sometimes cut things off right in the middle. Because, I mean, chunking is hard. And you can imagine chunking strategies that get very meta, and you have smaller chunks, and you have baby chunks and parent chunks, and you have meta chunks and regular chunks, and all of this stuff is very much within the realm of nothing that's new because RAG exists or LLMs exists. It's just dealing with data, and it's important to be able to do this with your unstructured text data. So you're going to know your data the best. What is the right chunk size? It depends. But you can use like 200 with recursive character text splitter, as we'll do. We'll pick some embedding model off the shelf. We already did. You guys saw that. And remember, we did this already, naive RAG. But in order to sort of take this to the next level, we need to load in some data. Let's say, we got loads of PDFs. Let's go ahead and load one in. PDFs is what we're seeing from enterprise most, even if like you don't necessarily want to deal with PDFs because you have to do parsing and all of that. And then the vector store is where we put all the stuff, and it's really easy to create a vector store. You load the docs, you split the text, you do the embeddings, and then you store the vectors. Yeah?
So like after you store the vectors, let's say in your agent, you're going to call for that document. Is there like a good practice to do so that you can retrieve like let's say like the source of the document?
Oh yeah, 100%. Yeah. You always want to be getting that sweet source of the document. Otherwise, you're not really fact checking after all, are you? So you always want to be able to like easily click and go right to the source. Yeah. So that's built into some of the basic UIs and something that you always want to be referencing directly, sort of as pile and reference material. Yeah.
So when you do the chunking, do you need to make sure to keep the context, or doesn't matter?
I mean, yeah. It's like, well, what does the context mean to you? It's like, there are words and sentences and paragraphs and chapters. And, it's like, what's your data, though? Is it a chapter book, or is it a textbook, or is it, something else? Or, is it paragraphs within structured data tables? Is it, what is the context? It's like, that's the data-centric question that you've got to answer for sure. Yeah, so we're going to use Quadrant. These guys are hyping it up and crushing it. And the numbers support that. We'll just show a couple things on numbers real quick. and we'll take more questions before Wiz comes up. This is from today, yeah, early this morning. You see these numbers, it's kind of hard to see. We see, Pinecone, no open source. Yeah, they really went all in, didn't they? Hey, but they have some good stuff. Maybe you check them out. But we see that kind of leading, we have Zilla's, who's been around forever and is a much larger company. But this is sort of a, for the specific use case, startup that's coming in hot here. Quadrant seems to be doing a really, really good job, and we would suggest as a best practice tool to just pick up off the shelf. Again, it's pretty good. You can pick up any of these tools. They're pretty good. And Quadrant also is the only one that got funding in 2024 as a startup. Everybody else got funding in like the March, April 2023 timeframe. So that is going to get us into retrieval. We've talked about this already. That's the interface wrapper. And so this gets us to this space where we can build out this thing, where we'll use a Quadrant database, and we're actually going to use the open source endpoints, not OpenAI here. That's right. So that's actually wrong. Those should be little hugging faces. But what we're going to do is we're going to look at a classic. A classic, is Elon v. OpenAI, and we're going to. You guys heard about the lawsuit? So we're just going to put the lawsuit into a RAG system, ask questions against it. We're going to see what it was really about. This is something that you could imagine fine-tuning, something that speaks better legalese for, and this is something we've done in the past. It's something that you could imagine has a lot of jargon in it, and something that you could imagine is hard for the average user to understand. So we'll just sort of ask it a question. This is how we'll know if it was good or not. You guys can be the judge. And we'll kind of use these two models that we set up. And let's keep in mind, though, before we jump into this, that LangChain is really all about chaining these pieces together. So here's the key concept that you need to take away. It's not chains. It's lower than that. Every component of a chain is what you need to understand. It's called a runnable. And the runnable is incredibly important because it's like there's like one block of code that does this whole thing. And it's just chain. You need to understand it. I'm going to show it to you on slides. I'm going to show you code on slides, and we're going to see if we can. Okay, because Wiz has done the good service of giving us great comments, and over time we've realized actually we need a visualization and we need a walkthrough of this. So you'll see this shortly. But we see retrieval augmented QA chain equals all of this stuff. Okay, let's not look at the comments. Let's just walk through this. First piece of the chain, highlighting it here. Question, item getter, question. Okay, now let's visualize this whole chain. This is actually just the top of the chain. What we're doing is we're seeing that there is a question here. Let's say, who are you for the purposes of this? And then item getter question. We're taking the question, who are you? It's still just who are you? And then we're putting it down here in question. It's just who are you? We're just taking the question and we're just bringing it down. That's it, okay? We're not doing anything crazy. We're just moving the question through. Because we gave it as input. It was created before the chain was created. It was created in the beginning, let's say. It wasn't created within the chain. So what we can do is we can say, okay, well, what are we chaining this thing to first? We're chaining it to this piece. Now this piece is where the magic happens. This piece, context, item getter, question, chain, quadrant retriever. Magical. This is a magical piece right here. Because this is like the whole shebang. What's happening? Well, look at the right-hand side now. We're saying this question, we're going to pump the question now, not just into carrying the question forward, we're going to pump it into the quadrant vector store. Okay. Dot retrieve. What do you think's happening? What do you think's happening there? We'll wrap around, and then we're getting retrieve context, boom, got it. Is that it? That's the whole RAG system right there, right? So we've got now this first important chain. If we zoom in on it, we can see that in the code, we'll see this quadrant vector store as retriever. What this actually is, if we zoom in really, really close here, we see split chunks, we see embedding model, we see location, we see collection name. This is an example we did obviously with Hitchhiker's Guide to the Galaxy. We're going to do something a little bit different today. And that's where all of this is housed, is right here on the right. We see the vector store, we see the retriever. We can zoom in even further here. We can see even more good stuff if we look at the chunks, at the embedding models, at the collection name. We can see how all of this starts to come together. It's all there. And so what else is there left to do then? Well, let's see. This is now runnable pass-through dot assign context equals item getter context. Okay, runnable pass-through. What in the hell is runnable pass-through? Well, let's sort of move this thing up a little bit first, and let's go down to the bottom. Now, what am I doing with runnable pass-through? Well, I'm taking this thing that was created within the chain, and I'm passing it through. So this question context was created within the chain. I'm passing it through. Remember, this is just the retrieved context. This is to your question of, do I get the source material back? Exactly, right? It's like, well, I want to get that source material back. Give it to me. But I actually didn't, as we talked about so many times today, do the generation yet, of course, right? So the generation hasn't actually happened. It's just retrieval. So what are we doing here? Oh, look at this. Our beautiful LLM chain, chaining the RAG prompt, the prompt template, to the OpenAI chat model, in this case, our Hugging Face chat model, and we get the response. And of course, this is the other side of this, as you can see. So the magic doesn't occur just in retrieval, also in generation. And we see the chat prompt template is set up. It goes into the OpenAI model right here. And then we get our answer. We get our answer and the associated context of the final output, which is the reference material itself. So we see the chat model. It's listed here for this example. We see the RAG prompt. We see it's exactly as we would expect it to be, and it's exactly as it is shown here as well. Boom. So we've got all the pieces. We can see it all in one runnable, and the runnables, put a pin in that, are going to be the only thing that we use in each piece of our graphs when we start building agentic applications. Okay, so let's see exactly how this LangChain RAG system is built using Elon versus OpenAI data. And for that, we go back over to the Wiz.
Oh, yeah. Okay, so we talked about how to manually provide context. And that was lame because it was manual. So now we're going to talk about how to automatically retrieve context, because that's less lame and automatic. So what I'm going to do is just head to our repo again, and we're going to get there. So that's the AI Makerspace repo, and we're going to go to... Oh, yeah, for sure. Yeah. Sorry, guys. We're going to go to LCL in LangChain, and we got the collab right here. Oh, nice. How's the zoom level there in the back? Zoom okay? Okay. So, so Greg explained it very well. It sounds like a lot, but it's not, right? So in practice, the way that we're going to think about a runnable is that it's something that we can run. If you're familiar with Python, it's a function, right? A runnable is a function. We're used to functions. They take inputs. They deliver outputs. Runnables have a agreed upon protocol, which means that they have very specific inputs and outputs that we care about, and that's how we can chain these things together in a way that's useful and productive. So let's start by grabbing a bunch of dependencies. We're going to need LangChain, LangChain Core, LangChain Community, LangChain OpenAI, and LangChain Hugging Face to get everything that we need done today. We're also going to use the Quadrant client. If you're in Colab and you see all these pip dependency resolved issues, don't worry about it. It's going to run fine. If you're running this locally, you shouldn't see that. And then we're going to get PyMu PDF. which is going to be our PDF parser. Since we're going to give it a PDF of that complaint that Elon, created against OpenAI, whatever the right legal term is. For our OpenAI API key, we're going to provide our Hugging Face token. So this is the classic, right? It looks like OpenAI, it smells like OpenAI, but underneath the hood, we've swapped it out to our Hugging Face inference endpoint. You'll notice that you have to provide your LLM URL here. Do be mindful that you don't include any trailing slashes, or else it won't work. You'll get a 404, as we discovered during the break. And then we're going to set that to our OpenAI base URL. So this is the thing that reroutes that request. Instead of going to OpenAI API, it's going to go to our Hugging Face inference endpoint. Easy. Okay. So how do we create a chat model object and a LangChain? Well, we just import from OpenAI LangChain, chat OpenAI, and then we create the model and we call it TGI. Why do we call it TGI? Let's head to Hugging Face real quick just to see like what's up with that. Why are we doing this, right? It feels arbitrary, but if we go to our endpoint, we go to test our endpoint through the API and we use API, this is just what is done. So we provide it because that's the expectation. Basically, the way you can think about this is that the TGI container is the thing that we're calling a model. The model inside of it, though, is still whatever we've set it to be. In this case, it's going to be that new research, Hermes 2 Pro, etc. Okay, so now we have an HF LLM, Hugging Face LLM, that's powered by the chat OpenAI object. Now we're going to create a prompt template. So before, we made these helper functions that did this. LangChain just gives us those out of the box. It's called chat prompt template. We're going to have a system template and a human template. You'll notice that the human template is not really anything, right? It's a formatable string. So we can call .format on this and replace content with whatever we want. It's going to be a little bit easier than that because LangChain has built useful tools for us. The idea is that our chat prompt becomes a chat prompt template from messages, where we pass in a system message, which is this template here, and then our human message, which is this template here. Notice the difference that Greg outlined for us, right? It's human instead of user, and then it's going to be AI instead of assistant. But they mean exactly the same things. And in fact, under the hood, it's converted back to user and assistant. But it does feel more natural to say human message and AI message rather than assistant and user. Okay, so our first chain. The big thing is that they've overloaded the pipe operator. So the pipe operator now acts as this thing that chains the left-hand side to the right-hand side. That's all it's doing. The chain operator is going to do some checks to make sure that the schema of the output is aligned with the schema of the input so that we don't have to worry about that, as in the chain will not successfully create if the schemas don't match, which means that you shouldn't run into issues where when you go to run the chain, it doesn't work. When we create the chain, we'll be alerted of any mismatched input-output schema. The idea is, right, if we have a square peg output, we need a square peg input for the next component, and so on, which makes it fun to use because it doesn't error, when you're running it, it errors when you're building it. So why do we care about LCL? LCL is very useful because it does a number of things for us. Now, for some of you out there who are building very customized solutions, you might have to fight with this a little bit. If you're building more standard solutions, this is going to be a very pleasant experience. Number one, it automatically handles asynchronous operations, batch and streaming operations. This is incredibly useful, right? We don't have to worry about building asynchronous. We don't have to worry about building in batching, and we don't have to worry about building in streaming. If the LLM we have supports these things and we say to use it, the chain is going to use it and leverage it where it can. Fallbacks. LCL gives us a number of places where we can usefully fall back, as well as we can add fallbacks to chain, as well as callbacks. You love it. And then parallelism. If we have components of an LCL chain which can be parallelized, they will be parallelized, What that means is that, say we have 2 LLM calls that happen at the same part of a chain, instead of doing them one and then the other, we're just going to do both at once, and then we can move on with our chain a little bit quicker. And that's all out of the box. So how do we make a chain? Well, we have our chat prompt that we created above from our chat prompt template, which just looks like this. And then we chain that into our LLM. And the idea here is that we start with our input, and then we chain it into the next component, and then we chain it into the next component, and so on and so forth. We're just going to build a very simple chain here. The way that we call the chain is with .invoke or a-invoke, if you want to be very specific about using the asynchronous implementation, though you don't have to. We're going to pass in content hello world, right? So the reason we pass in a dictionary with key content, right, is because we know we have to format our human prompt template with that content key, right? So that's essentially going to replace this content placeholder with the value that we pass in when we invoke. So instead of saying content, it's going to say hello world, classic. We get this, response, greetings, humble mortal. I see you get it, talks like a wizard. We've seen it before. We can ask with a different prompt, right? Could I please have some advice on how to become a better Python programmer? And then we get the same kind of response, but it talks like a wizard, where it talks about things you can do to be better at Python. You love to see it. But that's it for the simple chain, right? We have an input, we invoke the input, then it chains to the next component, then it chains to the next component, so on and so forth, until we get a response. So we can again manually add this context, right? We can say, please define LangChain. We can ask what LCL is. It has no idea what LCL is, right? The LLM's just making stuff up. You love to see it. And this is where the idea of RAG comes in again. We can ground the LLM with context. So we're going to provide that context with a big blob of text. You can see here, when we invoke the LLM now, or the chain, it's going to use that context to fill out that prompt template that we've provided above, which is this human template. Awesome. Then when we get responses, they're better. That's it. Okay. The next thing we're going to do is we're going to talk about splitting or chunking. So we know that there's this limitation that exists with LLMs, right? Which is that they have a limited context window. What that means is that there's only so much text we can shove into the LLM for it to be useful. At some point, we shove too much text in, and then it won't be able to use all of it. And we can do clever things like only count the last X token, all kinds of stuff. But at the end of the day, we can exceed the amount of information that the LLM can look at once. Chunking takes our large documents and turns them into small documents. You see, we're just kind of choosing a chunk size of 400. We could have spent the whole day talking about chunking, right? So we're not going to get too deep into it. But the idea is this is a very important piece of the RAG puzzle and is worth spending engineering hours on. Chunking is something that's important, and it relates to your data, what your data looks like, etc. So how do we actually use it, though? Pretty straightforward. We define the splitter, and then we call .splitText on some text, and then we get chunks. And we print the chunks out, and they look like this. Let's go. Okay. So now we have to introduce the next step of RAG. So we've converted our big document into small documents, but now when a user answers a question, how are we going to be sure that the desired context from our original large document is in the prompt, right? The LLM needs to use in-context learning to look at the context and then answer a question. But how are we going to make sure it's there? And that's where this idea of the vector retrieval comes from. So what we're going to do is for each of our chunks, we're going to generate an embedding vector. And that vector is going to be stored alongside the associated piece of text in our vector store. We're not going to get too deep into what these things are doing literally, but the idea is they hold the association between that embedding vector and that piece of text. Because when we send things to the LLM, it can't be an embedding vector, right? LLM's got no idea what our random embedding vector is, so it has to send the text back. But having that vector makes us able to do search very well with our computer, right? Computer, terrible at understanding text, real good at understanding number. So that's why we're doing this. We're going to use our custom embedding endpoint. We're going to set it up with a Hugging Face endpoint embeddings. Very self-descriptive, right? You know what this is doing. It's pointing at Hugging Face for our embeddings. We're going to pass in the URL. This is the task I was talking about. It doesn't matter the task you use for the container. This is the task that it's going to use when we hit it with this endpoint, which is feature extraction. And then we're going to pass in our HF token so that we have permission to access the endpoint. Okay, so how do we actually get embeddings for our chunks? Well, we just loop over all of our chunks, and then we generate an embedding for each of them, and then we store them somewhere, right? In this case, we're just going to store them in this dictionary, because why not? A vector store is a much more complex, much better engineered dictionary, right? Loosely. So what does this look like? Well, now we have chunks, and for each chunk, we have an embedding vector of size 768, right? One thing that's very critical that we get a lot of questions on, and I think it makes sense, the embedding model does matter between the thing you embedded all of your documents with and the thing you embed your query with. So when I ask a question, I have to use the same embedding model that I used to generate the embeddings that live in my vector store, right? And that makes sense because if they're not the same, then they're not going to mean the same things, and the proximity to certain vectors doesn't really matter, right? But what is not true is the embedding model that we use for the vector store and the query, it doesn't have to have anything to do with our LLM, right? So you'll notice that we're using the Snowflake Arctic embedding model, right? Which is the Snowflake Arctic embed M, but our LLM is Llama. Two totally different models, but that's totally fine as long as the whole retrieval pipeline uses the same embedding model. We're good. Because what we pass to the LLM is text, not embeddings, right? So just to head up any questions that might come up about that, the embedding model does matter in the R in RAG, but as soon as we get to the G, it's all text, so it's all good. What's up? Yeah, that's a great ops question, and you have to become good friends with your ops teams because they're going to have to re-embed your things a lot, especially if you're using like living documents or you have live streaming data. Your embedding pipeline is going to be something that runs a lot and often as documents come in, as documents leave. It is something that you're going to have to manage. The tools that we're going to talk about have simplified ways to do this, like we can update our vector stores, we can update specific references in our vector stores, but the actual orchestration of that pipeline is just going to require you to be good friends with your ops team. You will have to refresh these absolutely as your data evolves. If somehow you live in a world where you have totally frozen data, totally frozen models, you only need to do this once, right? And we talk about only needing to do this once, but realistically, you will have to re-embed data from time to time if you're in an organization that has data that moves at all. But great question. The simple solution is if you can use the API of your vector store to update or refresh, it will be able to do that dynamically, not re-embed exact match information. If you can't use that API because it's not flexible enough or doesn't get you exactly what you need, then make friends with ops. Okay, so how do we find the embeddings? Well, we use our good old friend cosine similarity, right? So cosine similarity looks at two vectors that are pointing in different directions, and it tells you if they're pointing kind of in the same direction or if they're pointing in kind of not the same direction. That's what we're going to use. The idea is that when we embed the text into this embedding space, vectors that are aligned should be semantically similar. Vectors that are not aligned should be not semantically similar. This is the number one assumption that we're making the whole time we use a system like this. This is not necessarily true all the time, and there are lots of strategies that you can combine with this to make a more robust retrieval pipeline. But the assumption that we make is that well-aligned vectors are close together in meaning, and ones that are not close together in meaning. That assumption powers a large volume of industry. And it's mostly true. So how do we actually find the closest chunk? Well, we just look at all the vectors, right? So we take our question and we embed it to a vector, and then we compare it against every single vector in our vector store, right? Now, this is going to quickly become completely impossible from a computational standpoint if we have, say, millions of vectors. So we have fancy stuff that we do to mitigate that. Someone in the back over there was talking about one of the core examples, which we will cluster vectors, and then we will only search in clusters, yada, yada. The idea is that we have ways to make what looks like a very, very dense, very, very computationally expensive operation much less all of those things. But for the simple example we have in just the Python today, we're just going to do the full search. Our vector database will automatically be doing this for us. So when we use Quadrant, it's going to be doing a lot of extra stuff from an optimization standpoint to make sure our searches are fast, even as we scale into the billions of vectors. This is why we recommend Quadrant. The Quadrant use case works for small examples, and it also works for very large examples. So it's a vector database that will grow with you, provided that you keep chucking compute at it. So there you go. Okay, so we create a retriever manually. All this does is it takes in our query, it embeds the query, and then it compares it to all the chunks. We get it, there you go. And that's the whole thing. So how do we do this in LangChain? Well, it'd be much easier than all that Python we were writing, right? So first thing we got to do, load some documents. What are we going to load? We're going to load the Elon Musk complaint PDF using PyMu PDF loader from LangChain. We're going to chunk it into 500 character long chunks. We're then going to check to make sure that none of our chunks exceed the size. That's crazy. It worked, right? That's what we expect. And then we're going to embed this. You'll notice that we have this for loop here. Where we do units of 32. This is because the Hugging Face inference endpoint only accepts batch size of 32. And so if we don't do this, it won't work. So we have to do it. If you're using a larger endpoint or your ops team has an endpoint that can handle larger batch sizes, you could do larger batches at a time. But that's what we're doing today. So there you go. You'll notice that we have this quadrant from documents location and collection name. Location simply means that we are storing this vector database in memory. That's all. You can have this hosted on a separate API, and so it could be stored there, and you just point to the address. But for the Colab experience, we're just storing it in memory. That's all that memory means. And the collection name implies what the collection is related to. You could imagine a world where you use that collection name as a means to filter the search space that you're trying to search when you're retrieving documents. We won't be getting into that today, but that is what you do with it. And then we make it a retriever. That's easy. Then we create a RAG prompt with a query, and we do the classic thing. We've left it as an exercise to the user, right? But this is the answer the question based on the context. If you don't have the context, say you don't know kind of thing. Try out what you want. And then we do this, and then we do this. So this is a lot, but it's not really doing a lot. The other thing is that, so if you haven't seen this notation in Python before, we have this, you might say, is this a tuple? No, it's just one line. This is a way that we can spread one line across multiple lines in Python. That's all it's doing. This could technically be a super gross one-liner, but to look at it would hurt our eyes. Greg's already explained this, but the idea is we get the question, we send it to the retriever, and then we get the question. That payload moves through the chain. We pass the context through because we want it to be at the end of our chain, and then we do something with the this payload, which is send it to the RAG prompt, which needs a context and a question, right? Because it answers a question based on context. It fills the prompt in, sends it to the LLM, and then we just grab that context we floated down for our output. The reason we do this is exactly what someone said earlier today, which is because we want the context. We want to know why it answered what it answered, and so we provide the context at the end of the output. You can also make this ASCII chart if you really want to look at an ASCII chart. There you go. What's up?
This might be a dumb question, but just to clarify for the item getter, that's essentially to extract a piece of the chain within the chain. Is that correct?
All item getter does is it gets an item from a dictionary. So what we're going to do is, because we have the input, when we invoke the chain, we're going to pass in this dictionary that has key question. All item getter does is it says, hey, I'm going to get the value of question. So you can look at the ASCII art, and we also made the visual that Greg showed. We've already walked through it, so we won't walk through it again. And then we can use it. And again, just like our simple chain, the way we invoke this is with a simple object that has our question and then the content of the question. And that's it, right? All of this setting up and all of this, creating a vector store and everything like that, it all just works in the background. And what we get at the end is we get the ability to query our RAG chain with a question, and then the LLM will answer the question based on the retrieved context. So we ask the question, what is the complaint about? The complaint is about plaintiff Elon Musk seeking specific performance of defending. It explains it. And then we look at the context to see, okay, so how did it land here? We see, oh, okay, so it's looking at this stuff. And then we can see the source metadata, so we can go to it. We can see where we got that information. That's a classic. And then we can ask a question very related to the document, like what is the airspeed velocity of an unladen swallow? And of course, it doesn't mention that, by chance. And so the LLM responds with the classic, I don't know. Which is the expected behavior. And so that is how we go from manually prompting to using LangChain to build a retrieval augmented generation pipeline with LCL. With that, we'll head back to Dr. Gray.
Yeah, and so there's one more thing that we want to show you guys, because after you deploy this, then you're going to be like, okay, well, how do I make sure that everything is gooch with my chain? People using it. I want to see everybody, like what their input output is, what errors that are associated with it, how to get this thing moving in a production environment. And this is where LangSmith comes into play. I want to give you guys a little heads up on how to start playing with LangSmith at the same time. So for those of you that want to kind of do this in production, this is sort of the piece where you might call it, this is the OG LLM ops from the original WandB website. This sort of logging LLM ops, it's still very, very well indexed on Google. And this is what LangSmith is going to help with. It can also help with some of this validation stuff, some of this evaluation stuff, as we'll discuss and give a little intro to as well. But we're not going to spend too much time on LangSmith. We do want to make sure we show it to you. It's important, and it's one of the tools that are really leading the industry right now in terms of how to do this. So this is what they tell you. Get your app from prototype to production. Sounds dope. Okay, what does that mean exactly? Well, it's like this piece that we didn't look at yet. And what it means is evolving rapidly in real time, as is the entire industry. So a few months back, they were like, yo, LangSmith is a unified DevOps platform. They straight used the dirty word here, and they called it that. And they were, they were messing with their marketing materials and so on and so on. Basically, we want you to come here for everything. LangSmith, LangSmith, get after it with us. Now, they've taken it to the next level. Since every time we run a class, a workshop, they change it, right? LangSmith is an all-in-one developer platform for every step of the LLM-powered application lifecycle, whether you're building with LangChain or not. Give me that Llama index, give me that Crew AI, give me that AutoGen. We want it all. We're LangSmith, right? And so this is important because, there's a race to the meta tool out there happening in real time. Everybody's racing after it, right? Whether it's, I'm going to do ops specific to agents. I'm going to do, everybody wants to compete with LangSmith. Everybody's trying to. We don't think anybody's doing a really fantastic job yet. But they are trying to solve the biggest problem. They're trying to be like, yo, come here and do it all. In fact, this is straight from their website. I mean, it sounds great, right? But what's the real deal? What's really going on? We're going to take a look here in just a second. One of the things that you can do with LangSmith, and you guys know now that you're prompt engineering experts, is you can evaluate very simply, and that's exactly what LangSmith does. In fact, LangSmith was trying to be really, really good at prompt evaluation, and there was a lot of people playing in this space, Llama Index and others. We're going to look at a tool next up called RAG Assessment. These guys, I mentioned them earlier, Y Combinator. They're going to sort of focus in on one part of the value chain and try to do it super well, whereas, LangChain's going wide. The people that go super deep, a lot of times if they go deep enough, they're left to their own devices, and LangSmith was like, okay, actually, you guys, we're going to, so it was interesting, because we would speak to, LangSmith, we would speak to Llama Index, and, they saw themselves as competitors one day, and then actually, we'll go ahead and work with them the next. So they do have their own evaluators, and they can build those in, but you don't necessarily have to use them. Quick question?
Yeah, so what's your take on Haystack?
Haystack. If you want to use it, go ahead and use it. I mean, my quick take is LangChain first, Llama Index probably second, and then maybe you put Haystack somewhere third. We got somebody in our community that's really, really into Haystack, and I would encourage you to talk to her if you want to know more about that. We call her Laura the Legend. Haystack came out of a company that's a lot older, that had a lot of legacy customers, that wasn't purpose-built for the LLM age. And so they did adapt and sort of keep up with the times quite well, but they are fundamentally burdened by their version control of their enterprise customers. So I think if you're looking for an LLM-specific thing and you're not already in that ecosystem, you might not pick that tool off the shelf first.
That's how they are selling enterprise.
Well, I mean, if they have, if that's what you got experience in, it's like that's what you got to sell. They're all selling enterprise, to be clear, but they definitely have been in the game longer. So what we want to talk about is we want to talk about metrics-driven development. This is classic, right? You don't change all the parts on your car. You don't change all the things in your workout routine. You stretch one muscle and you see if it moved and it's giving you a little bit more range of motion. Same thing in here. We don't change all the parts on the RAG machine. Don't change all the parts on the car to see if it's working better. And so we want a baseline number. We don't care what the number is, right? The absolute value is not the point. The having a value is the point, right? Rather than just saying it's good, it's not good, right? Which you can do that as well. And you can actually prompt your way into this. And then you change something, and then you see how the value changed. So here's an example of a prompt that's used within LangChain. We'll see some key aspects that we've seen before, within LangSmith, I should say. You are a teacher grading a quiz, role, persona. You are given a question. The context of the question is about the student's answer. Input. Specific instructions. You are asked to score the student's answer as either correct or incorrect. Output. Write out in a step-by-step manner. Chain of thought. Your reasoning that the conclusion is correct, avoid simply blah, blah, blah. Exact input format. That'd be great. And exact specific output, description, grade the student's answer, blah, blah, blah. Okay. This is one prompt. This is built directly into LangSmith. You could write this yourself, knowing what you know about prompt engineering. LangSmith isn't in the business of perfectly optimizing these prompts, but they have some. They have other ones too. Maybe you should use them. Maybe not. I'll leave that to you. There's 3 different types. QA evaluators, criteria evaluators with labels, criteria evaluators with no labels. QA evaluators, yes or no? Correct, incorrect. We just saw one of them. COT, chain of thought contextual accuracy. Maybe you should use it. Maybe not. Maybe you just use correctness. Is it correct? You can literally just ask the LLM that, if you're cool with that. We can take it to the next level, though. What if we don't want, is it correct? What if we want it to be accuracy? How correct? Give me a scale of 1 to 10. LLM's like, sure, 10, right? Damn LLMs. And no labels here, just straight prompt. We could put labels. We could say, yo, what do you think of the accuracy on this? What do you think of the creativity on this? What do you think of the conciseness on this? You could just, like, look at those prompts. They're great, aren't they? Creativity. Is this submission creative? Beautiful. I mean, this is all it takes to do evaluation. You can also add labels, right? More data, more context, right? Look at the accuracy by judging the prediction compared to the reference. Here's the prediction, here's the reference. Labels, great. Okay, easy. Now we can do similar things. This is a fun one. If we just use the default, if you just say criteria equals criteria, it'll give you helpfulness. And we return to helpful instruction following LMs. Yeah?
You can go back to the previous slides. So here you kind of told it to kind of look at the reference. But what is that almost like a kind of like supervised learning? Like I need to kind of label a lot of answers first and just show it? I'm just trying to understand.
Well, yeah, I mean, how did you get the answer, right?
Yeah.
I mean, is it a golden data set? Did a human come up with it? Did you have an LLM come up with it, right? How good was it, as a reference material? I mean, because this is the thing about fact checking, right? Is like, oh, fact checked him, Nope, didn't say that. Oh, said that. It's like, well, what about that fact checking material? Is that really legit that you just pulled up or not? So there's all these interesting questions that come up here in terms of data quality. And these are all just, again, words that we use, reference and answer and this kind of thing.
Just to clarify, this typically happens after you send a prompt, you get a response. You take that response, you insert it into this, then you evaluate it, return kind of the object that has the story.
That's correct.
Okay.
Yeah. Yeah, and we can get really, fun with this. We did like a dope or nope one the other day. It was really fun on YouTube. Like, it's like you can just make stuff up, right? How lit is this response, right? And it's like, maybe that's fun. Maybe not necessarily production worthy though, although it can be, and that's when we take a look at LangSmith. So let's take a look into LangSmith and let's see how these sort of manifest themselves, how we can sort of watch everything as if the LLM's getting hit a bunch of times, what we see, and then we'll go to our next breakout table session where you guys can spend time on RAG. You can spend time also with LangSmith if you like. I'm happy to answer questions on it. This is a separate notebook that we're going to do something a little bit. Yeah, question?
Can we have multiple RAGs in the same chain?
Say that one more time.
Multiple RAGs in one chain?
Oh yeah. Yeah. You can. So this is the thing. Your chain can be whatever you want, right? It can be like 6 RAG, 1. It can be a bunch of agents. It can be a bunch of tool calls. The sky is the limit here. If what you want to do is say like do multi-step retrieval where maybe you have like a first instance of retrieval to get an answer to a question that is going to guide you to the right next step, right? You can do that. Absolutely, yes. Yeah.
So how does it choose which RAG to take the answer?
So that's a good question that we are going to literally answer today at the end in our last notebook. Which is going to be done through an agent. An agent will make that determination for us, and we'll look at exactly how to implement that with the RAG tools that we're building right now. Yeah. So yes, we will show that exactly. But for right now, what we're going to do is talk about LangSmith. So again, we're in the repo. We go to 04.visibility with LangSmith. We click on it. You can go to the collab. You can go to the local notebooks. Totally up to you. Whatever makes you happiest. Okay. So. First of all, what is LangSmith? It's useful to look at the UI. Okay, so this is LangSmith. You'll see that today we did a lot of testing. We did a lot of running of the notebooks to make sure they ran and everything like that. So this is LangSmith. What is LangSmith at the end of the day? LangSmith is a big pool filled with every single interaction any traced application has with an LLM, right? So a couple words that we're saying there. Traced, what does that mean? Basically, that is one of these. When I click into a project and I look at a specific row, I'm going to see a bunch of information. And this is our trace, right? So if you're coming from a background where you already know what a trace is, that's great. If you're not, it's just like a record of what has happened, right? It's a collection of things that happened in the order they happened in. It collects information about how long each step took, how many tokens each step took. It talks about things like what services did we go to. It talks about things like what were the intermediate outputs of these things. So that's our trace. And this is what we're collecting with LangSmith. Every time we make an LLM call, we're calling out to an API, and therefore we're going to send it a number of tokens, and we're going to receive a number of tokens back. That's going to have a charge associated with it. It will have taken an amount of time. All of this information we were going to collect in LangSmith. So let's look at the example of a trace. We have input human, what is LLM-based agents and when did it break onto the scene? And then the output, LLM-based agents or large language model-based agents are artificial intelligence systems that leverage large language models to perform a variety of and so on, right? So we can tell a few things from this right off the hop. We can tell when it started, when it ended. We can tell time to first token. You might say, why is that NA? Time to first token is only calculated when we stream a response, right? Because the time to first token and the total latency when we get the whole payload at once is the same number. But when we stream a response, right, there's going to be an amount of time until we get that first streamed token back, and then it will keep running, and then we'll have a final latency of how long did the total request take to complete. But because we're not using streaming, we have an NA. It succeeded. We love to see that. Use a total of 1.3K tokens, which cost us a total of 0.02 cents. And then the latency was 12.43 seconds, and it was of type chain. So what took all that time? Well, if we look at the actual output, we can see that what took the most time is this chat OpenAI step. Now, this chat OpenAI step is pretty familiar to us. It is basically what we used. And you'll notice that we have a number of functions. We're going to get all into this at the end of the day, but the idea is we can see everything we would ever need to see about this trace, about this individual interaction. We can see where all the latency left. We can see our pass-through. We talked about that earlier. We can see the final response. We can see if this was helpful or not because we have a helpfulness check. All of this available through LangSmith. And let's look at how we set it up. Okay, so number one, set some dependencies, environment variables. Again, Hugging Face API key for our OpenAI key, our LLM URL. We're going to set that to our OpenAI base to override the OpenAI base URL. And we're going to set up exactly the same chain we did before, except this time we're going to add a tag. So one of the benefits of using something like LangSmith is that we can tag individual assets. So we know that any call that goes through this LLM will be tagged with base LLM. You can imagine this is useful if you have a number of different LLMs that you might use and you want to capture statistics about which LLMs are being called the most, what's their average token or average latency, etc. Then we're going to use the async nest just so the rest of the notebook works. We use sitemap loader. This is a classic. We're just going to get the LangChain blogs. So we're just going to collect all of their blogs. And then we're going to go ahead and split them. We're going to wind up with a total of 3.5 thousand chunks that are 750 characters long, which is a lot of chunks, right? So we're going to really put this to the test. Not really, but we're going to medium put it to the test, right? So we're going to create our Hugging Face embedding endpoint again. This is all what we've just seen, right? It's applied to a slightly different piece of data. We use a slightly different loader with a slightly different chunk size, but the pattern is the same, right? We get document, we split document, we set up our embedding model, and then you know what's coming next. We're going to embed all that information into our quadrant vector store. Then we're going to set this additional quargs for our retriever, K to 5. Anytime we retrieve context from a retriever, we're going to get a number of documents, right? So it's not like dynamic or like just some number. It's going to be a specific set number. In this case, we're going to choose 5 documents to return. So every time we query our retriever, it will return the 5 closest documents to our query. Then we create our chat template. And then we're going to create our LCEL chain. This is exactly the same chain with exactly the same comments, right? Because again, even though we're changing some of the guts, the pattern is exactly the same as it was the last time we did this. We can test it out. Question: what is a good way to evaluate agents? Based on the provided content, it doesn't directly provide a great way to evaluate agents. However, one of the document mentions evaluating models and selecting their best performing evaluator for each model, and on, right? So we can kind of see what kind of context we're getting and how we're answering the question. What's up?
Like, there's a small difference. The way you load the model in this one and the previous one is different. You use LangChain.chat models, and then the previous one you use just LangChain OpenAI. Just curious, what's the difference for them? Like, you use LangChain
Oh, yeah. There's no real difference there. So you can just use OpenAI. They have a top-level reference, so you don't need to do .chat models. It points to exactly the same class in the code, though. Yeah, this is just a unnecessarily verbose way to do that. Yep. A good call it. Yes. Okay. So how do we set up LangSmith? How does it work? I'm not lying. You do this. So you set LangChain tracing v2 to true. And then LangChain project to a project with a unique ID. It doesn't have to have the unique ID, but it can, right? This is just a way that you can see it's a separate project. And then you give your LangChain or LangSmith API key, right? And then you use your chain. That's it. That's the entirety of LangSmith integration. When you execute those two cells, the one that sets it equal to true, names the project, and then you provide your API key, the rest of it is handled. That's all we have to do to get LangSmith integrated with our LangChain applications. It's a very powerful thing to do because it costs you very little code time, right? This is not a big engineering lift, and it doesn't introduce a large amount of latency. And more importantly, it provides invaluable insights. Now, of course, if you're using LangSmith in a production environment, you will have to pay for it. There's a free version that you can use, but it's not suitable when you start scaling up in users. Up to you and your company to decide if you're wanting to pay for that. But the basic idea is this will now trace anything that we send, right? So every call that we make, every interaction we have with this LangChain application in this environment is going to be traced for us, and we can see the trace. There you go. Okay, so how do we, this is great, right? So how can we maybe extend this to a little bit of some evaluation? We're gonna do a simple LLM style, LLM is a judge style evaluation here, where we build the LLM evaluation chain, and then we evoke it. We can see things like, why is LangSmith a good tool for evaluation? Pass in the response, and we get a Y for yes, or an N for no. The basic idea here is, again, this is how easy evaluation can be. Now, we're going to look at some examples later on that take this to the next level in terms of the amount of data we can evaluate and the fancy ways we can evaluate, like Greg was showing us. But for right now, this is what's happening at the heart of a lot of these evaluation frameworks, right? We're just asking the LLM, hey LLM, how does this look to you, right? Does this meet certain criteria or not? You might say things like, well, does that work compared to humans? How does it stack up to humans? At the scale that you can run this at and the cost you can run this at, which you might think is a lot, and it is for LLM calls, but compared to expert humans, cost very low, and you can run it at such a scale that the information you get or the signal you get from it is quite valuable, even if, like Greg showed in the slides, the absolute number is not necessarily what we care the most about. The actual relative change in the number is something that's very useful when you can ask it, say, 10,000 questions versus a human annotator's, 100. But that's it for LangSmith. Yep, go ahead. Sorry.
I was wondering about security.
Yep.
You're sending all the data to LangSmith.
Yep.
And so they will have your data after
yes.
that point. Okay, so if you were passing some information, you probably shouldn't.
Yeah, you can. So you can work with their enterprise team. They offer SOC 2 or whatever it is, compliance and everything. But yes, one thing to be very clear about, even though it's a NIT, is you don't send your data, but you do send pieces of your data that are sent to the prompt. So they don't have access to like your full data set, and you can obscure, so you can not trace things, right? You can add the options like, hey, don't send this over to LangSmith. But that idea is absolutely true. They will be able to infer any information from your data set that you pass through. And when I say they, I mean the service that exists on their infrastructure will be able to do that. Though I believe they also offer working with teams to build on-prem LangSmith so you can keep it in your house. That is still a valid, absolutely valid concern. Yeah. What's up?
So you're saying that they have offline version that you can...
You have to work with their team, but yeah. Yeah.
Okay, and how about latency? They add probably additional latency.
Very little additional latency because they just keep the trace in the background and they fire it off async. So it doesn't interact too much with the actual chain. Yeah, it's just like they pool and collect, and it's similar to things like WAN2B if you used it for like model training. The additional latency is negligible. Someone else had a question? Or are we good?
I was going to ask, so LangSmith obviously is the one that you're discussing, but are there any, I guess, open source standards that you can run on a local machine? Like I'm thinking like Airflow is an example where it just spins up like a web interface for you to track these things. Is that something that's coming down the pipe from an industry standpoint, or is kind of the only option that exists for us?
There are solutions that exist that are open source. I think literally including Airflow has a version of kind of tracing for LLMs. And MLflow I know for sure does. You have Phoenix Arise and stuff like that. You have open source solutions. However, as is the case often with these kind of early stage startups with a ton of cash, LangSmith is pumping features out. And because of that, they're a little bit ahead in terms of the feature set. But given enough time, I'm sure the open source solutions will catch up. Yep. Yep. And we'll get you back with Dr. Greg.
Okay, so we're going to spend some time together now. Not me with you, but you guys with each other. And we're going to start building, shipping, and sharing our RAG system, which is the sort of keystone of the day. So please head over to AI Makerspace GitHub and check out the RAG notebook. Now, this is obviously the one we did, the Elon Musk thing. So let me sort of show you that if you go to the main repo here, you can find this directly, LangChain and LCEL. And this is going to be a great one for you guys to, if you're working on a project for school, if you're working on a project for work, if you have a PDF that's work related, see if you can get this thing running with your work related PDF and your open source endpoints. Man, you're going to have something awesome to build, ship, share, and show to everybody in your network by the end of the day today. So we're going to spend 30 minutes. You can also grab the LangSmith notebook if you'd like and just grab those 2 lines from it. See if you can get the LangSmith working if you set up an account with them and that kind of thing. We'd recommend checking it out if it's of interest to you. If not, no worries. Focus on LangChain RAG. And then when we come back, what we're going to do is we're going to spend time talking about the RAG assessment framework, and we're going to talk about really detailed ways of generating a bunch of synthetic test data and then testing, okay, is this thing not hallucinating? Is it using the context? Is the context ordered right? How can we get a lot more specific in the way we're doing the assessments? Then finally, we won't do a breakout for the assessments. We'll go right into LangGraph to do our agent build, and that's going to be our final build of the day. So set yourself up for success. Know that your LangChain RAG system will be a single runnable in a single node in your LangGraph application. So if you can start to draw the flow chart for it, then you can start to figure out exactly what you should be putting in this. Or just put multiple RAGs together, like I think someone said earlier. All right, 30 minutes. And then we'll come back, we'll do RAG assessment together. Should be a blast. All right, let's build, baby. Yeah.
Let's go.
So what we'll do now is we're going to get into RAG evaluation, and we're going to talk a little bit about how we can take eval to the next level, okay? And I just, quick shout out. I know we're going pretty hard today, and so if you guys are starting to get a little fatigued, we totally get it, okay? I think you guys are really going to like this, and if you're looking for a little break of your sort of mind from the code, conceptually, this is actually quite a lot to dig into. And so I encourage you to sort of peek up if you're sort of interested in kind of a technical, intellectual challenge to sort of wrap your mind around this. And then upcoming, right after we see the demo of this, we'll have LangGraph, and we'll finish it out with a build session that will culminate in the demo day sharing. And I believe that our main man Lusk has a whiskey tasting later that he's trying to put on, so we'd love to invite everybody to that, and we'll see what you guys are doing the rest of the evening. Okay, so eval, we're going to talk RAG assessment. We're going to give you an overview. RAGis, what is it? Well, we saw that we could build RAG systems using LCEL. That was pretty cool. Very cool indeed. Let's strip this back down, our good friend RAG. And let's imagine that now we need some sort of feedback loop on our system to know if it's good or not, right? We need to instrument our system with something that tells us, is it good though? Really? And we can use RAGis for this, but this is kind of a terrible visualization. Rather, let's consider the different component pieces that we've learned. And these pieces, each of them along the way, could be swapped out, much like the pieces on a car, right? So instead of thinking about just feeding the output back to the input, how about we think about what will happen if we change the document loader from PyMu-PDF to something else, or the text splitter from recursive character to, I don't know, fixed width, right? Like it's 2020 or something. Or what if we want to change quadrant to our personal favorite vector store, Chroma or something else? We could totally do that, and we could see, well, what effect does this have? Does it have any effect whatsoever? Of course, we could do lots of different advanced retrieval processes here. We could change the prompt, see how that changes things. But there's more, right? We could also change the models themselves. We could even fine-tune them. And in fact, I was having a great discussion. It reminded me, one of the best things that you can do, so thank you to the back there for the reminder, one of the best things that you can do is actually to fine-tune your embedding model straight away once you get this thing going, because you'll notice that many of the metrics that we measure from RAG assessment or from many prompts we could use are going to get better and better and change as we fine-tune embedding model on the data that's in our vector store. We literally fine-tune the embedding model to know the language we want it to speak. Smart, right? It's just like when you train a new employee, right? Hey, this is how we do things around here. This is how we speak. Get used to it. So these are the pieces that we can leverage with any RAG system. RAGis, we're not doing anything different. We're doing metrics-driven development. And we're assuming that if we improve search and retrieval, we can improve generation, because it allows us to have better stuff in the context window. MDD, you'll hear this on the RAG assessment framework. Docs, it just means, you guys got it. Okay, yeah. So what are the data requirements? Here's where it gets interesting. Here's where it gets intellectually stimulating. Now I'm not going to have question-answer pairs. I'm not going to have question-context-answer triples. I'm going to have question-answer-context-ground-truth quadruples. What am I going to do with these? Well, this is the magic of RAGis. Now, you might first ask, well, what is the difference between answer and ground truth? That's a pretty good question. But leaving that aside for the moment, what we can do if we have these quadruples is we can look at things like precision and recall. Hey, those sound familiar, right? But we're looking at the context here. We're able to say, did we do good with the context? You can imagine like an F1 score for context here, almost, right? For those of you with a classic machine learning background. We could also look at, is the answer relevant to the question? Pretty important. And everybody's favorite, faithfulness. Is the answer supported by the context? In other words, are we solving the fact-checking problem? Are we hallucinating? Faithfulness 100% equals hallucinations 0%. So we can take each of these, and they even have some sort of end-to-end metrics as well that we won't get into, and we can calculate all this great stuff. We're going to talk about the details of the calculation in just a second. And I think one of the things, I'm going to just hold on questions for just a moment till we finish a little bit more of the discussion. we have to actually generate these. And generating these is some magic, actually. We're going to use this synthetic test data generation piece that's now built into Ragus. It's always been built in, but now it's sort of explicitly built in. And what's really cool is that, obviously, we can do it fast. It's synthetic, and that's obviously a big thing about synthetic data. But we can actually create some pretty great data. And this comes from ideas of evolutionary algorithms, right? If you guys have sort of a classic ML background, you can think about these more, sophisticated, evolving things. And this actually comes from this idea of using kind of a question-answer evolver. And this is the evolver that we're going to leverage in RAG assessment. It is allowing us to say, you know what, that question's good, but I would like it better if it needed reasoning to answer it. Can you mod it to do that? I would like it better if it introduced a conditional element to it. So I would need to think through step by step harder on it. I'd like it better if it actually required me to return multiple pieces of context. I would really think it would be a much better question. So what we can do is we can actually take our initial NLP documents, right? We can get our chunks, make sure every chunk is a legit, valid chunk, and then we can take our seed question and we can evolve it. Now, the evolution is basically, sometimes this fails. Sometimes we say, hey, add a conditional element, and it's like, bro, I don't know. I got nothing. And so that would be something that's like, nope, get that out of there. So we do some validation before we get our final samples. Now, there's another interesting one here, which is conversational, which, sort of makes it so that it's more of a style of a question that requires kind of the back-to-back. The back and forth, I should say, conversation that you're going to get when you deal with these chatbots and LLMs. Now, they built this based on work done in this paper. This paper from April 2023, the Wizard LM paper. And the thing that's cool about Wizard LM is it's called Wizard LM. That's pretty cool. But it did so well on instruction-tuned data and on performance with that instruction-tuned data because they use the eval-instruct framework. And the eval-instruct framework took questions that were instructions and evolved them into different directions, and then it trained Wizard LM on these evolved instructions. And so the next level of evolution came with eval-instruct. And it's exactly eval-instruct that's being used in the case of RAG assessment. So, my slides are getting tired today, it seems. I understand slides, my good friends. And I think they're getting quite tired today. So, what we're going to do is I'm just going to straight share the paper with you because I've broken Canva pretty hard in the past, but I'm breaking it off really hard today. And so we're just going to sort of freewheel it here instead. And so let's go directly to the source material. Sorry for the lack of beauty on this and the lack of what to focus on. We're going to try to take this all in at once instead. Let's see if we can do this. Okay, so the idea here is that there's one question at the bottom, an epic favorite. 1 + 1 =, right? Okay, fantastic. Look at that, initial instruction. Now, what's so cool is look at the red line from 1 + 1 =. The red line evolves it to, what is the speed of light in a vacuum? Oh my God, that is legendary. What? That's pretty cool, right? And then check out the other red line. It goes from how many times faster is light than sound in a vacuum up at the top. And it goes to, oh my, photosynthesis. It's like, what is going on here? That's some evolution, like fast, right? And what they did is they basically wrote this prompt. They said, take this question and make it like similar vibe, but like way more rare. That's what they said. And then they add some other stuff in the prompt as well. And so that's pretty cool that works. And you can just prompt that straight away. You can also take 1 + 1 and you can get all like constrainty about it. How to prove 1 + 1 = 2 in the Goldbach conjecture. Okay, I'm not sure if that's the direction we want to go in our RAG assessment, but in what situation, the deepening, what is the value of this, increased reasoning, concretizing, right? Back to grade school math. It's like I have one and I have one of these. How many do I have? Both of them together. And you can see like the complications and the deepening, the reasoning increasing, and so on is all here. And what's interesting about this paper is this paper was like, they were like, we're not trying to keep this a secret, like what we're doing. Like here are the prompts, right? It's pretty straightforward. In depth, right? That wasn't 1 + 1 to speed of light. That was just the sort of regular ones. And I got no highlights here. I got no laser pointer either, but you can sort of read this, right? The rewritten prompt must be reasonable and must be understood and responded by humans, and so on and so on. Try your best not to make rewritten prompt too verbose. You should complicate the prompt. That was the complicate. You should deepen the reasoning. You should, and so on with each of the in-depth reasonings. And then the in-breadth reasoning, check this out, even more rare. You see in the second, third line here, even more rare. The length and difficulty should be similar, but you want it to be super rare. That's how we go from 1 + 1 = 2, to speed of light in a vacuum, to photosynthesis. Okay, so that's what they took inspiration from in the RAGAS framework, and that's pretty cool. They were like, okay, well, we got the eval instruct stuff, dope. We want to do our own version of eval instruct. We're going to call it evolution. And what we want to do is we want to do it with this data. And so what we want to do is we want to generate some questions. So we use a generator to generate the questions. Now, the one thing that I mentioned about the eval instruct thing is sometimes, you generate like an in-breadth or in-depth, and it's like, that was a failure. I don't really have a good one that came out of that kind of thing. So we have to like, be mindful. One thing of being mindful of here is we're going to use the LLM a lot. We're going to hit a lot of LLM calls to do this. Because we're going to say, hey, here's a question, and then we're going to say, hey, change this question based on this. And then we're going to say, hey, what do you think about that question? Is that changed like that? And then we're going to say, hey, if not, do it again. And we're going to do that like hundreds or maybe even more times. Thousands of times. And so the seed question, you can look inside the prompts on all of this stuff. Instruction. Generate a question that can be fully answered from given context. The question should be formed using topic. Example, oh, look, photosynthesis. This is from the RAGAS source code. I wonder where they got the photosynthesis idea from, right? And you can look in the RAGAS source code to see this stuff. And then we see it's got that sort of evaluator with labels thing going on. Very, very cool. It's got the one-shot, two-shot, few shot going on. Very, very cool. And we sort of generate a bunch of things. Then we have a critic come in, and the critic, again, because we can use the same LLM to critique the LLM's output, we use the critic to critique. And we say, yo, was that good or not? Like, what do we mean, actually? Well, assess the given question for clarity and answerability given enough domain knowledge. Consider the following criteria. 1, independence. 2, clear intent. Provide feedback and verdict in JSON format, et cetera, et cetera. So RAGAS built this out, right? They built this out using the ideas from the eval instruct. And then, basically, here's where it gets kind of interesting is we sort of generate a bunch of questions. We make sure that they're pretty good. And then we use our RAG system to find context and generate answers. because we want our RAG system to be assessed here, right? The questions are all we really needed. The right context, the exact right context for any given question is passed then to the LLM to generate the ground truth, the exact right context. So we're starting to mince words here. So we've got ground truth and we've got exact right context. We're generating context from our RAG system, and we're passing that context directly to the LLM as the right context. Is that what's going on, Wiz?
Yeah, so the way that we get to exact right context is that we actually use the context to generate the initial question. So instead of doing this kind of backwards where we generate a question and then we look for the exact right context, we start with context and then we ask a question that could be answered by that particular piece of context. So we start with having the correct context. And then we pass that to the LLM with the new question that's been evolved from the seed question from that context. And that is what we use as our ground truth.
Okay, so let me get this straight. We ask a question to our RAG system. We get the retrieved context. Then we take the question we asked and we evolve it. And then we attach the context that we got from the original question to the evolved question.
How do we do that? I'm not sure I understand.
So
I understand the concept, just
So remember when we create chunks, right? Well, when we create chunks, what do we wind up with? We wind up with a list of documents. Now, each of those documents is a piece of context, right? So we pass that piece of context to generate a seed question based on that context. So now what we have a piece of context and we have a seed question. Then we evolve the seed question into a whatever type of question we desire based on how we set up our SDG pipeline with Ragus. And now we have an evolved question plus the original context. Then we pass in the evolved question plus that context, which we know is the right context because we just took it, right? It is the context that created the question. So it must be the right context, is the thought. And then we ask the LLM to answer the question based on that context. And that's how we wind up with our question, context, ground truth triplet. So, yep.
So in initial context, you are restricted to those chunks you already have.
Yeah, we're in fact restricted to one or n for multi-context chunks. So what we do for each chunk is we create a seed question. If we use multi-context, though, we'll include like 2 or 3 chunks. Yeah.
And this is kind of interesting to note that Ragus can uniquely do this multi-context thing, and we didn't see this in the evolve instruct wizard LM paper because they're starting with the context as ground truth here, right? So they can evolve things to require context, which this is sort of going to form the basis for how they then measure success that we're going to talk about.
So when it evolves the question, it's using the context as an input to how it evolves the question? Is it clear?
Yeah, so exactly. So the thing that starts this chain reaction is the context. Then we develop a seed question from that context. And basically you can think of the prompt as what is a question that could be answered by this piece of context? Then we evolve that question through this process that you see here, where we do keep making sure that it fits the context. Like there's checks that are happening to make sure we're not straying away. And then we wind up with a question and a piece of context. And then we ask the LLM to answer the question we just created with the context that we just that we started with. And then that is assumed to be the ground truth. Of course, it's the LLM generated response. So a ground truth there is a, is a loose-ish interpretation.
It's a Ragus word.
Yeah.
It's the truth, though. Yeah.
Yeah.
Can you give us an example, like a simple question? What would be the evolved questions, and then what would be what would be the grand?
I know. It's like, this is exactly what we want. You know, we're 6 or 7 hours deep. We wanted this exact thing today. You know, we do want it, and we know we need it because, you know, the last time we presented this, we need that as well. But I believe we can get nearly there when he does the demo.
Yeah, we will look at examples of the question, context, ground truth. We'll have some examples of that. Absolutely, yeah. We'll see.
Okay, so just go. Yeah, go ahead.
I'm sorry, I just wanted to see how, have you actually tried this at scale? Because like I've attended a RAG session and there was a lot of comments on how scalable it is in production. And I just wanted to know if you have any knowledge on that.
This is infinitely not scalable.
Yeah.
Every single one of these examples can be comprised of 100 LLM calls. So this is not something that you're going to want to do frequently. This is meant to create a quote-unquote golden data set that you can use to evaluate your application going forward. This is not something that you're going to run as part of a loop. This is something you're going to create an asset with, and then you're going to reuse that asset multiple times because it is very expensive.
Yeah.
The example that we're going to do today costs $3 in OpenAI credits, right? So that's an example of
Big money.
Yeah.
I mean,
This is not meant for 100,000 row data sets. This is meant for very focused, very targeted.
but $3 is way less than replacing this entire evolver loop with a human, right? And that's the thing. That's your other option here. Is like, you got to actually ask the expert on this thing that you built. Is this the right answer? Is this good? How would you assess this exactly? And if you want to go around to everybody at your work that does this thing that you're automating and see if you can get buy-in from them and actually get them to create a golden data set with you, well, you're going to spend the next few years of your life doing this, and you probably will have a data set that may or may not work at all for it. So that's going to be a hell of a lot more expensive than $3, hence Ragus exists. And they got funded by YC, yeah.
So we have our QA samples. How do you use it effectively in your kind of application? Do you for every then subsequent call that's made, do you validate it against this QA? I'm just curious what do you use?
Well, yeah, this is where we go back to this idea of metrics-driven development. So we're using this to establish a baseline, and then if we want to swap out a vector store, if we want to swap out a retriever, if we want to swap something out of our system, we can say, oh, look, boss, it got better quantitatively, right?
Just have an example data so that you can just show.
Boom, that's it. It's our golden,
Generate your KPIs out of it.
That's it. You
It's
got
the
those
golden data
sweet,
set,
sweet
yeah.
KPIs. That's right.
What's a good amount of I guess questions you would establish as your set to test on? Is there like a good rule of thumb or?
I would say 1K. Like if you're being very serious, it's going to cost a lot to be clear. But I would say if you're very serious, 1,000 samples that contain a higher percentage of the more difficult evolved question types, if you're in a focused domain, is probably going to be good enough to get reasonable signal from. If you're in a very like generic space or domain, then that number is going to be much higher. But if you're say like in one corner of legal or one corner of medical, I think 1K is a good place to start. As well, what this is better at, even if you don't use all those samples, is you've at least generated questions, contexts, which you can, it's easier for human annotators to just answer questions based on context than it is for human annotators to come up with questions and context and answers. Just for a fun anecdote from a place that I work, there was a team of 8 people that were tasked to create a data set, and it took about 3 weeks to get 20 questions, right? Because it's an effort, it's a very effortful process, which is,
I bet that was some good data, though.
It was good data.
Yeah.
It was good data.
Because how many questions do you need? Well, it's like, I don't know. How many questions are you actually trying to answer? Is the person who has to answer that question today, how many questions do they need help answering? I mean, can your entire problem be solved by creating just an FAQ list and sending it to your customers? These are good questions, but if you want to do the more, engineering focused thing to get a whole domain. One last question.
I guess you could use this to generate, like even if you wanted to have a human validate something like this, this would be an easier way to do it because you can see
Yeah.
from their context, right?
Yeah, exactly. If we generate good questions, half the work is done, right? If we have human experts are very good at answering questions, right? There's no blank page problem to solve. Human experts are less good at coming up with really good questions and then answering them. So I think this is something you want to consider. As well as something you want to consider, we were just talking about LangSmith before the last breakout. LangSmith is going to leave you with a number of question and context pairs, right? And so again, we have more than one avenue to get to good data sets that represent how our users are using our application. But this is a great way to solve. I've just started. I don't have the users or the volume of users that I need yet. And I want to be able to make decisions that are backed by something quantitative. This is a great way that you can start that process and put fuel in the fire.
Yeah, we're going to keep it moving here. So given that context, let's see exactly how we can calculate these things, because this is where it gets kind of interesting. Of course, faithfulness is pretty clear. This is where we get back to the have a conversation with a real human being kind of thing. You want them to act like an astute child or like a good conversational partner. Here's the easy one. Is it hallucinating or not? Did it make stuff up, right? Question, where and when was Einstein born? They're still an early stage company. Their docs need a little bit of work like everybody else's. Albert Einstein born, context. Albert Einstein born date, was German born, and told to be the greatest and most influential. Okay, where and when was Einstein born? Einstein was born in Germany on the right date, high faithfulness. Einstein was born in Germany on the wrong date, low faithfulness. So what's the faithfulness there? Well, what we do is we say, break the generated answer into individual statements. Each statement is taken as true or false, and we're able to reproduce that statement in truth or not. So statement 1 is going to be Einstein was born in Germany. Statement 2 is Einstein was born in Germany 20th March 1879. Statement 1 is yes. Statement 2 is no. We calculate this as 50% faithful. Okay, very, very straightforward, very, very clear. This is a great one to start with. Everybody likes this word. You can say no more hallucinations, boss. Faithfulness 100%. Boom, you're going to get that sweet raise directly from that one. These are a little bit harder to explain to people, everything else basically besides faithfulness, but we can get it now that we understand what we have just been talking about. Answer relevancy is not about necessarily considering the factuality, but instead it penalizes where the answer lacks completeness. So this is like, say only stuff that's relevant and say all the stuff that's relevant, right? It's like, where's France and what's its capital? Oh, France is in Europe. It's like, bro, are you drunk? Are you listening? Right? And it's like, that's not what you want in a good conversational partner. That's not what you want in a high-performant LLM. You want it to be fully relevant, fully attendant. You want it to pay attention to everything that you're inputting, and you want it to respond accordingly. So, to sort of calculate this one, we sort of say, okay, the question, we sort of reverse engineer n variants of the question from the generated answer. And this is where, even within the eval, we have a bunch more LLM calls. So you could say sort of, in which part of Europe is France located? What is the geographical location of France within Europe? Can you identify the region of Europe where France is situated? All these different ways of saying the same thing. And then we say, okay, how did it perform on all of those? And we could say, okay, I'm going to calculate the mean cosine similarity between the generated questions and the actual questions. That's how I'm getting this metric. Okay, so it's like, okay, you think that's good? I'll leave it to you to decide. Cosine similarity, coming in hot. Again, our good friend, huh? Cosine similarity, we'll see you again. Context precision, right? The precision, we're very sort of comfortable with this. We're evaluating whether all of the ground truth relevant items are present in the context or not. Are they all there? Are we precise about them? Ideally, we have the most relevant chunks at the top, right? That's the best. And so this is computed using the questions and the contexts. And the idea here is that as we get into this context precision, we're essentially calculating the precision for each chunk in the retrieved context. We're checking, is that chunk there? Is that chunk there? Is that chunk there? Is that chunk relevant to the ground truth for the given question? If it's not relevant, I'm not counting it. We want, again, 100%. We want all chunks in the given context are relevant to the ground truth. Of course we do, right? So you sort of have this weird like front and back thing going on. Context. Now, recall. Yeah.
So is the precision a property of vector database?
I mean, I wish we could be so deterministic. You know, I think it's a property of the whole system that we built.
No,
You know.
if you are getting the top K, right? And out of top K, then you are choosing whether it's number 1, number 2, number 3, or it's out of the top 5.
Well, so one of the things we could sort of, is add another layer of complexity to this. One of the things that you could take easily off the shelf and do right after you build your RAG system is put a re-ranker on it. Cohere has one, local company, right? Just use Cohere re-rank on it. Like, why not? Well, because it's a little computationally expensive, but maybe it'll give you a better ranking, And so what you could do is you could say, I'm going to use this metric to see if Cohere's re-rank makes it higher or lower, for instance, right? So, I don't think we can be, too causal about exactly which part of the system that caused it or how we can, more generally make it a better performance. But this gives you one sort of insight. And you might look at context precision and context recall to sort of do this, right?
So get it like it's holistically you are calculating, not at an individual component level.
Trying to.
You could just run an experiment on that individual component if you really wanted to, and then do a plot.
Yeah, that's.
Yeah, I mean, ideally, you're not swapping out a bunch of parts at the same time. Yeah, right. So, here, where is France and where is it located, right? High context recall. Like, we want to make sure that everything we're returning in the context is relevant to the ground truth. If we have a bunch of extra sentences, right? This is the whole thing of like long context windows. I could put all my data from all time in there. Yeah, that could be cool, but it could also be not cool because a lot of it's not relevant at all. And so maybe this is a way to sort of help you get more dialed in terms of the stuff you're returning, stuff you're not returning. So, without beating this to death and make sure we leave plenty of time for LangGraph here, we saw a few. The context precision and the context recall, we could say those are associated more with retrieval in general, so dense vector retrieval, whereas the other one's associated more with that in-context learning piece, the generation piece. And so you could start to say, okay, well, if I want to improve my retriever, if I want to improve my ability to retrieve, maybe I'll focus on these two metrics versus the other two. And so we have, it's 3:15.
Yep.
And we've got a demo of this that we want to show you. But I will warn everybody that if you ask a ton of questions during the demo, we're going to rapidly approach running out of time. And you're going to be tempted to. But you guys want to see this demo? Yeah, okay, let's do it. And the whiz.
Yes.
With Ragus.
With Ragus. Okay, so this is the good stuff. I mean, it's all good stuff, to be honest with you. Ragus is great because it's easy to use for us, the developer. So there's not a lot to do with Ragus. Thanks, Ragus. So we're going to start, of course, at the repo. So we'll go to github.com. We'll go to our AI Makerspace repository, TMLS, OSS agents, and then we'll go to the Ragus. I should probably push that. Let's push it now. We're going to push it live. Okay, it's in there. We're good. So this is, you can see behind the scenes for a second here.
Deep in the well. You guys are with us now.
Yeah, this is life. And we'll head over here and we'll do a git add dot and we'll do a git commit releasing 0506. And then we'll do a git push.
That's how the sauce is made, people. I mean, like this.
And now everyone can see it. Okay, so if we refresh the page, the whole time it was there. That's crazy. Okay, so if we click on this, we can go to either the Colab or we can go, of course, to the local notebook. Ragus is very straightforward to use. Disclaimer right off the top, if you use Ragus with OpenAI's models, which is what we're going to have it set up to do, you're going to be charged like $3 if you don't change some of the parameters. I will tell you the parameters we can change to reduce that volume of requests. You also may hit rate limiting issues because we have to send a ton of calls to the LLM. We are going to use OpenAI for the SDG portion of this. So we're going to create the data with a very good model so we can test our less good model on data that we expect to be high quality. But again, it's going to be like $3, so just keep it in mind. Which, by the way, is a whole hour of 4 L4 GPUs, just for comparison. So what we're going to look at is a bunch of dependencies. Like always, we'll get Ragus, again, Quadrant, PyMu PDF. We're going to use some pandas even. You'll notice that for this OpenAI key, we actually are going to provide our OpenAI API key this time. So this is not secretly the Hugging Face token. We're also going to set up LangSmith because we can, and if we're going to pay $3 worth of API calls, you best believe I want to see every one of them, right? So we'll keep them. We'll enter our LangSmith key here, and then we'll move on. The first thing we're going to do is what we always do with RAG, which is create an index. We're going to go ahead and chunk all of our documents. The data science-y folks among you might think to yourself, hey, if we use the same chunk size to create our synthetic data that we use to build our RAG system, isn't that some kind of potential leakage of information if we use exactly the same chunk sizes? And yes, so we're going to use different chunk sizes. The basic idea here is that if we use the same chunks to generate our synthetic data that we're going to use in our RAG pipeline, we're going to bias our results because it's going to be able to retrieve exactly the right chunks. And though we do want it to achieve that goal, we don't want it to get there by cheating. So we'll go ahead and we'll generate some 500 big chunks this time, leaving us with 232 chunks total. We are using the Elon Musk complaint data again. Then we're going to go ahead and pass in our Hugging Face embedding URL. We are still going to use Hugging Face as the embedding model for this initial process. We're going to create the embedding model here. We're going to embed all of our documents, 32 at a time, create a retriever, and then we can retrieve some contexts. We love that. Okay. Now that we've done that, we are going to move to the synthetic test set generation. Again, big orange or red or whatever stop sign shaped things where it's going to cost a lot if you run this cell as is. So two things you can do to make it cheaper. You can replace the critic with GPT 3.5 Turbo. Also, you can reduce the number of QA pairs and you can reduce the number of documents we care about. So, if you want to do something very inexpensive, you can do like 2 here and you can do like 10 here, and that's going to be just fine. But we'll leave it in this state for now. So what is this doing, right? So Greg said a bunch of awesome stuff, talking about eval, talking about reasoning and multi-context and everything like that. And the way that we do that is by calling test set generator, and then we use generate with LangChain docs. Right? So all of that stuff sounds very complicated and interesting, but the way we actually implement it in the code couldn't be more straightforward. You'll notice that we have this distributions kind of object here, and all this is saying is we want to have 50% of our questions generated as simple. We want to have 40% of our questions generated as multi-context, and 10% generated as reasoning questions. That's all this is doing. It's letting us pick how we want to distribute the evolved questions, with simple being the simplest and multi-context being another evolved strategy and reasoning being yet another evolved strategy. So this is the idea. We can choose the proportions of questions that we have from each bucket. If we want to test one more than the other, this is very useful. We have a question here.
How would it apply to like organizational specific documentation or specialized context? I'm just confused how it would know that.
So it doesn't know. You'd have to set that up. So if you want specific context, we'd have to provide it specific contexts. Yeah. Yeah, all this is doing is it's just taking some nodes, and that's it. Those are going to be our ground truth contexts, from which we generate a seed question, then evolve the question.
The virtualized context.
Correct. Yes. 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 Exactly right. That's exactly right. Okay. So that's it, right? It sounded complicated, but in the code, couldn't be more straightforward. We love to see it. It couldn't be more straightforward or expensive, but we love to see it. And then we wind up with this. Question, context, ground truth, the evolve type, and the source. So we can look at an example of this. I think the session is still running. Yes, okay, so test set data 0. The question is, what rights does Microsoft have to OpenAI's pre-AGI technology? The contexts are regards. Microsoft's own researchers have publicly stated that, given the breadth and depth of GPT-4's capability, we believe that it could be reasonably viewed as an early yet still incomplete version of artificial general intelligence. Moreover, on information belief, OpenAI is currently developing a model known as Q-stars, even stronger. Microsoft only has rights to certain of OpenAI's pre-AGI technology. There you go. So this is the idea. This is the question that we used. This is the context that we used to generate the question. And that's how we get that original question context pair, right? However, you'll notice that we have, there's no answer here. We have our ground truth, and that's generated by the API, and that is Microsoft only has rights to certain of oh my goodness, sorry, I clicked the button. Rights to certain of OpenAI's pre-AGI technology. So this is the answer based on the question and the context, right? So this is what we're talking about. This is how we generate these things. First, we give context, then we generate this question, then we ask the LLM with this question and context to provide us with an answer, and that's our ground truth. Bob's your uncle, away we go. Okay, so how do we use this to actually evaluate? Well, what we're going to do first is we're going to just send them to a list. Then we're going to set up our RAG chain. Our RAG chain will be looking at this point probably a little bit tired, right? We've seen it a few times. It's our old friend. So we're going to set up our custom Hugging Face endpoint LLM. You'll notice this time, instead of directly overriding the environment variables, we are passing in the override for our endpoint or our base URL and our API key. We do this because we actually need to run both OpenAI and Hugging Face at the same time. We can't run both because they'll both depend on the same environment variable, so we have to do a specific override here, but it's exactly the same process as we saw before, just another way to do it. Then we're going to create new chunks, and these chunks are going to be a different size than the other chunks, right? Again, this is to make sure that we try to solve some potential issues that can arise from just using the same size chunks as we did before. We're going to use the OpenAI embeddings this time, so not our custom embeddings. The reason we're going to do this is because we're actually going to test a claim made by OpenAI. OpenAI said that text embedding 3 small should be as good or better than Ada in all circumstances, but also fast and cheap. So we're going to put it to the test with Ragus. We're going to first use the embedding model of text embedding Ada, which is their old and now more expensive embedding model. We'll embed all of our documents. We'll create a RAG prompt. We'll create a RAG chain. And then we'll have our RAG chain answer every one of those questions, right? So we generated the questions that live in this data frame. And now we're going to answer every single one of them with the newly created RAG chain. And that's going to be our answer. So remember how we had in the chart we were looking at question, context, answer, ground truth? The answer is really the response generated by our RAG chain. So it's not the ground truth response, but it is the response that we're looking to test. And so that's what we're going to pass in. We're going to go ahead and just shove that into a data set because that's how Ragus wants it. And then we're going to evaluate. We're going to evaluate across a number of metrics: faithfulness, answer relevancy, answer correctness, context recall, and context precision. These are all the things that Greg showed us in the slides. So that's why we're going to do them there. Our eval LLM, we're going to use a big beefy LLM, so we're going to use GPT-4o. It's fast, it's slightly cheaper than 3 GPT-4, and faster, cheaper. We'll just use it. Does a great job. So we have the our custom LLM plus the Ada embeddings for our first trial, and we get great scores. Faithfulness, very high, 0.97. Answer relevancy, very high. Context recall, also very high. Technically can't even be higher, right? That's 1.0. Context precision, pretty high. Answer correctness, not as high, we could say. And we can talk about why that is a little bit later if you want to hang around. But the idea is the LLM is getting some information. The information is relevant, but it might not be able to leverage it to give a correct answer according to GPT-4o. Okay, so we can look at the DF. We can look on the specific trials that it failed on or succeeded on. You get it. Then we're going to do the same thing, and the only thing we're going to change is the embedding model. We're going to use the text embedding 3 small embedding model instead of Ada. Everything else will be locked. And we're just running it again. It's not even marked down because we're just running it again straight up. Okay, so, and we can see we can get it all. So let's look at the comparison, right? So, to me it looks like faithfulness took a little bit of a hit. Answer relevancy, a little bit of a hit. Recall, same. Precision, a little bit better. Answer correctness, I wouldn't even categorize that as being better. The claim that OpenAI made, right, was that that text embedding small 3 was as good or better than Ada. With these numbers in front of us, I mean, that feels pretty true, considering the fact that it's significantly cheaper. I feel pretty good about using the text embedding 3 small model going forward for this particular application. And that's all Ragus is to the developer, right? The intuition behind it, all of the background to get there is a lot you can dig into. But using the tool is very straightforward. They did a great job implementing this library. Again, if you're running into rate limiting issues, please just reduce the parameters. So reduce the number of QA pairs you generate as well as the number of documents you're looking at. And if you want to be mindful of the $3, you can use GPT 3.5 to reduce some of that cost. And we'll head right back to Dr. Greg.
All right, so actually text embedding 3, it looked like, was more hallucinatory than, I think we'll not report that one to the boss. What do you guys think? How about we just pick and choose, like any good scientist, which evaluations we present?
I have a really quick question.
Really quick. Let's go.
So, when you're generating your ground truth, I guess the assumption there is that you have to use the best model possible because you're kind of hitting that's the ceiling of what you're comparing everything else to. Is that correct?
I feel 100% okay with saying that that's correct, yes. The better the model you use or process you use, because you can use humans here, to generate the ground truth, we can assume the better that ground truth is, and therefore all of those downstream comparisons should be more accurate, yes. Yep, and there are a lot of downstream comparisons. So.
Okay. And here we are. Let me get to the right slide here. Join our YouTube and community in the meantime. Hold, please. This is a slide deck that broke Canva, so we'll be sharing it with you. I doubt you'll ever want to use it because you'll run into everything we ran into today. Hold on.
Would these slides stay on Canva?
Oh yeah, 100%. These are yours to keep forever. Because after we present them, we can never present them in exactly the same form again. All right, here we are. We made it, guys. Okay, agents. Let's see. Ah, yes, our old friend that we met this morning. It's feeling so, it's feeling so much closer now, isn't it? We have the LLM. It needs to go through this reasoning loop. It needs to select tools. What's our loop again? Yes, let's remind ourselves. We're going to enter the loop. We're going to go to our agent. We're going to decide, should I take an action or do I know the answer? When we take the action, we'll generally be selecting a tool. It might be a tool from directly our RAG system, or it might be a tool that we want to get super up-to-date information on, like an internet search, DuckDuckGo, because it's cooler than SERP API. And we actually want to not just grab the tool, we want to use the tool. And when we use the tool, we want to get something out of it. We want to get some data out of it. We want to get some results out of it. We want to incorporate that into our message thread, our conversation thread we started when we entered, that we keep adding to each time as we go. And this loop will continue until we are done. This is the agents. And we are just, again, doing retrieval. And we're augmenting our generation with search and retrieval. Now, with LangGraph, the way to think about this is that agents with access to tools can solve problems. You can give it a problem. You can set it to work on solving it. That's pretty cool. There's lots of agent frameworks now. Well, not really lots, but there's a couple. Here's one that we covered recently in a YouTube Live event, Crew AI. And this actually might work out pretty well on this particular screen. Here are all the tools that you can get access to in Crew AI. The little yellow, for those of you with eyesight as bad as mine, just says RAG, 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 RAG. Now, I will put forth that this is not a coincidence. The other things that are not RAG, they say reading and processing, they say extracting data, they say scraping, they say scraping, they say extracting, they say searching. So we are solving the same old problem here. Search and retrieval. Is agents tools? Is it RAG? Is it the reasoning action pattern? Is it all of the above?
It's all of the above, Greg.
What do you guys think? What do you guys think agents is? And you can't take his answer. Anybody have an option? Anybody want to offer something to the group as a definition of agents? Functions. That's on here. Tools, function calling. Yeah.
The way I'm thinking about it is it uses a user input to make a decision on performing a subsequent action, rather than it being a predefined path that's been pre-programmed.
A user input to make a decision. Okay, all right. Try to say that to a stakeholder. Yeah. See, anybody else? Anybody want to get super meta with this? Yeah.
It's like Liam Neeson is a spy that has trained on very specific skill
set. Secret agent, man. Yeah, I like it. Okay, yeah, And a bot. A bot? A what? A reflection. Oh man. Oh, you're getting. I mean, we're starting to abstract here a little bit. You're talking about multiple agents now. The system ones. Let's not even go there right now. I don't think we have bandwidth for all of that this afternoon. Reflection is one type of agentic. Yeah, sure. Anybody else want to offer anything?
So it works for a goal that it needs to achieve, and it will use reasoning, going through tools, and getting the answers, making sure it has enough data before it replies, or before it gives the output to the user. So it works on a common goal.
I like that. And actually, that's pretty much how I think a lot of the tools that are being built kind of define agents, which is really cool. I want to offer a couple other older ideas on agents that'll kind of hopefully get you guys out of this this is an important box to stay in as developers and as people that are practitioners that really want to use these tools. But we can get super meta for a minute. So like, I don't know why the screenshots aren't working. It happens when you're at 500 slides on Canva or something. But this is from Stephen Wolfram and from a Lex Friedman podcast. And this idea that we can use very, very simple rules, very simple prompts, and get extremely complex behavior, this is a very powerful pattern. And in fact, I think it is this pattern that's going to lead to some really incredible things being built in the coming years. And I think you guys are going to be amongst the people that are building them the soonest. In fact, I know you are, because you're still here at the end of the day. And many of you are already building these tools. And there's not that many people in the world doing this, by the way. TMLS is sort of a very niche summit, a very niche place to be. And, we can even expand the frame more. Agents as neurons in a brain, agents as companies in an entire economy, agents as cells in a body. Agents are not a new idea. Again, it's a poverty of language that we're stuck with. We have to keep reusing these words in AI. And one of the things that we will see emerge from the use of agents and agentic tools is complexity. Not complicatedness, but true complexity. And it's going to be a really exciting 21st century with agents and with AI to see exactly how this comes to pass. And one of the tools that's going to help lead the way is LangGraph. Here we are. So LangGraph is, I think, really a great meta of everything that we've done today so far. Now, this is the line, right? Build coordinated multi-actor and stateful applications. Also, don't say that to a stakeholder. But it is true, and we have to understand why. Agents with access to tools can solve problems. LangGraph lets us add cycles to things that we built with LangChain. Harrison, the CEO, Harrison Chase, gave a TED Talk on the cognitive architectures. These are important for you guys to know. The first one, you're all too familiar with today. The classic, the original gangster, the OpenAI API call, right? Boom. ChatGPT. We can chain these things together. Some of you have talked to me today about applications you're building that are actually doing similar things to this, chaining things together. And that's obviously the next layer of complexity. What you can do is you can also, when we start to talk about specific agent structures, or we start to talk about multi-agent systems, a lot of times you'll see routers used, and router is exactly what it sounds like. I got this problem, who should I send it to, right? Middle managers as routers. And then we have, sort of full autonomy as well, which is like you pump it into the system, and the system auto-magically gets you back what you need. That's cool. But cooler would be somewhere in between router and full autonomy. That gives you more control than full autonomy, but is more sophisticated than a router. And this is where we meet our good friend, the state machine. And in fact, all we're doing in LangGraph is we're tracking state. That's all we're ever doing, is how was it? How is it? What's going on? And if we can build the flow chart, we can build the application, right? So, kind of tongue-in-cheek, you can tell this to people. State machines is what people called agents last year, okay, right? But the reality is that most of the time, when that happens, send it to a real human, please. Enterprise needs that. They don't want this full autonomy, no. They're like, no. How about that? How about if anything goes wrong at all, and I'm going to define what wrong means, you put it in the hands of somebody that we can trust with our customers, right? So the state machine is much more flexible, much more useful than the fully autonomous agent. And LangGraph is a way to build these state machines by specifying them as graphs. So what's the point of a graph? Well, again, we already talked about it. If you can draw it, you can do it. Now, anybody heard of a DAG? You heard of a DAG, directed acyclic graph, right? Well, this is a directed cyclic graph. DCAG until somebody corrects us, okay? We're going to just call it whatever we want. Nobody has, I'm not going to call it a DCG. I'm not going to be that guy. You can be that guy or girl if you want. But it's cyclic, right? It's in a loop. It's an agent, man, right? And so if we can draw it, we can build it. We're going to build it with a graph. What is a graph? Well, you guys know what a graph is. You got nodes, you got edges. It's a flow chart, right? Now, in the nodes, right, a single node, there's our good friend, the LangChain LCEL runnable. It could be a simple Python function. You could put anything you want in one of these nodes. And in fact, we talked about, what was it? Idiotic or not idiotic question function, right? Put that one in there. Put anything you want. If you can draw the flow chart, you can build it, right? And when we think of edges, we can think of paths to take, or where to pass our state object as it's collecting the next information about state next and next and next and next. So LangGraph says basically, hey, here's the state graph. Define it, keep track of it. Update it as you go. As you move through each node along each edge, do the thing, and then update the graph. So we want to build our graph by specifying the state graph, by adding nodes, then by adding edges. The first edge, how about the starting point? That'd be a good one to add. And then we could add some conditional edges, and then we could add, finally, our close the loop edges. And of course, here we are, closing the loop. So satisfying. Here we are back at where we almost started today. We'll continue to close the loop on the Sessionino as we go. But these are looking quite similar to me now. And in fact, one came before, betwixt, and between the other. The chat agent executor is representing the internal state as what? As a list of messages. Back to the OpenAI API. What's that list of messages? It's the same exact one that was created. It's a conversation thread that we're updating along the way. So the conversation is sort of the state. And as we can see, we have, again, prompting. We have the conversation thread adding to the prompt. We have the retrieval, augmented generation. We have search. We have a fine-tuned model for function calling. We have an LLM call each time. And so here we are back again. As goes retrieval and search, so goes generation. And this, my friends, is basically where we are just about ready to wrap up the content. But first, we need to actually see if this state machine is as easy as it sounds, or if it's actually a lot harder. Wiz, take us home.
Oh yeah. Okay, so it is as easy as it sounds. I'm not biased. It's true. Honestly, through the time that we've been lucky enough to be, teaching people about this kind of stuff, I think LangGraph does a great job of helping kind of crystallize what the heck we've been doing the whole time. And one of the reasons is because it is a flow chart. That's what we're building, right? Everyone kind of knows a flow chart. You might not know a graph by the name graph, but you got the idea. You're at one place, you go to the next place. You're at one place, you get some information, and that makes you decide to go left instead of right. Right, so this is all LangGraph is doing. Okay, so first of all, why cycles? Cycles are really important in order to provide that behavior that we want, which is the LLM, right, or the agent, or whatever node that we're talking about, should be able to make some determination about the doneness of the request that you give to it, right? So with just RAG, we ask a question and we get a response. That's it. Information flows in one direction. But if it doesn't fully answer the question, then you have to input more things, right? The human has to say, oh, well, actually that doesn't answer my question, right? I need more information. So what cycles help us do is they help us build in the functionality that the LLM gets to dictate relative, doneness, however you're going to define that. So that's why cycles are so important. So what is LangGraph? It allows us to build, graphs that have cycles in them. So like if you're used to things like MLflow, built on top of DAGs, they are a very useful tool for a lot of application flow, for a lot of the way that we want to think about things, but they're not so useful when we want to have this system that can repeat itself or move back through cycles. There's no limit to the kinds of cycles you can have, except that you must have an entry point and you must have an exit point. So the graph does have to be enterable and exitable. If it's not, you've just built an infinite loop in extra steps, right? So we're going to grab a bunch of dependencies again, some old favorites, some new ones with LangGraph, archive, and this very specific version of DuckDuckGo search to avoid weird rate limiting issues. Okay, we're also going to grab PyMove PDF, Quadrant Client, and LangChain Quadrant. Easy enough. We're going to provide our OpenAI key for real this time. We're going to be using OpenAI as the quote-unquote brain of the operation today. You can use the open source model that we've selected, but your mileage may vary depending on the complexity of your asks. So what we're going to do is use OpenAI as the brain. The important things that you need to be true for this to work is that you must use an LLM that is capable of function calling. So you can use Claude 3 Sonnet, you can use OpenAI's models, you can use the open source model we developed today, which does support function calling, but that is a requirement of the steps that we're going to follow for the rest of the notebook. Just keep that in mind. Yeah, what's up?
Certain models have noticed that function calling is not quite readily available, especially for Mistral.
Yeah.
And I saw some people cleverly research this, starting selling these data sets that enable this.
Yeah.
Worth it or?
Yeah, worth it's a hard question to answer generically, but what I would say is that fine-tuning for instruction following is great. Fine-tuning for function calling is great. Fine-tuning for JSON mode is great. I don't know how to generically answer the question worth it, but we do need to fine-tune, and we do need a data set to do that. And those data sets are not the easiest to come across or to create synthetically. So it can be worth it, certainly, but we need the functionality, right, of function calling in order to use this implementation of LangGraph. Now, you can use any implementation that you'd like, and many of them don't require function calling. However, function calling and agents in 2024 go together like, two things that go together. So when it comes to setting things up, this is your real OpenAI key. Significantly less usage than what we saw from the synthetic data generation. This is, in the tens of calls over the course of many runs of the tool. We're also going to set up tracing, right? Because again, why not set up tracing? If we can, if it's this easy, if that's all we need to do in order to get traces, to see what happened, to look at what is going on, to see individual costs, how much we're hitting certain models, let's just do it, right? So we set it up because we want to. Again, we're going to use that same data that we used before, the PDF from Elon. It's just what we've been doing. We're going to use a chunk size of 500 because why not? We're going to use our Hugging Face embedding model, and then we're going to use our Hugging Face token for our embeddings. Now you might notice, hang on a second, are we just building that same RAG pipeline again? And you'd be 100% right, that's what we're doing. And you might right now have the question of why, but we'll be answering that for you in a second. We're going to set up a retriever after we bed all of the chunks that we make from our complaint. Then we're going to make a RAG prompt. Then we're going to provide our Hugging Face LLM URL. Then we're going to create an OpenAI chat model version of it so that we can interact with it through the OpenAI Python or LangChain class. And then we're going to create a very simple RAG chain. There's one key difference with this RAG chain that wasn't true in the other, and that is we are not returning context as part of the chain. Because we're using LangSmith, we still have visibility into the context. So we're not losing the sourcing, but we're not including it as part of the output. This is just to very slightly simplify the chain. But you can see here we pass in some input blob. We're going to get the question for our context, so we can pass it to our retriever, and then we're just going to grab the question and then feed that into the RAG prompt, which gets fed into the Hugging Face model, which gets fed into a string output parser. All the string output parser does is it outputs the parser to be a string. Set it, in a different order. Okay. And now we're going to create a tool. So this is why we're setting up our open source Hugging Face RAG pipeline again. We're going to actually leverage this as a potential tool in our LangGraph agent. So what this means is that this tool is going to be part of our system's tool belt. It's going to be one of the options. What we're going to see here is a couple things that are weirdly important, despite not being that important in other situations. That is, number one, this annotated, so this is Python's type annotation, right? It's not real. Python doesn't actually care about this. It's like suggestions, right? Python is not strongly typed, and as much as we try to make it strongly typed, it's not. But what that does is it gives us the ability to communicate to the LLM when it goes to try to use this tool, how this tool should be called, right? Because what is happening with function calling is we're asking the LLM to call a function that we have. And what that means is we need an input to that function. And even though Python doesn't care about types, right, we still need to have a string to pass in as input. Without that string, we can't use our RAG pipeline, right? So the idea is that this looks like code that we've constructed in a decent manner because we're following good code principle, right? We like clean code that has that's well documented, but really this is useful for the LLM. This is what the LLM will see of our function so that it can call it correctly. So you'll also notice that we have the doc string for this function. And again, that's not for us. That's a prompt to the LLM, right? It defines used to answer questions about the Elon Musk complaint against OpenAI. So that's what the LLM will use to determine when this is the right tool. So it's not just a doc string to help people who are working on this code. It's a prompt for the LLM. And this is when you get into this level of making these systems, you begin to realize very quickly that we're not just writing code anymore. We're also writing prompts, right? So even the coding that we're doing we have to be mindful of how it interacts with the LLM. So it looks kind of like throwaway. Oh, it's just a doc string. Like we should make it good so people can understand. It's got to be clear because the LLM uses that to make decisions, right? So I won't harp on it any longer, but that's the idea. Then we're going to create a tool belt. We're going to go ahead and we're going to fill our tool belt with DuckDuckGo search, archive, query run, and retrieve information, which is our RAG tool that we just defined above, this one here. What this is going to do is it's going to give the LLM access to 3 tools that it can use, right? DuckDuckGo search, aka kind of like Google search, right? Archive query run, which queries archive for papers and abstracts, and then retrieve information, which can be used to answer questions about the Elon Musk complaint against OpenAI. Now you might say, well, where's the prompts here? We can look into the implementation and see that indeed, the same as our tool, these tools have doc strings that are prompts that help the LLM determine when it should be used, right? So hopefully that's pretty clear, and we'll stop harping on it so much, but it's so important, right? We're writing prompts at the same time that we're writing code. Very cool stuff. So we have functions that we want the LLM to call, right? But it doesn't have the functions, of course. We can't just send it a function and assume that its environment is set up in such a way that it can properly execute this code. So we need to run the function on our end. But now we need a system that can take some response from an LLM and then run the Python function, and that's all the tool executor does. It is going to execute our functions given the input parameters that the LLM sends us. So we have our tool belt, and then we have the thing that can actually run the tools, right? Because we do have to execute functions while we're in that loop. Okay, Model, all this is saying is, hey, you got to use something that supports function calling. So we're going to use GPT 4.0. It's cheap, it's fast. You love it. Then we're going to convert through LangChain our tools into OpenAI functions. All this does is basically it unwraps those doc strings and those type annotations into a format that is more familiar to us as a prompt. It used to be that you had to do all of this work and you have to use things like Pydantic in order to make sure that the types lined up, but now we can be very lazy about it, and isn't that great? Okay, so we've got tools, we've got the thing that can call tools, and we've converted those tools into prompts. Okay, feeling good about it so far. Now we get to the coordinated multi-actor and stateful application. So what is state? For us, state looks like a dictionary with key messages and value empty list. So for us, the state is going to represent all previous parts of the conversation that we've had with the LLM, from our initial input to any of its responses. So that's, in this case, that's all state needs to be, right? With this, we're going to be able to build the entire agentic flow. We don't need anything else in our state. That being said, we can certainly make state as complex as we need it to be. We can have it track things. We can have it, exit early. We can do all kinds of very fun things with state, but we're just going to keep it simple. The idea is, right, that state is this box that gets passed around our graph. Every time a node gets state, it's going to look at that state, it's going to do something, and then it's going to modify or not modify that state. That's the entirety of LangGraph, right? Just passing around that little state box and making changes to it and then passing it to the next guy. Then opening it, seeing what's in there, saying, oh, this has got to go to this node, or this has got to go to this node. That's all that's happening, right? So how do we set up the state in code? We're just going to use a type dict. We're going to call it agent state. We're going to make an annotated list. And we're going to give it this add messages operator. Add messages operator lets us simply add messages. We can use a set operator here, but we want the state to grow every time we feed it a new message. So we use add messages. All that's going to do is whenever we feed our state a new message, it's going to be appended to the list of messages, and that's it. Technically, it'll be it'll be appended. Yeah. So the idea is it'll just be an ever-growing list of messages that tracks the historic conversation we've had with the LLM. And that's all the context that it will need, and we'll see how we use that state in just a second. Greg's already talked to us about graphs. We've represented it with these dots here. Okay, so what is a node? A node is a runnable or a Python function. A node accepts state and it returns a modification to state. That's it. So all the node does is it gets that box that we're calling state, right? Does something, and then it makes a change to what's in the box, and then it passes it to the next guy. So the nodes take in state, we've called it state so it could be clear. It looks at that state for the messages that are there. It invokes the model on all of those messages up to that point. And then it returns that response as an addition to the messages in that state, right? So what we've done is we've taken in a list of, say, 3 messages. We've fed that to the LLM, which has generated a response. We add that response to the list of messages, and now we have state with 4 messages, and we pass it to the next node. That's all we're doing. We also have a slightly more complicated node, which is the call tool node. Now, the call tool node is going to look at the last message. You'll see when we look at the graph, right, that this is set up such that the last node in state will always be from our LLM, from our agent node. And so what we're going to do is look at the last message. If that last message has a function that needs calling, we're going to go ahead and we're going to call the function, right? So all we do is we look at the last piece of state. We say, hey, there's a function that needs to be called. I'm going to go ahead and I'm going to invoke my tool using the name of the tool and the arguments that should be used to call that tool. the name of the function, and then the parameters, the input parameters to that function. We're going to get that response by invoking the executor. Remember, all the tool executor does is run code, just runs that Python code, runs that tool function, right? Then we're going to create a function message, which is a special kind of message that means something to the API. And we're going to then append that, of course, to state. The reason we need to do this is that for a function calling API, when the LLM requests a function be called, the next thing it's expecting is going to include the response of the function that it said to call. So that's why we have this pattern here. Basically, it's like, hey, I'm going to need you to run this function and then tell me what it was, right? So we run the function, and then we tell the LLM what the response was, so it can use that as context so that it can make new generations that may or may not include more function calls. What's up?
Yes, you're saying that it's appending it to the kind of set of state.
Yeah.
Does the actual appending happen there? Like,
Yeah, that's right. So this is thanks to our add messages operator. Whenever we return the messages key, it's just going to append the contents of that messages key to the existing list. So if we used the set operator here, what would happen is every time that we did this, it would overwrite our state with whatever we returned. But because we're using the add operator, it's going to append the contents of messages to that existing list. Great question. Yeah. Yeah. Okay, so now we have two nodes. We have node that makes decision. Do I use tool or do I not use tool? It generates text. And then we have a node that calls tools on our end and sends that response back to the LLM, right? Okay, cool. So let's build our graph. We can start very easily by just making a state graph with agent state, then adding nodes to it. So right now, this is what our graph looks like. Useless, right? It's just two floating blobs. What's it doing? So we're going to add an entry point. We're going to enter at our agent, right? Because if we wanted to enter at the action node, which is our tool calling node, we would need to have some kind of function to call. But we're not going to start that, right? We're going to start by querying the LLM. So we add the input or the entry point to our agent node, which is just our base node. Then we're going to create a conditional edge. Sounds fancy, but all it is it's a map that is going to look at state and then make a determination of which node it should go to. So in this case, we're going to have should continue. It's going to look at the last value in state. If there's a function call that's in that last message, so if the LLM response from the agent node says, hey, you should call a function, then we're going to go to the action node. If there's not, then we're done, right? If we don't need to call a function, we've done the job. So that's all this does. And we can see it more expressly as a map here, where we go from agent through should continue, and we'll either go, if the output of should continue is continue, we'll go to action, and if it's end, we'll go to the end node. The end node is just the terminal node. It's the exit point of the graph. And so this is what we have now. Okay, cool. But, we can get stuck. If we need to do an action, and we get to this node right now, we just stop, right? And the program would hang. We'd just be left without anywhere to go. So what we're going to do is we're going to connect action to agent. It is one direction, right? It goes from action to agent. And now you can see that we've got a cycle, right? We can go from agent to should continue to action back to agent. And this is the idea of those cycles. However, the thing that's going to decide, quote unquote, if we continue or not will be the LLM by determining if we need to call a function or if we don't need to call a function. And so this is that idea of the LLM deciding if we're going to do more cycles or not. So let's look at some examples to see how this works. We're just going to compile it because it's got a compile. This is checking to make sure that we have a valid graph, right? You can see if we didn't connect those last two edges, we wouldn't have a valid graph. If we didn't have an entry point, we wouldn't have a valid graph. So we compile just to make sure that everything passes the sniff test. Okay, and then we have a helper function to print stuff out. And then we can ask the agent things. So what we're going to do is we're going to ask it about what is the Elon Musk complaint against OpenAI about. We invoke it on those inputs. Notice that the input, right, it looks an awful lot like our state. And by it looks an awful lot like our state, I mean it is our state, right? So we kick things off with state. And then we can see it does a function call. It's going to go to the retrieve information, which is our Hugging Face open source RAG. It's going to receive a response. It's going to then give us that final response. It only does one cycle as it determines it has enough information. So we don't do another tool call. Let's look at another example. Did Elon Musk ever beef with Mark Zuckerberg? Was there ever a legal complaint filed by Elon Musk? Use all your tools to answer these questions. In this case, you can see, first of all, the agent is going to determine if there was Elon Musk, Mark Zuckerberg feud. It's going to ask DuckDuckGo for that. And then it's going to get information about that. However, we've only kind of half answered the question, right? Because the agent gets the entire conversation history, it now has the initial query, which has basically 2 subqueries, right? It can see, oh, I've got information that answers one of those, but I haven't answered the other one yet. I need to make another tool call, so it's going to go back to the retriever, and it's going to, in this case, sorry, it's going to go to DuckDuckGo, and then it's going to answer the second part of the question. So what we wind up with is 3 tool calls, one to DuckDuckGo, one to retrieve information, and then another to DuckDuckGo. So the idea here is that even though this is the same graph that we used for the first question, where we did no cycles, basically, right? Or like what kind of one, I guess you would say, cycle. In this case, the agent, without us, asking it to, completed 3 cycles through the graph. And this is the power of LangGraph, right? It's able to dynamically determine when it should stop. So we're going to very quickly look at how we can evaluate this with LangSmith now. So we have to convert our inputs and our outputs. As we know, right now we input and output state. However, LangSmith expects us to input and output strings. So we build a wrapper for that. And because we're in LCL, and because our entire LangGraph is an LCL runnable, we can just straight up chain it with this Python function that converts our query into state. And then we can chain it into a parse output function that converts our state into a string, right? Because not only can every node in LangGraph be a runnable, but every graph in LangGraph is itself a runnable, right? Very, very useful thing about this framework. And then we can ask questions like, what is QLoRa? And we can get responses, and we love that. Then we can create a bunch of questions about QLoRa, and we can create a bunch of answers for these questions called must mention. We can build our LangSmith client, create a data set on that client, create examples on that data set on that client, and then we can use custom evaluators like must mention, right? This is just exact match. So it's just saying, does the response that I have contain the keywords that I expected it to contain? Right? A very basic evaluation, but can be useful. There is a flaw in this that we would typically ask you guys to figure out, but for now, we'll just tell you this is case insensitive or case sensitive. So it will tell you you're wrong if the cases are different, which is terrible, but that's okay. We're also going to use some of the evaluators that Greg talked about a little while ago, the criteria, aka helpfulness, and then the chain of thought QA, which is what it sounds like. To evaluate this, we simply run on dataset and we give it our agent chain. Our agent chain is simply our LangGraph runnable wrapped in the string input output. That's it. We run it, we get results, we're happy about the results. And then finally, one more thing. I know we're just going, right? But one more thing, we're going to add a helpfulness check. So yes, right now, we've done a great job. The agent should keep going until it fully answers the questions. That's great. But now we're also going to add a check to see if the response was helpful. So the way we do that is we build a new node called check helpfulness. That node contains a chain. That chain is a simple LLM as a judge prompt that determines if it's helpful or not. If we are helpful, then we go to the end node. If we're not helpful, we go to continue. And then we recreate our graph with that same information. An exercise for you guys, if you should want to, is to explain what each of these are doing, just as like a practice. If you want to sanity check yourself, could be fun. Or you don't have to, you can just run the code. And the idea is we add one more conditional edge, and that conditional edge is going to check helpfulness. If the response is helpful, then we're going to the end. If not, we're going back to the agent, right? Hey, we got to try again. This is not helpful, okay? And that's it. And then we can run it, and we see that it's helpful, and we're very happy about that. And there you go. And just one last thing I will show you. In LangSmith, for that evaluation that we did, we can actually look at that evaluation by going to our data sets, clicking on that evaluation data set, and seeing that we answered those questions that we set up in our notebook. And we can look into each of them to see how contextually accurate they were, how helpful they were, and if they contained the required keywords. So that is a lot, but that is LangGraph. With that, I will send you guys back to Greg, Dr. Greg.
All right, folks, that is why we call him the LLM wizard, okay? My main man right here is the Wiz. And all of you, after joining us today, are wizards in your own right. We have a few of you that we'd like to also especially highlight today. But first, it is time for our wrap. What have we learned today exactly about prototyping and about LLM production grade applications? Well, we've learned many things of the patterns that will help us get there. We've learned about fine-tuning, about RAG, about agents. We've learned how to answer questions simply that vex far too many of us out there. And we'll probably get asked at this very conference many a time, am I right? And then you can answer the question. Because the answer's simple, really. Yes, of course, you should. Because we need all of the patterns when we're doing LLM application building. We need prompt engineering. We need to optimize what we put into context. We need to optimize the behavior of the way our LLM acts. Oftentimes, we want it to be specialized to do specific things instead of general things. We need both of these tools in our tool belt and also the patterns of actually using tools in our tool belts. The patterns of reasoning and action, the pattern of if this, then that. These are all patterns at the end of the day. From prompt engineering to fine-tuning to RAG to agents. We've learned quite a bit. Are agents just tools? Are they just fancy RAG? Are they just the reasoning action pattern? Do they actually have each of the other patterns nested within inside? Well, I don't know. Let's zoom in. How about the RAG box? Looks like this, right? How about the prompted engineered box? Looks like this. We might need all of these things. In fact, we will need them all to get to that sweet, sweet human level performance, get this thing deployed to prod, and in the hands of customers, making that sweet, sweet ROI for you as individuals and for your company. That's practical education. We told you by the end of the session we'd give you a feel for these things. We hope we have. We told you by the end of the session we were going to turn your brain into a chair. We hope we have. And we have one ask and one tell that we'd like to end on. Please do follow our journey so we can follow yours. We'd love to have you on Discord, and I know many of you have already joined. We look forward to seeing you there. There's one last thing. We've been building and shipping all day. It's time to share, everybody. Okay, so I am excited to share with you that we have some people in the audience today that are ready to share. Oh my God, who's it going to be? And let's see who's going to go first, okay? Some of you might not be surprised about some of these people, but I want to start, actually, with my man up front. I believe you told us you've never hit an API. What did you say to me earlier?
Well, not like with the...
Not with an LLM.
Yeah, no.
Okay, why don't you bring your laptop up and show everybody what you've been able to build today, my friend.
Yeah, this is like it's like those...
First of all, let's go ahead and just do mic check, 1 2 1 2. Can we get your name, my dude?
Hey guys, name's Brian. Pleasure to meet you all.
And what do you do, Brian?
I'm just a student right now.
All right.
I'm doing my master's in CS.
Woo! Give it up for Brian. Not just learning, but building, shipping, and sharing. Why don't we get you plugged in here? Make sure you're ready to rock and roll. Let's see what Brian learned today.
Yeah, let's check it out.
Let's check it out indeed.
Is it working? Oh, good. Yeah, so this is a project I just made. I called it Mass Debater. Basically, I was always interested in how one AI agent interacts with another. I always thought that kind of concept was interesting. So with this introduction, I didn't even know what RAG stood for before, so their notebook was very helpful. Everything you see here, I just basically copy-pasted and modified from...
Can you increase zoom on that, Brian?
Oh, sorry.
We gotta be sharing like legends here.
Yeah. How do I do that?
Command plus
Command
or
plus.
Control plus.
All right.
And then the incessant scrolling up and down, we're gonna get Brian sharing like a legend in no time.
Yeah.
It's very distracting, so you can just go nice and slow for us.
Yeah, so I just used the LCEL notebook, and I just took the embedding dictionary and how you loaded the documents. And then I just went on, basically my debate here was cats versus dogs. So one agent argues in favor of cats, one agent argues in favor of dogs. And basically all I did was, unfortunately Reddit's API is no longer free, but I found this website which converts a Reddit thread to Markdown. So I just did that.
Manual retrieval, very nice, yeah. Brian.
So it's not a lot of data, but it's enough to do something with. So yeah, I have a pro cats thread and a pro dogs thread. You know, 2 different camps. Yeah, and so I made 2 embedding models. I don't know if I have to do that, but do I?
It doesn't matter. Let's get to the output here.
All right. Yeah, so I was already running it. I ran it for 10 iterations, so they'll do 10 back and forths, basically. Let's just see what happens. Okay, cats or dogs? Oh, that was fast.
Cats or dogs, people?
Dogs.
Yeah. Yeah, so I won't...
Sounds like we're pretty split. This is a tough one. What does the AI tell us? How long are we going to have to wait on this, Brian?
Basically, they just argue back and forth with the content from the embedding. When I was debugging with... Sorry, what's your name?
Todd LLM.
Todd LLM. Because my token... I was using too many tokens for input. But basically, I hope to see the same result, but what was interesting was near the end, like, they were just agreeing with each other.
Oh, what a classic!
Yeah, see, I'm glad to be discussing the merits of cats and dogs. Well, both animals have unique traits and blah, blah, blah.
The vanilla no answer at the end with the agents. Brian, this is fantastic work. What do you guys think of Brian's work here? Cats versus dogs, let's go. My man, you built, shipped, and shared your first RAG system, baby.
Oh,
That
nice.
is for you.
I appreciate it.
And you are officially an LLM wizard. We are going to make these stickers a little bit easier to take off in the future. Let me just get that going. Oh, boom, baby. Let's go. Round of applause for Brian. Round of applause for Brian. And we've got one more special guest. I don't think anybody's surprised today. Are we ready? Are we ready? All right, we're ready. We've got one more special guest from the front, one more from the back. And can we meet you again today? What is your name, your occupation? Where do you hail from?
My name is Dina, and I want to say that you guys might find it funny. I think by January, I don't think I knew how to code in Python.
Oh, let's go, Dina!
I used to be a partner in a large consulting firm.
Oh!
So I led a big AI team, but I was just the talking head. So I was like, screw that, I need to know what the hell they're doing.
Yes!
And now I'm a CTO on a startup.
Oh, yeah. You go ahead and
Getting
keep that
there,
mic.
getting
Let's
there,
go ahead
getting
and plug
there.
you in.
So have mercy on me. That's all
CTO,
I'm
we knew
trying
she
to
was
say.
a killer when she walked in and started engaging. We all knew. Okay, show us what
I
you
used to
built
talk for a
today.
living. No, so this is, I don't want to show you my day job. So actually, I'm in cybersecurity, but I just took what we've done today exactly as is, pretty much. I didn't want to show you the other because the stuff I work on are like log files. But I basically just the context. Just taking the context from the Biden debate, and I asked it, how did Joe Biden do? And it gave me a very nice response, weak and raspy voice, poor guy. So we had that, and the rest, and you can see here the chunking of the context on that, and then I think I had a question around how did Trump do. So again, more how old is Biden? So I think we can run that to see if it works. So that's like the size of the vector. So here I kind of ask about debate performance, and you see, about his biggest fear. He's 81 years old, so you kind of replied nicely. Like basically, and again, how did Trump do? And it gave me a big response in that, it mentioned that Trump continued to fuel, depending on where you sit. I don't want to get in trouble. Sure. I work for an American company, and I have people with very strong opinions. As I mentioned, I'm actually in cybersecurity, so I do a lot of AI and cybersecurity. I pulled from my drive just a simple paper. It's not a simple paper. It's a paper on application of GenAI in cybersecurity. I went through all of the good stuff in terms of like embedding, vectorization of that, and and I kind of use the same approach. You guys take a long time explaining stuff, but I love you still. And then I said, here's the question. If I had more time, somehow the file kept rewriting itself with the existing content. I could have done like a chat bot where we can chat to ask a question about cyber and maybe teach you all about cyber while we're at it. But then the question here is, how does GenAI apply? This is for someone who did not do Python 6 months ago. How did GenAI apply to cybersecurity? And then it gave us a very nice answer based on the document. It's not the best answer. I think it would have been better if I added the context to say you are a very helpful engineer, you need to give us as much detail as possible. so that would have helped. And then you can see here all the context, the stuff it pulled from the document, from that PDF. So it's actually pretty, like it's a very simple code. And then I asked, what's my name? And then it said, well, I don't know your name, go fish. So
0 to Python hero in 6 months. It's a very simple code. Let's go.